Okay, well, good morning, everyone, and welcome to VirtuEARL. My name is Richard Pugh. I'm Chief Data Scientist and co-founder of Mango Solutions, and I'd like to welcome you to this this online event. So if you've not been to an EARL conference before, it doesn't usually look like this. EARL has been running for many, many years now, and we usually have EARL in the Tower Hotel in London, or in Boston, or in Seattle, or LA. And right now we should be, we should be sitting there waiting in that big room for the keynote speakers, and they should be running around in the background wondering where the keynote speaker is, and so on. And obviously that's not happening this year because of COVID. So it was actually Laura that came up with the idea of having a virtual day. So yeah, again, as before, Laura and Liz in the background have organized all of this, and I just get to turn up and say a couple of words at the start. So welcome to the event. In terms of, so let's say I work for a company called Mango Solutions. So just if you've not heard of Mango or come across Mango, so we run the and organize the EARL events. We're a data science consultancy. We've been in business for about 18 years now. And really, we believe that data and analytics has the potential to generate significant commercial impact. And so we very much take a pragmatic approach to helping organizations embed data science and generate value that way. And we are absolutely founded on R. We've been in business now for 18 years, and really we grew up around R, and the entire company is based on it. And yes, there's some we have Python skill and PySpark skill and so on, but we're still R at heart. And so the sort of things we get involved in are things like R training services and consulting services, validated builds of R. We were the first R Studio partners. We were the founding members of the R consortium with Microsoft and Google and RStudio and so on, and so on. So we really kind of live and breathe R, and so EARL is a lovely celebration for us and a lovely moment to discuss the thing we love, which is in particular the application of R into a commercial setting, and that's really where our focus is. If you've not come across the R consortium, by the way, we're really proud to be members of the R consortium, and it's really a great organization that does an awful lot for the R community, and in particular the adoption of R in the commercial sector. And they sponsor some really important and vital projects and initiatives around the world. So if you want to know more about the R consortium, please go and see the R consortium website, r-consortium.org. And even consider, you're becoming members. If your organization is heavily using R, then this is a good organization to get involved in. Okay, so I thought we'd start the day just talking a little bit about, I guess, one thing, which is a recent survey. So as part of our work in the R world, we send out surveys and we do a lot of research around the uses and adoption of R in the commercial world. And I guess we still have this trend that we've seen over and over again, which is that we're still in a situation where there are restrictions to actually being able to access and use R in the commercial world still. We sent this out, we had 300 respondents, and just over half responded that there are still restrictions and concerns about the use of open source in their organization. I would probably say that the bias in the respondents is towards government and pharmaceutics and finance and areas like that. So where there is regulatory aspects and compliance to be considered, but we're still in the situation, I think, where it's not a given that people are going to just be able to use R day to day. And I think that of the reasons given in the survey, it's still really focused on things like IT implications, data security, lack of technical support, and so on, and compliance. These are still the reasons that are being they're being cited essentially within the survey. So the survey, if you want to read this is going to be on our website in the next couple of hours, so you can read the full output. But it's interesting to see that we still have these restrictions, and I think that's kind of where this conference, EARL is really about. The enterprise applications of the R language, right? So it's really about adopting R in the commercial world. I think this is where these conferences are still so important. So so that's kind of where we are. So please have a look on the website and see the full survey. Before we start, I'm not going to present any more on R today. I'll leave that to everyone else. We've got a wonderful lineup, so I'll leave it to them. Before we start, though, I just wanted to touch on a couple of things. The first thing is that the Tower Hotel and the dinner, the lunch and so on, is really expensive. One of the things that happened this year, of course, is we were able to reduce our ticket price. But also we got to a point where we realized that we would actually, make a profit from VirtuEARL this year. We were really keen to understand and think about how we could use that profit. So we decided to donate the profits from this week really into a charity. And when we spoke to the team internally about which charity we should support, people were really keen on supporting Data for Black Lives, which I think is really, a massively important charity right now. I think obviously the story of the year and the answer to pretty much every end of year, like what happened in 2020 quiz, is going to be COVID, by the way. That's obviously the big story. But in amongst this year, I think we've seen, stark reminders of the prejudice that exists in our society still towards different groups. And I think it's really, it's a really kind of, so it's a really important, I think, to back charities like Data for Black Lives. It's worth having a look on their website. It's a really important charity. It's a really good charity. They basically are using data and data science to sort of fight back against some of the prejudice that exists around Black lives. And so please have a look at the website, and that's where our profit will go off the back of Bill, which is really good to see. Okay. So a couple of housekeeping things before I start. So today is being recorded, so my fumbling welcome speech is being recorded for prosperity. So please keep yourself muted. And when you want to ask questions, can you use the chat box in Zoom? And then what will happen is that we'll have someone in the background kind of pick up the questions, then pass them to the presenters and so on. So please use the chat box if you want to ask questions. If you want to tweet or use any sort of social media, then we're using the hashtag VirtuEARL today. And you can see this is our handle as well, EARLConf here. So please tweet about VirtuEARL and what's going on and so on. And that's probably the last bit. I want to kind of mention just kind of three quick things before I promise I'll stop talking. So firstly, I want to say a massive thank you to the team, particularly Laura and Liz. So people never quite believe this, but as a company, we actually manage and run EARL ourselves. I think people always told us in the past that the sensible thing to do would be to bring in an external company that runs these things and do it that way. We've never done it that way, so I want to thank Laura and Liz massively for making this happen. I also want to thank the speakers and the people who run the workshops this week, for making VirtuEARL possible. And lastly, while it's great to have this day, I'm really looking forward to seeing everyone back in, face to face in the Tower Hotel or in the US next year if all goes to plan and we can be safely back in there. So I really, fingers crossed that this time next year we'll all be, in that very long dinner queue, lunch queue, or we'll be having a beer in that bar next to the hotel, whatever it is. But I hope to see everyone next year. In the meantime, I think that, enjoy the day. I think the agenda looks fantastic. You can find the agenda on earlconf.com. And we're going to kick off the day with Annarita from Zurich. Annarita is an experienced analytics leader, and she's going to talk about, I suppose, going from a sort of like analytic background, an advanced analytic background in machine learning to a role in leadership, which I think is really kind of a really interesting topic. So without further ado, I will hand over to Annarita and stop sharing my screen.
Thank you, Rich. Brilliant. I think it seems to have worked. Hello, and thank you very much for inviting me to speak at this wonderful conference. Actually, Rich, you were saying, that mine is not yet fully adopted by industry, but believe me, 20 years ago when I started to scribble my first R code, that I do say scribble because it was a scribble, it was quite unusual. Nobody ever heard of it. Actually, even somebody asked me to spell it, which I thought it was quite a challenging task. And you know, outside academia, very little organization knew about that. So actually now, you know, if an organization like Zurich, for example, is fully embracing the power of our Python, you can see that the journey has been there. But as usual with these things, there's more to do. So, but without much ado, it is an incredible honor, as I said, to be here to present to this community of talented analytics experts, and I use a statistician, data scientist. Now, first thing I want to reassure you that you will not hear much about ballet, despite the title. The other second disclaimer is that this has got nothing to do with recent government backlash with ballet and retraining from ballerinas to other jobs. So nothing to do with that. I'm not going to disclose more, otherwise I'll tell you the end of the story. And the other thing also, the third disclaimer before I start is that you might not really hear much about R today, at least not from me, but the agenda is packed with brilliant speaker, where you will hear more about use cases and applications of machine learning at R. So what am I going to talk to you about then? Well, what you will hear in the next, you know, few minutes or so, it's about my journey from a wannabe ballerina to analytics leader, and how my experience as a statistician, coder has helped me to get where I am now. And hopefully at the end of this, like 40 minutes or so, you will also start to think or continue thinking more about your future career choices. But I will need your help. So I would like to make this session as interactive as possible. You know, we are all in this virtual world. We can't really see each other. I'm not sure at which point some of you might fall off the chair. So how about we all start speaking with each other? So let's see if you're all keyboards ready. If you use your comment chat box, could you type in just your job title and the industry you're in? So I could just get a feeling of who am I talking to. So job title and industry you work in. Let's have a look. Let me just find out if I can. Oh. Job title, industry I'm coming to. Sorry, I'm just trying to reopen this screen because it's just closed. There you have it. See if I can see you. Laura, I can't see anything on the chat at the moment.
Okay, do you want me to read out some of the answers?
Please, yeah, that would be great. Thank you.
We've got a lot.
Oh my God.
I'm going to keep scrolling to the top. Okay. Oh, wow. We really do have a lot of responses. Data scientist, public sector, data science, insurance, associate data scientist in advertising, data and reporting officer, higher education, expert in bioinformatics, health tech, junior data scientist, food, insurance, charity, manufacturing, NHS, e-commerce, insurance, consulting.
Thank you, Laura.
There's a lot.
This is brilliant. Oh, wonderful. Thank you very much. I will need to make sure that my chat function works at some point, because there will be more questions to be asked. Nothing to worry about, but thank you. This is really brilliant, and actually really does highlight the fact that, as I probably was saying that yesterday in another conference on an insurance panel, that there is not better time to be in data. So absolutely, that is the case. So let me then, you've introduced yourself, so thank you very much for that. Let me then introduce myself then. So let's just see if I can move this. Oh, there you are. So my name is Annarita Roscino, and I'm responsible for predictive analytics for Zurich in the UK. Let me move this, you probably see. For Zurich in the UK, I lead a team of statisticians, data scientists, actuaries, and I'm responsible for the analytics journey at Zurich, but also for setting up the strategy and motivating team, but also one area which I picked up recently is around the ethics and ethical use of data. I'm sure something that you are very familiar with yourself. Now, who I'm in this photo, just to reassure you, I'm not the tall man. That's my lovely dad. The little girl just next to it, and yes, that's the one I used to be. And roughly that time, perhaps a bit later than that, I did want to be a ballerina. That was my dream. But you know what? I never was a ballerina, and I did end up getting my dream job. Now, I told you about my dreams and a bit about myself. So how about we reuse the chat function? Hopefully I will be able to use it now. And you also help me a bit here just by saying, well, I wanted to be a ballerina. I didn't turn into a ballerina. What did you want to be when you were a child? What was your dream? What did you want to get to? Oh, wonderful. I can see it now. Yay. Oh my God, an astronaut. I thought that would come. Batman. Oh, I love it. Cardiologist. Brilliant. Professional hunter. Wow. Rich. Oh, wow. That's nice, Rich. Nice for you. You wanted to be older. Paleontologist. Oh, wow. A computer scientist. Oh, we got somebody who knew that from the beginning. Wonderful fashion designer. Oh, I like that. Accountant or hairdresser. Lovely. And it's a bit out of this, but there is a government webpage actually that came available not that long ago, where you can actually type, you know, you can answer some question. It will tell you who you should really get a career to. Oh, Chief Jurassic Spartan Gen. Oh, I love that. Sorry, Erwan, you're the winner. This is wonderful. But anyway, if you go into the government webpage in the UK, you can fill a survey and find out what job would suit you. I turned up that I could be an actor. Now, not that dissimilar. We wanted to be a ballerina, but hey. But anyway, wonderful. Oh, so many things. Well, look, what does that mean? Why am I talking about that? Well, of course, you know, if you are sitting here, as I am, you probably didn't turn into the president of the world, although I'm not sure Maria Grazia might be, and I didn't know, or an astronauts, as I thought, or a singer, although you could be a singer in your spare time. So definitely, no, that's not what happened, but sitting here today, I would say this is probably the best place I'm currently on. It definitely wasn't the Royal Ballet of London. So as the thing that might have happened to some of you, to most of you, there was one thing that generally changed my kind of like my life, and it was when I was introduced to maths. It did turn not just into like one of the things I was doing, but it generally turned into my passion, the passion for numbers, the passion for logic, and how you could come from what I would call dry numbers to get so many more things and insight and then stories out of that. And absolutely after that, perhaps for most of you, maths, physics, statistics, that all followed, and the story is probably very similar to yours, some of your stories. And I went on to study for a PhD in statistics, and then I went to work for Fiat for the NHS, for market research companies, and ultimately in insurance, where I've been since 2006. The other interesting part when I think about my career is that when I told my family and friends in the late 90s that I wanted to be a statistician, I not only had to spell it, but I also had to kind of explain what it was, which is a quite a remarkable change to today, where, you know, data sciences, statisticians are, I think they've been described as the sexiest job of the 21st century. So hey ho, again, the world has changed and definitely evolved. And it's very, very interesting, clearly looking at where you are coming from and the industry are coming from. I could say without a shadow of a doubt that there are no single industry which doesn't have a data analyst, a statistician, or a data scientist on their payroll. So I did start as a statistician. That is my background, that is my bag. But for the last 6 years, the role that I had and I've been covering has been moving from, you know, writing codes into now managing team, building function, setting up strategy. Now, does it mean I've abandoned my passion? Does it mean I've abandoned this lovely board here with my lovely equations and all of that thinking behind that? Well, I don't think so. Actually, quite the opposite. My passion has kind of like evolved, and I've now become what I would call an advocate of analytics within my teams and within my organization. One thing I also wanted to make sure that you know today is that all the time I've spent coding, one thing I did not know at the time is that actually I was learning about leadership. But how? Well, just bear with me and it will become hopefully clear. So this is me now, or nearly now. So yeah, that's kind of like me moving from the little ballerina or wannabe ballerina to the position I'm now. So let me just sit here now and bring you back in. So often when we talk about jobs, we talk about tasks. What do I need to do? What are my responsibilities? So let me ask you then another question. What would you describe the main tasks in your current role? What do you regularly do? You don't have to write everything, but what could it be, you know, the top things that you do on your daily basis? What are the tasks that you perform in your job? Let's see what's, yeah, nothing. Okay, all right. Hopefully you get paid. Build tools to automate staff communication, talk to business, clustering, segmentation, yeah. Influence meetings, oh yes, yeah, I know that. Shining our coding, oh, cleaning data, build model research, yeah. Maintaining and developing code, package development, code monkey, love that. Data cleaning, we all have to do some data cleaning. Mechanisms and tools available to non-analysts, wow, love that. Coding, report, assess analytical performance of pipeline, bug fixing. Teach, oh wonderful, we have a teacher, I love that, all respect for all teachers out there. Data management analyst, driving insights, find quantitative solution, data, oh my God, lecturing statistics, this is brilliant, absolutely brilliant. So many sides of, you know, what I would call a love and a passion for data, scenario modeling and optimization, engage with clients. Oh, this is absolutely brilliant. Thank you all. This is what I used to do, and you know, you've covered most of them really. I used to spend most of my time collecting requirements, coding, analyzing data, building model, validating model, presenting results, and what I would call and repeat over and over again. Did I love it? I absolutely adored it. But what I do now, though, in my current role, believe me, it couldn't be more different. I am, as I said, I lead a team. I lead actually 3 teams. Data scientists, a team of predictive modeling who looks at the pricing, and also a team of business analysts and project managers who all sit under in my area. I develop strategy, absolutely key at the moment, and in general, so that we can find a space, or analytics can find a space in our industries and the recognition that it deserves. I manage budgets, the reality, nothing can be done without some money. So that's a big part of what I do. I manage stakeholders and bring the conversation about analytics to all levels. But as somebody mentioned before in the chat, yes, it's meetings, as well as emails, and tons of them that I still haven't answered. So thank you. You know, you yourself in your chat have kind of like shown the variety of tasks that analytics and data under the analytics that sits under the analytics and data umbrella. So when I look at what I did before and I look at what I do now, I could just sit there and think like, oh my God, that cannot be different, or could not be more different. But let's forget for a moment about skills, about tasks. Sorry, let's talk about skills. Let's talk about expertise then. So, and again, I will bring you in a moment. If I were a ballerina, and you might have figured out I'm not, if you did see me, I've got generally two left feet, as they say here in English. I would probably say, if I were a ballerina, I would probably say one of my skills has got to do with motivation, isn't it? You know, you've got to train that long, and you've got to be fully motivated to embrace in such a hard career. But how about you? What are the skills that you have learned or you've improved in your current role? Again, share them in the chat here below. We're talking about skills here, so we're moved away from the task. Let's think about skills. What do you think you have learned? Oh, perseverance. I like listening, empathy, influencing stakeholder, coaching, developing problem solving, communication, project management. Wow, brilliant. Mentoring, yeah, junior training, teaching, training other, stakeholder management, project leading, planning, influencing, design skills, teaming for success. This is brilliant. I mean, this is coding, multitasking, coding. I mean, if you're not feeling inspired now, I am. It's absolutely incredible to see, again, under the umbrella of analytics, all the skills that sit underneath that. Big pat on everybody's shoulders. This is incredible. Productivity hacks, yes, love that. Training, coding, comms, communication, R. Hopefully nobody will ask me to spell that again. This or anything related to coding, version control, yes, yeah. Designing onboarding programs, yeah, so it's designing, yeah, bargaining, yes, yes, yeah, I do that too. I do that too, especially when it comes to money, domain knowledge, constantly learning, more structured approach to problem solving. Oh my God, this is brilliant. As you can imagine, the reality is that it's something that perhaps at the time I didn't know, and please keep on writing if there's more things. I'm absolutely like incredibly proud to see all of these tasks and skills sitting in this community. So the reality is that at the time I did not know, when I was coding and when I was looking at when I was in my junior career, I did not know. But the reality is that there are so many overlapping skills between a data scientist, or what a data scientist does, or a statistician or a coder does, and a leader. And not just, please remember that, and not just a leader in analytics, but any leadership role. And you know what? I haven't talked about it, but I have a list. Yes, we love lists. So let's look at the list before I move into the other one. So I have a list. It's not by any chance a definitive list, but it is one. So let's think about problem solving. Some of you mentioned that earlier. Let's talk about problem solving. So when some of you, or when I used to write a code, a code is often writing with the goal of solving a problem. You've been given a problem, you need to solve that. And you will need to have the ability to identify the problem and then come up with the most efficient way to solve it via a program. And the leaders, and those of you in this here who are leaders in their teams, you know that a big thing that what a leader needs to do is to solve problem, is to facilitate problem solving, and also being able to see where the right expertise sits in the teams to be able to actually efficiently solve a problem. Is it different from coding? Yes, I'm not coding anymore, but I'm still there and I'm still solving problem. An inquisitive mind, some of you I think I mentioned that, but an inquisitive mind is absolutely key in a scientist role, and absolutely in a data science role. We all need curiosity, because sometimes, you know, the way problems are faced or are presented to us, we will have to dig a bit deeper. We will have to go down a bit deeper, and that only happens if you know how to ask the right question. If you are curious. And same thing when you move into a leadership role, you know, asking the right question, fully understanding the issues, or fully understanding the opportunities. It's absolutely an essential skill. And yes, yeah, I've learned that, and I've learned that when I was coding. Positive attitude, come on, we don't have to talk about that. Often codes don't work. And often I often used to sit there with my literally heads in my hands thinking like, what's wrong here? But I did carry on. I see my team, they do carry on. And keeping that positive attitude not only helps you get into the end of, you know, of a challenge, but also helps, you know, motivating yourself, self-motivated, but also motivating, you know, the people around you. Being a team player, no doubt about that, you know, and this is like the thing that you learn from when you sit, for those of you who have done a PhD, I know that people say, oh, PhD, you learn to work independently. I did, but also I learned to work in a team. And then, you know, when I look at my experience, when I was a statistician, and when I look at my teams, all they do is, and I think all you probably do as well, is to like look at each other, ask questions, support each other without, you know, without fear to just feel like that nobody's appreciating your work, because it's the work of the collective that is bringing the biggest results. And this cannot be more true for leaders. Yeah, I learned team playing when I was doing my PhD, when I was working for my first job as a statistician. As a leader, you know, your main duty, in a nice way, it is to motivate, support the team, encourage them, be a team player, sit with the team. Communication, some of you mentioned that, are incredibly important. You know, we sit in a very specialized area, don't we? And often, as I said to my team, when they usually come to me, they would say things like, oh, this was easy. And I would say to them, you know what, 95% of the UK population would not be able to do that. So I wouldn't call it easy. I would call it easy for you, perhaps. But the reality is that we do very complicated things. But often the people around us, our stakeholders, our business partners, they don't know what we are doing. They need to know the results. And that's where the communication skills become really important. And when you are in a technical role, not only you learn to communicate technical things, but you also learn to communicate to business, or translate the technical knowledge into a business question, into a business answer. And I'm not going to get you started. Communication is a key part of leadership. You know, I did say I sit into meetings, and that's most of what I do is communicating, influencing, telling the story, telling a story, my team's story, a project story, and also communicating at different levels, because clearly, depending on who you talk to, you need to adapt your communication. Where did I learn that from? Well, without a doubt, when I was sitting into my statistical roles that I've had and I've had in the past. And the last one I put in here, but as I said, it's not the exhausted list, absolute by any means. It's looking at a bigger picture. A great data scientist will not just look at the task that has been given or the task that needs to be completed. We'll want to understand what is the bigger picture. I often get people in my team just pinging me messages, say, well, I'm doing this, but why is that? Why do I need to do it? What can you give me a bit of a context here? And if you put things into context, when you go out and talk about them, when you go out in a way sell them, well, believe me, they become much more powerful. And absolutely, when you're in a leadership role, you need to look abroad, you need to look outside, you need to look years and years you know, ahead of you as you are now. And there are many more. Let me just have a look at, influencing. Yes, yeah, absolutely. And influencing starts, thank you, Vinit. Influencing starts even when you start coding. You know, you kind of like want to start understanding, you know, you might have a different opinion with the team. You want to say, actually, this is the best way to do it. This is the most efficient way to do it. Literally building that that relation where you are influencing each other, you are supporting each other, you're influencing each other, you're listening to what other people say. Or patient, I love that, Jonathan. Thank you. Absolutely. And in a leadership, it's very true in a coding, you know, role. You've got to be patient. Things might not work the first time, might not work the second, but in a leadership role, absolutely. Sometimes things develop. Sometimes the little seed that you've planted doesn't appear straight away. You know, sometimes it requires a number of conversations. It requires a lot of support from other businesses. It requires going back and forth. You need a lot of patience, without a doubt. And multitasking. Thank you, Hannah. That is brilliant. Yes, yeah. And who hasn't learned more about multitasking since being at home? And if any of you have got kids, who hasn't learned about trying to keep the family happy while still being proficient in your job? But still, you know, when you are coding, you need to learn that all at the same time. I see my team having like several screens, lots of codes running while they're typing an email. And, you know, I'm always very fascinated. You always fascinate me. Absolutely incredibly proud. So what did I want to say by all of these things here? Yeah, well, first of all, there is more to the list, and you've clearly gone through and given me so many more examples, which I haven't put in here. But let's face it, there's never been a better time to work in data. And let's face it, we are in the best jobs around at the moment, in my humble opinion. But if there's one thing I would like you to take away from this, you know, presentation, and lots of words that I've just thrown at you is, and you've probably seen that before, is what I would call to become more self-aware. Think about your skills. Think more about the things that you are learning as you're going through this wonderful journey. Think about your strengths and think about your weaknesses as well, because this and all of these will keep you moving into the role you want to be next. And it could even be an astronaut, believe me. It could be a ballerina, perhaps. But remember, the skills you learn become what stays with you forever. I don't code anymore, but the skills I've learned from my experience in coding are the ones that I'm still treasuring today in my leadership role. And that's it for me. So thank you all. And if you've got any questions, please use the chat box. I'll be very happy.
Thank you so much, Annarita. That was brilliant. We'll just, we'll give it a few minutes. If everyone's got some questions, if you'd like to pop those in the chat box, that'd be great. Thank you.
Shall I pick this one here? So first of all, thank you, Lisa. That's wonderful. Thank you for saying that. Daniel, actually, shall I pick that up? You're asking, how did you deal with moving away from coding? Now, yes, I would say there's one thing there's one thing that that was very hard, and I can't deny that. And it was the fact that when you move away from coding, you kind of like you start managing teams who code kind of like on your behalf. You lose that level of control that you have. You know, I'm sure all of you love to kind of like look at the details, look at the coding, and say you need to learn to delegate. Believe me, that was very, very hard. And it wasn't something that I learned straight away. I've got to be really honest. For the first perhaps 6 months when I was leading a small team of coders, it was pretty much like me checking every single line of the code, pretty much. But I sat down with my mentor, and he kind of like looked at me and he said, look, this is not sustainable, isn't it? So you've got to learn to trust. And this is what I did. So it wasn't easy. And I'm not saying it's going to be easy for you, Daniel, either, but it's about the ability to let it go, to start trusting, to make sure that the people in your team, to allow them to make mistakes, because they will, to put the right controls in place when that happens, but just to allow them to find their own path, as we have all done when we're writing, or when I was writing my own codes. But yeah, that is definitely the hardest part, to let it go, not to be in control. But it was worth it in the end, when I've seen, you know, how much my team then developed, and then we moved from 3 to 6, and now we are 15 and counting. Oh my God, there are many more questions. Laura, do you want to pick a few?
Yeah, sure. What is the biggest challenge of being a female leader in a male data world?
Oh, thank you. Yeah, that's a really good question. So the first thing I would like to say is that the biggest challenge is the fact that I'm actually quite short. So you end up sitting, generally you end up like in a room, and insurance has traditionally been quite male dominated. I'm saying traditionally because things have evolved a lot in that space as well. So the first thing to me was, generally I'm quite short. So I used to sit into or stand next to loads of men's and feeling quite, you know, tiny. But you know, that psychologically kind of like had an impact. But anyway, the reality was being myself. So I've tried to be myself and bring who I am in my role. Now, was it challenging? Yes, at times. You know, I might not look at myself having the same, I would say, attitudes or behaviors that are associated to a man leader. But again, even that has changed a lot. I have actually had such a big pleasure of being managed for most of my career by incredibly talented men who have really, really brought me through. So I haven't really had many challenges other than perhaps the challenge that I've thrown to myself. But I've been very, very lucky to actually be in an organization who have been very, very supportive of the kind of like gender equality in all areas. But my suggestion would be yourself. Don't try to be anyone else other than you, and that will go a long way, even with a funny accent. You know, in my case, I'm being short and full of that.
Okay, what's the next one? How did you move from PhD in an academic setting to enterprise?
Oh yes, yeah, thank you, Christopher. Yeah, again, I can't deny it was a challenge. I had few sleepless nights. I loved academia. I generally did. The buzz I would get by, you know, all the things that clearly, you know, academia gets first hand, all the new research. I would also get loads of buzz with the students and you know, the creativity, and it was an incredible time. But I just wanted to do something different. I thought that I wanted just to see how things work in the real world, and I'm putting, you know, clearly brackets all around that. It was challenging, but again, as I said earlier, I mean, it was mainly about trying to be myself and bring myself in. Now, quite interestingly, I hired a number of PhDs for my careers myself, and I know how that feels like. So I know what it is to move from, you know, academia to an industry. It is possible, and actually more industries are more and more open to PhDs when coming. When I joined Zurich, I was the only PhD they had at the time. Now my team a third of them are coming straight from a PhD.
Okay. How do you make time to keep up with new developments technically whilst leading the team, or do you delegate this?
No, I don't delegate it. So I love to read. So I'm always like checking new articles and getting, you know, making sure that I'm really up to speed with new techniques. Now, my data science team, they have set up the Data Science Journal, which is every Friday. One of them will present us something new that they found. And you will find me sneakily in there, just sitting there and listening to it. It is actually a really difficult balance to be able to still keep yourself relevant, but at the same time, you know, keeping on with your other, I would say, day-to-day responsibilities. And I do it because I love it, to be honest with you. I don't have to, but I really like it. So I would say, yeah, in my spare time, I would read articles. You know, I've clearly spent so much time reading about the A-level scandals in general, you know, so I would try to get more and more informed, because the place where I sit is, one, I want us to be at the forefront of data science, but secondly, I also want to be able to communicate some of the things that we read in the press to our exec, who might get scared about certain things and might get, you know, a bit worried. So yeah, it's a tough challenge, but, you know, I try my best. Is it perfect? I don't think so, but yeah, we will try to do our best.
How do you manage business leaders when they challenge the value of data science?
Thank you, Vinay. A very good question. So when we started at Zurich, we were what I would call mainly a technical team. So at the time when I set up the team, and I set literally from scratch, there was nobody. So I really started recruiting from nothing. The idea was, well, you know, somebody has read it in the press, I guess, and we wanted to get the technical ability list up there and up and running. Now, what we have evolved, and I mentioned earlier, I have a team sitting next to me, or sitting under me, who are business engagement, project manager, etc., etc. A big part of what I do is not only looking at a business case, so what is the value that the initiatives I'm bringing are going to add, but also monitoring that value as we go along. And believe me, when you start doing that, when you start talking to the leaders, the language that they need, they know, you start talking about money, you start about profit, you start about customer satisfaction, etc., etc. And you mention, you literally go down and say, actually, this initiative added this initiative, or this initiative could potentially add that. Believe me, you know, all of a sudden you get heard. But it's moving from that, it's moving from the knowledge that we all know this is worth it, and we all know that, but they need to see numbers, they need to see why. So explaining the why, showing the benefit case, that in my experience has worked.
Okay. How long had you worked as a junior before you became a leader?
How long have I done it? So I started. I started in 2004. So I got 6 years. Yeah. So I would say 6 years. So in 2010, I got my first leadership role, and it was to set up the first data science team. So yeah. So I've been doing that for a number of years now. But yeah, I would say roughly 6 years. If I then include my PhD, then that would be 9. But yeah, 6 years. There isn't really, I would say, there isn't really like a number. It's about what suits your kind of like your life, and what, you know, how your ambitions are. I mean, in the meantime, I also had 2 kids, so which meant that I wasn't really interested to take any more things other than, you know, responsibilities I had at home. So it really walked around, mainly for me, walked around what I wanted to do at home, my family, and you know, my career ambitions. But there's no, there's no numbers there. I've seen people actually moving much faster. I've seen people waiting longer, but still getting very, very senior careers. So it's up to you. Have a strong development plan. That would be my recommendation. I wouldn't worry about the years. I would worry about the fact that you've got a strong development plan and you are checking against it on a regular basis to see what you're making progress.
I've got a question from Matt. How do you broadcast about data science and analytics in your company and show that you have the capabilities to solve their problems?
Yeah, thank you, actually, Matt. That is a really, really good question. So I have actually found out myself, again, when I started this journey, I didn't know that, but I found out myself that actually doing something is almost sounds bad to say, but it's also as important as talking about it. So we have set up in the last 2 years, actually, at Zurich, we have set up a number of webinars, lunch and learns, where my team presents things that they've done to everybody, including Zurich Group, so the wider community. We have a strong community at Zurich around workplace, which is our internal Facebook, where we regularly post things that we are doing. And it's just generally it's literally about talking, it's about getting the right tractions from the business and getting the PR right. The reality is that I've got somebody in my team who half their job is literally to do PR. And as I said, it's as important as doing something. It's about talking about it, talking about the value, making people understand, bringing them to this journey.
We have a question from Sandra. If you could give advice to your younger self on the beginning of your journey with data science, what would it be?
It would be to be more confident. It would be to just be more confident, just go for it. I think I often, and I see that actually in my junior data scientists at the moment, I think most of them, they just don't know how good they are. They just don't. But they are brilliant. They're absolutely brilliant. So that doesn't mean don't be humble. Just like know your strengths, and just, you know, go for it. This is what I would say to my younger self. I would. I was very insecure. I might not look like it, but I was very, very insecure. I think you just have to find out you are very good. You know what you are doing. And the same thing I say to the people in my team. They are brilliant. I just don't know it. So yeah, you are brilliant, and I hope you know it.
That's great. Thank you so much. I think that's all the questions. So yeah, weirdly, we can't all clap at the same time, but I'm sure everyone's clapping at home. So thank you, Annarita. That was absolutely fantastic. We're now going to have a short break, and we'll be back at 10 a.m. with Lisa Clark presenting. So if Lisa, if you're on the chat, if you could give me a shout, that would be great. But yeah, we'll be back at 10 a.m. Well, the applause is coming in for you, Annarita. Lots of clapping and thank you
all. Thank you very much. Thank you. Bye.
And by the way, if anyone needs to leave the conference at any point, just simply leave, and then you can click back on the link and you can join. So we'll be the same meeting, same link all day, and you can come and go as you please.
Hi, Laura.
Hi, how are you?
Yeah, not bad.
Good.
Hope it's all right and it's all set up. I'm trying to change the size so that people can actually see me rather than the room.
Yeah, feel free if you want to test sharing your screen or anything.
Oh,
like
that's
that.
A good idea. I can start that, can't I?
Yeah, we'll be starting at 10 a.m. everybody, back after a short 5-minute break.
Let's see. Right. Is that sharing, Laura? Can you see that?
Yeah, sorry, I've managed to.
Super, that's all right.
Myself. Perfect.
Super. I'll put that down a bit. So they only get a small screen of me, don't they? you want me to unshare so that you can talk to them at the beginning?
Oh, no, that's fine. It's perfect to leave it.
Are you sure?
Yeah, it's absolutely fine.
Oh, I've just undone it. What was I thinking of? Where's it gone? Being a pain. I normally have set. Oh, it's like that.
Yeah, great. You can just
There you go. I'll leave
there
it there.
until we start. Cool. I'm just going to nip off for a second. I'll be
all right. No problem.
back.
That's a fair point.
Mm-hmm.
Super. Why is it being?
Okay, we are bang on 10 a.m. We're going to attempt to run punctually today. So next up, we have Lisa Clark from Virgin Media, who will be presenting on For the Love or Money, how to generate high revenue from a team of R developers. So Lisa, if you'd like to unmute yourself and take it away.
Hello, I hope you can hear me. Laura, can you hear?
Yep, all clear.
Superb. And I hope you can see me because I'm afraid it's disappeared. So
yep, all clear.
Super. Good morning, all. It's a bit quirky doing a virtual conference this morning, but I hope everyone's can see, hear me, and everything's going well for you guys. I've just got a little bit, I'm actually recovering from hip surgery this week. So if I start moving up and down, it's because my leg's cramping. So I apologise in advance if you wonder what's going on, but I'll get through the talk. And just in case something goes horribly wrong and I can't keep going with the talk, I've got my husband to step in, but since he's a developer and he's listened to this talk enough, he'll be able to. So it won't happen, but just in case, that's what's going on. So yeah, so this morning I would like to give you a little bit of my own experience and examples of being a manager of a team of developers, and just give you a little bit of insight and show you what I've learned along the way. So this is not clicking through, there we go. So often there seems to be this tension between sort of having fun and delivering value for a business, this kind of love or value tension. And often it's perceived to be sort of the data scientists and the programmers versus the business and the ROI. And actually the two are pitted against each other. And what I want to do today is actually say that this is a bit of a misnomer and it doesn't have to be the case. So I want to give you experience and examples from my own walk of life. But also what I would really like to impart, I suppose, is the fact that no matter where you are in your career at the moment, whether you're a senior business leader, whether you're a manager, or actually you're a junior data scientist or anywhere in between, you can hopefully use some of these tips and tricks to influence your own kind of position and also your team around you and the environment. And that's kind of upwards, sideways, and or downwards. So I'm hoping that there'll be stuff in here that you'll listen to and take away and think, oh, actually, yeah, I can maybe change that and in doing so, make a better environment for yourself and your team. So a little bit about me to begin with. I started out as an academic. I was a theoretical astrophysicist. I went into cosmology and I ended up working in academia for very many years. And somewhere in the middle, I founded and ran 3 of my own companies. So quite a non-linear career path. And then ended up being an economic policy analyst before I actually became a data scientist. And now I'm at Virgin Media as the principal data science manager. But everything, or the things that have underpinned my whole career are that I love data, I love programming, and I love business problems and solutions. So essentially, in a nutshell, I am a data scientist, but that's not what I've done, or at least I've not had that title for a long time, but that is what I've done for the last 20 something years in my career. It would be remiss of me, not just as a female, but as a data science manager, to suggest that data scientists are kind of single faceted. I actually love being outdoors. So the top image there is me when I was a research fellow at the University of Sheffield, working outside. I used to sit on the roof with my solar panels and work up there. But also I play hockey, hence, unfortunately, the hip injury. And I have a young family. And I think most of us nowadays are getting away from the whole all programmers are kind of introverts and don't have anything else, when actually there's a really good life balance in data science. So a little bit about Virgin Media. Most of you will know Virgin Media as a consumer business, doing quad play, so landline, telephone, TV and broadband. But also, and I'm not going to go through these numbers, I hope they speak for themselves. But what I want to sort of, I would say remind you, but most of you might not be aware that we have a B2B side. So we serve businesses across the UK. And we actually have 45,000 businesses that actually don't include the small office and home office customers. So we have a lot more than that, but a huge amount of business to business customers as well. And some of my examples, or the more interesting ones that I can talk about, are from the B2B side. So don't be surprised. Virgin Media is also part of Liberty Global, and Liberty Global are one of the world's leading broadband companies in the world, predominantly in Europe, but across the world as well. So let's start on a little bit of my experience, and I hope this will really resonate with some of your own experiences from being data scientists or analysts and programmers. So on the one side, you've got the business and business leaders are demanding high returns on investment, and they want real value. They want quick solutions often. They have problems. They want something very, very quick. And they see or perceive skilled analysts as quite an expensive resource, especially when you start talking about data science, AI, smart technologies. They really view it as an expensive resource. So they want a very good return on investment. But they don't necessarily understand AI and machine learning and everything that kind of incorporates. And so there can be this kind of tension between actually how do you deliver that value to somebody who doesn't necessarily, they know how it can be used, but they don't necessarily understand the techniques. On the other end of the scale, you've got the data scientists who typically want to develop really good, exciting code. They are always keen to learn something new. In my experience, hate too much data engineering, but actually that goes into things like data quality and sort of the wider aspects. I'll come back to some of that. But also they perceive that or know that data science projects aren't always quick. You can get quick wins if you're doing something like a new marketing model, for example, and you have all the data in the right place and everything's aligned, then you can actually turn around a new model quite quickly. But often if you want something quite smart and novel and new for a new business problem, then it's not just a quick turnaround. And then in the middle, you've got the managers who I've put here can struggle to find the right projects. What do I mean by that? What I mean is that they are exciting enough to keep the data scientists and developers and programmers really kind of challenged and excited, but also that they are going to deliver value in the end. I'm going to come back to that one because actually it's this question of value and what you deliver. I'm going to sort of put a bit of a nuance on, but also it's got to be the right priorities. So managers do have to take that line about delivering the ROI, but also keeping their data scientists intrigued. And also it can be quite difficult to engage a team of predominantly introverts. Sorry, just gonna turn that off. Sorry, I'm being distracted. So programmers are typically introverted, not always. I am almost the opposite. I'm an extrovert, but typically data scientists and programmers are introverts. So it can be hard to engage them and create that really good feeling of team. So let's go into that a little bit in more detail. What makes a programmer happy? I'm hoping that this doesn't make you sort of gasp and feel dismayed, but I think that on the whole, and it's a bit generic, but what does make a programmer happy? Firstly, a computer of their choice. I think that latter bit is important. Having the right systems and that tool is important. I've put high-speed internet. Actually, I think here what I mean is connectivity. That could be to the internet, it could be to resources, it could be to databases, etc. So maintaining a network. A really challenging problem to solve, something that gets those mental juices flowing. And then ultimately, most programmers then what they've got their sort of environment set up, what they want is a quiet space with time to think about it so that they can really look at that project from all the different angles and start to analyze and assess. So what tricks have I learned to get my team engaged? And I've heard some of this. Annarita was talking about this a little bit a minute ago. So it's nice to hear that we're aligned. But for me, it's been a little bit of an experiment along the way. I have got things wrong and I've got things right. And when I've got things wrong, I have tried to be open and transparent with my own team to say, okay, I don't think that went so well. I probably won't do it like that in the future. How do we do this? And make it very democratic. Try and get the team involved so that it's less being done to them as done with them, and actually maintaining that real engagement amongst the whole team. But it is a bit of an experiment. So these are tips and tricks that I've kind of learned along my path. I think the fundamental for me is that if you want to engage your team and thereby get value back out of them, you have to give the team space and time, but with the right tools. And for me, it's that combination that is essential at actually getting the brilliance out of a brilliant team. So using the correct tools. Why is this important? If you're asking your programmers to use either antiquated software or difficult systems, or you're asking them potentially to use Windows to integrate with a Linux machine, whatever kind of difficulties there are, then that means your team are going to be focusing on all the wrong aspects of their job. So removing those IT barriers is quite critical to make sure that you can get that space and time, because actually what you're doing is removing the noise from a system. And actually that is underestimated in most business environments, especially those that don't really understand what programmers need to do their job. Again, it can be perceived as expensive when actually if you weigh up the time you save, you can do a lot of good by removing those barriers and giving them the correct tools. Fewer meetings, I think most of you will be nodding here. I think it speaks for itself. If you want your team to spend time thinking and being brilliant, then actually spending all their days in meetings is not efficient. So trying to find only the most important meetings and limiting the time and having really clear agendas is key. Again, sounds quite obvious, but is not necessarily trivial to do in a workplace. My personal preference is to design an environment to feel a little bit more academic. So to get people to be thinking more innovatively, thinking outside the box, being a bit novel, keeping up with the latest trends and techniques, and actually feeling that they can be sort of research oriented in the sense that they can suggest new models, suggest new methods, and come up with their own ideas. So that's what I mean by academic, more than the actual sort of the research university-led sort of academic. But to feel that environment is for me quite an important one, to have that open, honest, innovative thinking. And as part of that, I initiated Lunch and Learns, and it was great to hear Annarita talking about similar that her team have done, and keeping up with those. And the reason I find it's really beneficial is that I find my team train themselves on something and then want to feed back. So it's very much peer-to-peer learning and training, which means that the team always keep up with the latest trends and techniques, and they want to teach each other. But in doing so, they learn to work with each other. And that sounds very simplistic, but actually understanding each other and respecting each other from that deep intellectual sense is also an ability for engaging the team and getting them to be much more open and transparent, because it also brings around those opportunities to say, I tried this and I got it wrong. And there becomes less stigma around being an amazing, smart data scientist. During COVID-19, I actually initiated game sessions, and I did them during work hours. I'm a mother myself. A lot of my team are parents or carers, not just of children. And for me, that was important to do something during work hours where the team could step outside of practical work, the value-based stuff, and actually do analytical board games, things like that, where we could just get to know each other much, much better and learn how each other thinks. And it's been hugely empowering for the team, actually. It's been a real success. From my own perspective as a manager, I think it's really critical that I personally know my team members and their own individual personalities. Most are introverts. I do have a few extroverts, but actually some like the detail, some like the bigger picture, some prefer working in one ways. You know, there's a lot of differences in there. And when the team start to understand their own personalities in conjunction with others, and also their irritation points, you can start to really, really develop those strengths and weaknesses. And you can really play on those weaknesses to turn them into strengths as well. For me, an irritation point is that I'm a talker. So I have to learn to listen more. And I'm very open and transparent about that with my team. My team will now quietly say, Lisa, button it. You know, they have the ability to say, you know, a little bit less. So actually learning your own irritation points or personality traits that irritate your own team is also critical. And then obviously capability building, I sort of mentioned this one before about providing learning and development opportunities, making sure that actually your team can develop the capability and the knowledge and the know-how before a particular project comes up. The reason for that is that business leaders do want a quick return. They often do want it to be a quick turnaround, which means that if your team are given a project that they need a certain capability or knowledge for and don't have it, then that's going to delay everything. Whereas actually allowing your team to develop that in advance, in quiet moments, means that when the right project comes up, you can develop the solution much quicker and gain the value quicker. So it's a sort of upfront value test in some sense. I shouldn't talk about value without almost defining it. And I'm not going to labour this point because I think it's a speech in its own right, really, and there have been books written about it. But value is in the eye of the beholder. Almost every business leader I've ever talked to has their own perception of what value is and how to define it. So for some, it's quality. It could be quality of data, say for the BI team. For some, it could be quality of customer. If you're talking to a salesperson, it's usually about the revenue, the sales that you're generating. But it could be about advocacy. How is your brand represented or perceived by the community as a whole, whatever that community might be? But if you're talking about the operational part of the business, it could be about efficiency savings and cost reduction. So value can come as a range of things. But what you want is to have something that's really measurable. And not all of them are measurable. And this is something I think we need to think about when we're talking about value and return on investment. So, for example, capability building, I've already suggested that actually doing this up front, when there may not be direct value to be returned immediately, will usually generate value later down the road when you use some of that knowledge and know-how in projects. I personally find that business as usual, things that we do every day to keep the show on the road, whether that could be, say, like a predictive model that feeds into, I don't know, marketing, for example, is often undervalued in that it's there, it works, and just because it sort of runs, people forget that it's still generating value, but also does need tweaks and work here and there. And it's not, you know, it is, you have to cost it in somewhere because but it does add value. It's just not always tangible. And computing efficiency, I've mentioned before, but actually if your team are working on things that aren't the project, the work, etc., and they're not wasting time, but they're spending a lot of time on other things, then actually you might be wasting value. And can you measure that effect? How much time are your team spending on things that aren't work, or per se? So here's another example of tension between code and ROI. There are two very simple bits of R code that will do a fizz-buzz game, essentially. And I just want to emphasize here that both pieces of code do the same thing, essentially. They do the job. The one on the left is perhaps, we might call it a little bit dirty. It's clean code, it does the job, it's brilliant. But actually, if you're working in a collaborative environment and it's maybe going to productionized code, you probably want something that's maybe a little bit easier to understand. So you might use functionality. You want something to be scalable, reproducible, but essentially both do the job. And it's about understanding when is code good enough and when is code the right code. When do you actually need to make it better? So it's a reminder just quickly to say, actually, sometimes the left-hand code is just good enough if all you want to do is a one-off bit of code, and that's okay. So before I go into a few examples and show you how we put this into practice, I personally feel that the way to get the best value from the team is to really get the best, or remember what the value in your team is, and that is the people. The people are essentially the brains, they're the smart, they're the people that will manage to give you your value. So integrating everything I've mentioned above means that you will set up the right environment so that those people will generate the value for you. And it's about the right projects, making sure that you can get value from projects. That's absolutely key, right? You don't want to always spend time on projects that will never generate value, but also allowing those capability build projects that might not generate value now, but you can see a reason for having that know-how in the team. But also about that environmental setup and that sort of learning academic environment. So a few quick examples if I've got time. The first one's the knapsack algorithm. It's knapsack, obviously in British we use rucksack, but it's known as the knapsack algorithm. That's what it was first named. So what was our business problem? So for every installation that Virgin Media Business has, there is a given cost and an associated revenue that the customer might give to us as a result of that installation. But we have to keep all those projects within our capital expenditure budget. We only have so much money we can spend on installation of projects. Now, because it's B2B, we're talking big money, big projects here. We're not thinking of sort of switching on a mobile phone for somebody. We're talking about cables in the ground. So there's only a set budget, and we have to prioritize the projects that we can actually undertake and keep within that budget. So the business came to us and said, okay, we want to apply a simple threshold that says whether project would go ahead or would be cancelled according to the cost of installation. And we decided that, actually taking a step back, taking a bit of time to think about it, that a simple threshold was possibly not necessarily the right way to go about it, and we wanted the knapsack problem. So before I tell you about the algorithm, I'll just show you one of the reasons we thought a threshold problem wasn't the right thing. So here we've got a chart. Along the bottom, you've essentially got the cost of the project, so the installation cost, and along the y-axis, you've got the revenue that you might get back, so to some extent profit. Anything along the diagonal, above the diagonal line, would be profitable. Anything below it would be loss-making. So what you can do is move the dotted threshold left and right and start to understand for the amount of cost you would spend, how much revenue would you get back, and work out that there is a plateau point at which you say, okay, this is the point at which you don't really make much more profit for the threshold. So you could define a cutoff there. But what that means is that there are profitable projects that are excluded and loss-making projects that are still allowed. So it seems a very ruthless way to define a threshold, really. So this is where the knapsack model comes in. And the idea is that you have a given size of rucksack, you have a certain number of items that go in, and they have a value and a size. And you can only pack certain amounts. So how do you maximize the value you get back out for all the items? So you want to maximize the value of the things you do pack. Now, you can use the Adagio package, which would be great for the knapsack model. So very quickly, a few lines of code, you can actually work out for your range of projects which you keep and which you don't, and maximize your budget. And that's what we did. And it's quite a fun little project. This one was actually quite quick to deliver. And what we found was we cancelled just under 10% of projects, which was actually only 92 fewer than the simple threshold. And actually what we gained was about 200K for this small set of projects. And this would be a monthly model going forward. So quite a quick revenue gain at the end of this, just by tweaking. So instead of looking at it as a very simple threshold project, we took time to step back, think of it a bit differently, and suddenly quite a lot of value can come out of a very, very simple model. Because of time, I'm going to just quickly move over this one, but you will probably all have come across customer segmentation in your workplace somewhere. This is about using a computer rather than humans to segment your customers and understand the nuances between them. And we essentially did that. We built our own clustering problems. So we used Clara and we used the cluster and artsni packages to do this. But what we did, we actually had to develop a bespoke Clara algorithm, so a little bit more complex. But what we could then understand between groups of customers shown here in different colors, we could understand where customers were different within a cluster and where their nuances and differences were, but also understand where two clusters were close, so they looked quite similar, but yet were distinct, what made them distinct. So we could start to understand our customers from a very, very different perspective. So something that is quite numerical and mathematical can sometimes deliver very, very good insight. A little bit more work, but actually we're using these in our high revenue marketing campaigns to huge success now. I couldn't talk about R in the business environment and value if I didn't really talk about the visualization, and I think it would be too naive, but sometimes the value for us and our team is in visualizing that data very quickly and being able to present that message back to business leaders or stakeholders. For example, here we're on the left, we're showing our duct, so our fiber cable in the ground, and showing where it's connected and not connected. And on the right, we're showing individual premises as to whether they're serviceable or not. And by actually just visualizing it, we can pick out the quirks in the data, essentially, where some of them look a little bit odd. There's a cluster of serviceable premises and one that's not. You might start to think, that's a little bit strange. Do we need to look into it? But you can also start to understand clustering of, say, businesses that we might go and sell our services to. So it's a huge gain on just quick, simple visualization. Here's another example, very simple bar charts. And my point here is really that adding value doesn't have to be complex. You don't need something like the knapsack model or clustering, or sometimes it's literally just about presenting very simple analysis in the right way back to the business to gain that value. So to end, I personally feel that the value in a data science team or a team of programmers is actually in the real asset, and that's the programmers themselves. They're the people that will be able to take something and generate real insight and revenue from it by twisting the problem on its head. So for me, the value comes by giving your team the space and the time with the right tools. So making sure the environment is set up so that the team are the real asset. And it's about doing it day to day. It's about the full environment and making it comfortable so that people can be innovative, but remembering that they do need that space and time, and they do need the right tools. Just think quickly back to the knapsack problem. We could have implemented the very simple threshold cutoff, but actually taking a step back, allowing some of my team just to think a bit differently, meant that we really quite quickly had a totally different solution that was very simple to program, that actually generated much more value. So yes, the simple threshold would have generated value. We went above and beyond that. Why? Because the programmers took the time and the space to step back with R, the right tool for that given moment, to develop the right solution, to develop the value. So for me, it's about motivating the real asset. Thank you.
Thank you so much, Lisa. That was fantastic. If anyone has any questions, we'll just give you a minute or two just to pop those into the chat. And also considering that Lisa has had a surgery this week as well, like, thank you so much for,
it's all right,
for coming today.
I'm a little bit woozy on morphine, but I think I got through it. So if I was a little bit hazy in places, I apologize, guys.
Would you like me to read the questions to you, or are you happy to read them?
Yeah, if you could read them. Yeah,
sure.
I'll stop sharing so you can see me rather than, oh, did that stop sharing?
Okay. A question from Beth. Do you think managers are often guilty of seeing data scientists as a tool that they don't know how to use?
Oh, good question, Beth. Yes, I think I do. To some extent, I expect that was probably a leading question. But yes, I do think there is a danger of that. They don't always. And this is why I think I feel very strongly that actually remembering that the asset is actually the people, not necessarily the team. They're not a tool, they are people, and they need their own environment like any other business person. Do I think, or where do I think, I guess the danger is, yeah, people assume too often, and it's too generic to say everyone, but that data scientists are very bright and will just come up with solutions very quickly, that actually they can think on their toes and it all just happens, and actually they've got R, they've got Python, whatever tools they're using, and that it's just magic. It isn't magic. We all know that, but actually reminding managers that that you do need to think. It doesn't just happen. It is really important. So yeah, I think it is a danger, but it's about a two-way dialogue and reminding managers that we're not tools, we're people, but we can be a real asset when motivated.
Great, thank you. I think we've just got time for one more question. Yep. I don't know whether, Lisa, if you can stick around for a minute, there's a couple of questions in the chat.
Yeah, sure.
Okay, great, that's fantastic. We'll just do one more from Daniel. What analytical games would you recommend?
Oh, good ones. So we've played a various set. The one I actually like, which is intriguing, is a very simple one called Code Names. Horsepaste do it. It's horsepaste.com. And the reason I like it is because we have really a disparate team, a wide range of personalities. But what it allows you to do is have teams, you have spy masters who have codes, and you basically have to guess the words that they're thinking of. And the reason I like it is because it makes the team try and understand each other. You have to understand and put yourself in their head to think, what are they going to understand by the word I say? So if I say Indian, meaning Native American Indian, to somebody who is maybe from India, the two perspectives are very different. It's the same word. So thinking about the nuances in words can make you really understand your fellow colleagues from an analytical point of view. So that's one of my favorites at the moment. The other one is Psych, because again, you've got to think about who would have said different things. So those are two of my favorites. But if you want other suggestions, I'm happily email me and I'll give you a couple of others that we love playing.
Great, thank you very much. Yeah, there's just a couple of other questions in the chat if you've got time to answer those. But again, sure. Thank you so much, Lisa. That was fantastic.
No worries. Have a lovely day, guys. Bye.
Okay, so next up we have Owen from the Very Group. Owen is presenting Mind the Gap, how forecasting can help to see gaps between financial targets and demand in advance. So Owen, if you're ready, if you'd like to unmute yourself and share your screen, that'd be great. Thank you.
Isabel, can you see the screen okay?
Yeah, all good.
Oh, fantastic. Yeah, thank you. So today I'm going to go through Minding the Gap, which is one of the use cases that we had within the Very Group. And just to start with, if the slides work, I'll give a little introduction about myself and then I'll get into the more interesting stuff. So my name is Owen and I work at the Very Group as a data scientist. And when I was working on this project, I was working within the retail data science team. But before this, I was a consultant working with charities, B2B and B2C, different companies. And we were dealing with different types of data-driven problems that they had. And it was quite insightful, not only to see the different problems that they had, but also the data infrastructure. And interestingly, a lot of it was quite similar, which definitely helped me in my career now. My experience with R stems back to my mathematics degree. So originally, I started with MATLAB and Derive, and I always have a place in my mind remembering MATLAB and those semicolons. And R was definitely one of the more rebellious languages that I was getting taught at the time. But it was definitely interesting. It piqued my interest as soon as I used it. And I think from pretty much there on, I used it for everything I could, including some of the coursework during my degree. And then since then, I've been utilizing R for EDA, modeling, and reporting back to stakeholders. And I've done this in the form of Shiny dashboards and R Markdown reports. So what I'm going to go through today, hopefully, will be an overview of the Very Group, just to give you a flavor of where I work, the business use case that I'm going to go through, the tools of the trade that I've used to achieve this, and then the results and actions from this use case. So as I said, I wanted to give an overview of where I work. And to start with, the Very Group is UK's largest integrated retail and financial service provider. That's including Very in Littlewoods. And it's quite interesting how long the history is here. And I just wanted to pull out some key milestones, which are on the images on the right. Starting from 1890, it was a catalog company. And then it moves towards a storefront in 1930. And then the next milestone is quite interesting from a change perspective. It's in the 1990s, it started its first e-commerce. So it's already beginning to move into the online space when it wouldn't have been as common to do so, especially given its history. And then from 2005 onwards, you can see that it's actually closing its storefronts. And that's probably a recurring theme throughout the Very Group, where change is something that's always at the forefront of what we've done. And it's always something that's in the mind of what's the next best thing, or what's the best approach that we should do to this problem. Which leads on to 2009, where we moved completely to online as a brand with Very. And then by 2015, we actually cut the catalog completely as well and went 100% digital for all the different platforms, which is interesting to see over 100 years of history there, that we've went from the catalog storefront to completely online. And then more recently, we've renamed ourselves into the Very Group and also opened a new fulfillment center in the East Midlands. And this is just to help deliver better promises for the customers, as well as try and keep up to date and be on the cutting edge of delivery. I suppose one other thing to draw out there was the 2014 point, as although it's nice to talk about all this change, and there is definitely a passion for change in the company, it's not always a profitable thing. So it's, as I said, 2014 was the first time they have profit following a decade of loss. So it's just to show that although it definitely is a company for a change, there are risks associated to having such a demand for change and a passion for it. And then moving on to the business use case. So what was the problem that I had to solve? So the business use case that was hand was there was a need to see what the financial forecast was going to be with a different lens. So the current approach that was being used, it had been used for a long time and it had been useful, but they wanted an additional check. So in a sense, another sense check, or possibly to make sure that they weren't missing the trick with the way that they were forecasting. And so the solution that we proposed was a customer-led forecast, which broke down the customer groups within month of acquisition. And the way that we defined this was financial year and financial period of acquisition. So for example, customers that would have started in the financial year of 2019 and the financial period 9. And on the left-hand side, I've got an exaggerated sketch of what this would look like in terms of the proportion scope of the project. So on the left-hand side, we have two distinct groups. You have the cohort groups and then the pre-2015 groups. So the reason why we split it like that is just because of pre-existing business conditions. But the cohort groups and pre-existing, you can see that they're suffering attrition and they're going down. And this is because they are mutually exclusive groups and they wouldn't have any new customers being fed into it. And then on the right-hand side, where you'd see the forecasts, you'd have the budgeted line and then the new cohorts existing and the pre-2015. And the idea essentially was to help the business to identify what this gap was, if there was one, and how we could associate it to the different sets of customers, and then use that for different parts of the business. So which leads on to the approach. So previously, there was an attempt at this project a few years ago, and the difficulty that it inherited at that time was a legacy structure. So when it was built previously, it didn't have any scope to be either a smaller project or a larger project. So if we got more customers or less, it wouldn't be efficient in a sense. It would still be using the same infrastructure and the same cost every time it ran. And it wouldn't also be able to scale up to larger customer bases. So that was something that we needed to address. And the next thing was difficulty to unlock value with the stakeholders. So originally when this was created, it had one single KPI in mind, and that wasn't going to answer any of the questions that they had originally. And so the next time we would build this, it had to address that issue as well. And finally, it was prioritized quite a few years ago. So some of the assumptions that were in play there would need to be consistent with what we see today, and any other exclusions that may need to be applied. So the approach that we took in the new one had to address those things. It needed to be able to scale up to the problem if new customers were required, or even if part of the process could be run on a smaller size instance. And also the design needed to have the stakeholders at heart. And I know the conversations before, people have mentioned that you have to show the value to the stakeholders, and this was definitely something we wanted to make sure we focused on. It was all well and good doing a lot of fantastic work, but then if the stakeholders don't see the value in it, or they don't go ahead and use it, it has no value at all. And then also a new take on the problem. Given that we're starting it again, we wanted to make sure we tried new things, new algorithms, and compared how they would do to what was done in the past. So the new approach that we decided to go with was R, and we decided to start from the bottom up just to ensure that all the business definitions were still relevant to the project, and it also was in line with the previous iteration of the project. And starting with this, we quite simply got really simplistic models out the door to show the stakeholders what type of thing they could be expecting, what type of accuracy they could see, and also whether or not this was going to work and how it would look. And then from there, we built it up to the same standards as what we saw previously, and then also began experimenting with different algorithms for the older and younger cohorts. And these older and younger cohorts I'll go into in a bit more detail. But for now, just accepting all the younger cohorts. And throughout this process, and alongside any changes that were made, explorative data analysis was performed and captured in R Markdown documents. So an example of that is the one on the right. And this is the start of the tools of the trade section. So there'll be 3 sections on this, following EDA, modeling, and then also showing the value through a POC. So the R Markdown document on the right is a little bit more bespoke to the company, but it's utilized through the R Markdown package and the dynamic R Markdown package themes. And that allows it to be reshaped and sized for different users. So for example, if you were looking at it on the tablet or the phone, it could still access this R Markdown report as you would any resizable HTML document. And the packages that I've utilized to get this was ggplot, dplyr, and tidyr predominantly. But the good thing about these Markdown documents, not only are they just part of the infrastructure when I'll do some work or EDA within R, is that it allows me to add interactive questions for the stakeholders. So I've blurred out some of the questions for obvious reasons on the left, but they would be example of questions of things that stakeholders would be interested in, or possibly some exclusions that they never thought of when we originally started the scoping process that could potentially be important to remove. And also allows us to look at different KPI or dimensions that were no longer there. And then so moving on to the modeling flow. Apologies if you can't see this diagram too well. I am going into it in more detail in the next 2 slides. But this is a top level view of how the modeling process works from front to end. And I wanted to address some of the different bottlenecks that we had, and also some of the things that take into account of why I've used certain packages. So similar to what I mentioned before, I utilized R Markdown to share information to different stakeholders, as well as to my line manager and internally within the data science team, as well as ggplot and dplyr, as mentioned before. But I also wanted to utilize more efficient techniques because a lot of this data was quite large, and a priority was also getting it done in a timely manner. So things such as data table and the FST package were really, really paramount in getting through some of these processes faster than you would normally do. And the reason why I've distinctly used separate ones here, as opposed to just using data table, for example, is because I quite favor the dplyr format in terms of readability. And if the process doesn't require high aggregations, then I'll usually tend to stick to dplyr. I did also learn more recently that there is I think it's a dtplyr package which kind of feeds into it, but I do like the distinct parts just so I can see where problems are if that did occur. And then for the modeling process, we ended up with the Profit package from Facebook. And in terms of improving the performance, where I've highlighted parallel lines, hopefully you can see that on the diagram, is where if the computing power is accessible, it will run as a parallel process, and it will try and optimize as much of that computing space as it can. And the reason, for those who are not familiar with the FST package, is where we're storing this data at the moment is on Amazon Workspaces and in an S3 location. And although the cost for S3 isn't that expensive, it's good practice, I suppose, to compress the data. And the FST package is very, very good at reading and writing compressed data within R using multiple cores, similar to the way that data table will use multiple cores to do its aggregations. And then, so in terms of how does the modeling process work? So I mentioned that we have those older and younger cohorts. For the time series forecast, which I've highlighted on the left in little pink circles, this would be customers where we've restricted it to 3 years worth of time series data. And we've done this just to make sure we capture the yearly seasonality and allow for the data sets to be completely cross-validated. And as I mentioned, these would be referred to as our older cohorts. And as I mentioned, the package that we used to do these forecasts was Profit. And this could be done in both R and Python, but it does use Stan in its backend. So if you wanted to parallelize these processes, you would be best using for each or do parallel to support that. And the actual forecasts themselves are quite straightforward in their approach because of how granular those groups are. So it will use a linear growth, periodic change, and some basic periodic holiday dummies. But beyond that, we wanted to originally start it off without any additional external variables such as marketing spend or consumer confidence, etc. So that when we compare against that financial budget, ours is kind of an unchanged view where it looks at the data that we see and makes a prediction based on that without any additional factors included. And then so the next part is the proportionality section, which is for customers that are less than 3 years worth of tenure. So in this section, it would be any customer that has, as I mentioned, 3 years worth of less than tenure, and we can make those predictions on a single data point, utilizing the behavior we see in the past. Now, in the plot that I've used here, it's a bit more simplified than the actual algorithm that we apply, but the general concept is the same. So on the x-axis, you'll have cohort age, which we measured in months, and then on the y-axis, we have proportion of spend during their first month of purchase. And then from there, we can track the proportionality across the cohort age. And it might be a bit difficult to make out, but I've got it from 2015, 16, 17, and 18. And then the dashed line is the average of these. And so using that average, we can make a projection of those future cohorts and how their behavior would look. And as I mentioned, this is a simplified view, but it gets the same message across. And then the last part in terms of tools of the trade is unlocking the value through a POC. So to do this, once we'd got to a point where we were happy with our forecast and we'd tested and experimented with different algorithms, we wanted to present this information back to the stakeholders in a way that they might see it or that it might be served to them on a weekly or monthly basis. So to achieve this, I used Shiny to make a dashboard which highlighted some of the key things that were getting asked during the meetings. So the first of which was a front-facing dashboard, which would have summary information that they might want to use, or people who are more senior stakeholders could get right away. It also included pivot tables for those who are more familiar with Excel, so that they could do the same aggregations that they would have done on the fly through the Shiny dashboard. And then finally, it would just have a very granular input where they can check all the different splits that are possible and look at the confidence for different cohorts in general. And to achieve this, I use some of the similar packages that I'd mentioned before, such as ggplot, dplyr, etc. And in particular for the Shiny package, I focused on Shiny and Shiny dashboard with Plotly for the interactive plots. And the pivot table was our pivot table, but I couldn't find the logo for that one to throw on here, unfortunately. But it is definitely a good package for sharing information with stakeholders that are more comfortable with Excel documents in general. But in general, this was a very good technique for comparing the value for the proof of concept, because as soon as the stakeholders saw this, there was a lot more questions and more engagement from them in terms of what they could now see. And it was probably a recurring theme throughout these projects where until they actually see it, it's difficult for them to imagine how it's actually going to impact the business and also what value it drives right away. So this leads me on to the results and actions. So one of the things that happened during these predictions, unfortunately, was the COVID impact. Now, with time series, you can imagine events like this are difficult to forecast anyway, and it was definitely unprecedented. But one of the questions that we received quite early on and throughout a lot of the project was, what are these new customers behaving like? So given that we are getting these new customers in that we haven't seen before, what will they behave like in comparison to the customers that we already know? So the way we decided to answer this question was through correlation of spend through department to see if there was anything we could pull up or continue to do any deep dive information on. And so the first one that I see here is a correlation by similar year. So the first one is correlated with itself, so it's got a value of 1. But then the next highly correlated year within the same month was 2018, followed by 2019. And this was of somewhat use immediately to some of the marketing teams, because they could look then at what activity they were doing in 2018 for those customers that could be of benefit to the new cohorts. And then from there, we moved on to similar cohorts in general. So not just looking at the same month, but looking at the cohorts in general. And so the one that we noticed, which was quite interesting when we looked further and did a longer deep dive into it, was the Black Friday months, as well as the highly prevalent sale months. So in here, you can see that it was 2018, 11, 2019, 11, 2017, 11. And what we'd noticed was that the spending patterns were pretty much very similar to what we'd see during these Black Friday periods. So high purchases of electricals, for example, as opposed to fashion purchases. And again, this was the type of information that we could share and cater to the different stakeholders from different departments to help them with their information at the time. And also it helped us with our forecast for these new cohort groups, because as you might imagine, this definitely originally skewed a lot of the forecasts because the behavior was so different than what we'd seen in the past. And then finally, the results and actions go in full circle on minding the gap, so to speak. So the original purpose before COVID happened was just to compare what the cohort outlook would be in comparison to the budgeting process. And we wanted to do it at this granular level so that it would unlock additional value for different departments. And what I mean by that is it would allow them to target different groups of cohorts not only if their behavior was less or more than what they'd expect, to see what the reasons were for that, but also explainable differences and CRM insights. So on the right-hand side, I've kind of done a mock-up of how it would have looked when we presented this to the stakeholders. Of on the left-hand side, this was the budgeted amount, and on the right-hand side, to the far right, is what we projected the forecast to be for the next financial year. And then in between, you have the different groups grouped together within 0 to 6 months of tenure, 6 to 12 months, etc. And then from there, we could show where we felt stronger differences were apparent and where we were not as confident with different differences. And just, I suppose, help the business make better informed decisions for the next financial year. I believe that is it. So hopefully that was somewhat interesting.
Great, thank you, Owen. If anyone has any questions for Owen, if you'd like to pop those in the chat, we'll just give everyone a minute to type.
I can't see the chat, by the way, Laura, so if there are any...
okay, I'll read them out.
Oh, apologies.
Yeah, we've got a question. Well, we've had a couple of people saying thank you. From Julia, small question. On slide 9, how do you create these flow charts?
Slide 9. Oh, okay. So this is from a free open source Draw.io. So it's a really good tool for doing flow charts and diagrams, which I pretty much, I think I learned it from a data engineer within our business, and since then I've just kept using it. Definitely recommend it. You can import different PNG files in as well if you have like a business logo that you want to include in the diagrams. But when you start using it, you won't want to go away from it. It is very, very good. I'll type the name and I can find the chat box afterwards as well, just so you...
Okay, we've got another question from Andrew. Can you discuss the advantages of Profit over other time series packages?
Yeah, absolutely. So we did try quite, as I mentioned, when we were looking at the approach, we did look at quite a few different packages. But primarily, I feel like the reason why we chose Profit in the end was the explainability to the stakeholders. So we did try different algorithms that were more complicated, but the difficulty we had was acceptance of the algorithms themselves, because a lot of the departments and stakeholders were quite precious to their approach. We needed to make sure that whatever we were trying to explain to the company was easily understood, even if that came at a bit of a sacrifice to the performance. To be fair, though, the performance drop wasn't massive, and it was also very easy to plug in because it just backends into Stan. So a lot of it is just a wrapper into Stan, and from there you can kind of iterate and loop through Profit quite easily, as opposed to some of the other packages.
Cool, thank you. And we're getting lots of messages of thank yous and great presentation, great talk. I think, we've got one more question from Daniel. Did you find the Plotly visualizations really increase the buy-in from business users?
I would probably say it depends the stakeholder. I definitely am a big fan of Plotly because I do like the interactive plots, but sometimes it can start to get more questions than you want. So it's definitely useful for the buy-in, but then sometimes the buy-in is probably too much and you end up spending about 15 minutes going through different details that they want to find out. And then I definitely say it's a positive, but it depends the stakeholder, I would say, on that one.
Cool, thank you, Owen. And one more question from Tyrone. I know you mentioned you had correlation analysis to cope with the COVID blip, but does this mean that that COVID has destroyed the profit models going forward?
So because we weren't aware, this was at the very beginning, so this would have been around March time when lockdown would have pretty much went into commenced. Now that we've seen like the impact that it's had, we can include different factors and variables within there to associate the effect that COVID had, and we can make projections from the business, the government advice at the moment, as well as medical advice. But at the time, it did mess up the forecasts quite a bit, and so we used those proportionality metrics to adjust them according to what we could see. But it was more of a temporary measure for the forecasting, at least, to say, we don't know what the future is going to be because it's so unpredictable, but at least we can use this as a gauge to say, we know the forecast in the past showed a similar behavior, and then use that going forwards.
Cool, great, thank you. I think that is it for the questions. So thank you again, Owen. That was fantastic. Yeah, lots of messages on the chat saying thank you. Great presentation.
Oh, great, thank you, everyone. Hopefully it was a bit enjoyable. It wasn't too boring.
We're a little bit ahead of schedule, actually, which is unprecedented in an online event. So Adriana, I don't know if you're ready to go with the next presentation. If you could unmute yourself if you're there.
I'm here. Can you hear me all right?
Yeah, I can hear you. You're a little bit quiet, but I can hear you.
Okay.
Great, and we can see you as well. Next up, we have Adriana from the Natural History Museum. Adriana will be presenting on using R to predict global biodiversity loss. So whenever you're ready, Adriana, I appreciate we're a little bit ahead of schedule.
No problem.
I can see your slide presentation rather than the actual, just the slides. I can see like your notes and stuff.
Okay, let's Is that better?
Perfect. Yeah, we can see that.
Okay, yes. Hello, everyone. I'm Adriana de Palma. I'm a biodiversity modeler at the Natural History Museum in London. And today I'm going to talk about how we use R to predict global biodiversity loss. So as human populations increase and we change our lifestyles, we're placing more and more pressure on the environment. So this really leads to greater levels of land use change. And what I mean by that is, we're losing more of our natural forests and grasslands to make way for agriculture and urban areas. But we're also changing the way that we manage our land. So for instance, we're using more pesticides in our croplands and our urban areas are more densely populated. So all of these changes are big threats to biodiversity. So land use change is actually the major current threat to biodiversity, not climate change. So it's really essential that we understand how biodiversity responds to land use change. If we're going to know how much we've lost so far and how much we stand to lose in the future, depending on what decisions we make about how we manage our planet. So there are different ways of approaching this question, but what we've done is not to look at big data in the traditional sense, but to focus on the long tail of dark data. So we've searched the published literature for existing data sets where researchers have gone out and they've sampled biodiversity in different land uses. So biodiversity is, the variety of life. So, they may have sampled different bees or birds or whatever it may be. And there's hundreds and hundreds of these data sets out there. And when we've done that, we've pulled all of these small data sets together to produce the PREDICTS database. Now, each individual data set is, one dot on this map, and it gives us a small kind of piece of the puzzle, if you will, about how biodiversity is responding to land use change. So one data set might be about birds in Uganda, and one might be about bees in Germany. And as we add more pieces to the puzzle, we get a better idea about what the overall picture looks like about how biodiversity in general is responding to land use change across the globe. And now what we can do is use R to fill in the gaps in that puzzle. So pulling lots of these smaller, different data sets together in order to build this bigger picture obviously comes with its own issues in data curation and modeling. And so R really has been an ideal environment for dealing with a lot of those problems. So I'm going to talk today about how we use R to wrangle, model, and visualize that data, but also how we use R to then communicate our results to the public and also to policymakers as well, so that we can start to see some impact from that science. So this is just a very, stylized example of what a single data set might look like. So researchers will have gone into a landscape and sampled biodiversity, a number of sites, so the stars here in different land uses, and they'll have told us for each site what species they found and how many individuals of each species. But there's often data cleaning steps that need to be taken to make sure really that the data are comparable across sites. So for instance, maybe they didn't sample with the same intensity across each site. Maybe they didn't sample for the same amount of time across each site. Or maybe they've given us data, rather than the total number of species and individuals at each site, they've given us data for each individual trap they used at those sites. So these kind of data cleaning problems are really easy to manage with dplyr. And dplyr is also really useful for calculating summary variables for each site. So when it comes to biodiversity, we've often got far more information than we need. So people often just want to know how many species in total there are. So what we call species richness, or how many individuals in total there are, regardless of the species identity. And as I say, those kind of summary biodiversity variables are really easy to calculate with dplyr. But biodiversity can be a little bit more complicated than that. So while we can use dplyr to calculate biodiversity measures for each site, there are so many different ways of calculating biodiversity, and some metrics are much more complicated to calculate, and they need to be done on a study by study level. And when things do get a little bit more complicated, we may need to save some computation power. And when that happens, we often end up using dplyr in combination with something like for each and do parallel. So as I say, if we need to calculate a metric for each study in turn, we've got over 700 studies in the database, and 3 million data points. When we're calculating those metrics, it can get a little bit clunky. So for each is just, it's an alternative to a for loop, and we're just telling it to run each study in turn and then combine the results by rows, and telling it to do it in parallel. And then within the curly braces is the code that we need to calculate the biodiversity metrics. And then before we've even started, we've told, code from the do parallel package how many cores we want to use to run this parallel loop. Now, an alternative that we've also used is data table, which is really computationally efficient. So depending on the analysis and the purpose of it and the visibility of it, we've used both approaches really. So for other biodiversity measures, it's about the characteristics of species that matter rather than the identity. And in ecology, we're often missing a lot of information about species characteristics, particularly for plants and insects, which make up the majority of biodiversity. So tools to fill in that missing data are really, really useful. So Miss Forest is a tool, it's a package that imputes missing data using random forests. And, it's particularly handy for us where you've got a mixture of both categorical and numerical data, which for, ecological data sets for, the characteristics of species, that's pretty much, the standard. So, for bees, we'll know whether the species nests in a social sense, like honeybees, or whether it's solitary, or sometimes it can be both. But, we'll have numerical data like the body size. So, Miss Forest is a really useful tool for filling in that data. So we've got much more options about, what biodiversity metrics we can calculate. Now, once we've got all of our data, we use R to model the relationship between biodiversity and land use. Now, because our data set is actually, as I said, it's a combination of these smaller data sets, we need to account for that structure. So, each data set will focus on different species groups using different methods, and, they'll be from different regions and different climatic variables. So, there's a lot of variation there that will lead to differences in our response variables, so in biodiversity, but potentially also in how we expect biodiversity to respond to our explanatory variables, so to land use change. Now, R is, really useful for this because it contains a number of packages that allow us to account for that heterogeneity in our modeling by using mixed effects models. So just a couple of the packages that we use are LME4 and GAM4 to do that. So the top line is from LME4. So you can see it's really similar in syntax to a linear model, but we've added, in parentheses, a grouping variable G, which in our case would be study identity. And, that accounts for the structure of our data set, and it allows, it says that we know that biodiversity varies across studies. Now in GAM4, we can do something similar, so we can account for that structure in our overall data set, but it adds an additional level of flexibility by allowing us to have relationships with continuous explanatory variables where we don't know the shape of that relationship and we don't have to define it in advance. So rather than constraining it to be a linear relationship or having a particular curvature, GAM4 will use the data to estimate what shape that curve should be. So these two functions really provide, a lot of flexibility, but they're also, a robust way to account for the heterogeneity in our data while letting us estimate the overall relationship between biodiversity and land use, which is, you know, the overall aim of our work here. So once we have our models, we can use BASE or ggplot2 to visualize the results of those models to show the relationships between biodiversity and land use in a way that's a little bit more easily understood. So, you know, here we've taken the estimates from our models and we're showing them relative to a baseline. So in this case, primary vegetation, which is the, you know, the natural or the pristine state. So, you know, what we expect the world to look like if humans had never interrupted nature. So, you know, for instance, we can see from the models that if we go from primary vegetation to pasture, we lose about 40% of the biodiversity for this particular metric. So, you know, given those relationships that we've now got estimates for, you know, you can imagine then that for any given grid cell on Earth, if we know how much primary vegetation there is, and we know how much pasture there is, we can now predict how much biodiversity should be in that grid cell. So, you know, that's essentially what happens in our prediction pipeline. And this is the one point really where we've moved out of R and into Python. And, you know, we used to have this in our, you know, quite a few years ago now, but it was just too computationally intensive, and it took hours and hours to run versus, you know, the 20 minutes to run hundreds of years of projections in this Python pipeline. So, you know, this pipeline essentially, it takes an LME4 model that we've saved as an RDS file. So, you know, similar to those estimates that you've just seen, and it combines it with spatial data that corresponds to the explanatory data in the model. And then it outputs spatial projections of biodiversity. You know, so at the moment, this pipeline is a little bit fiddly to use, and, you know, we have a lot of students that come in and out of our lab. So, you know, I'd be really keen to have a way of running this pipeline in R, so students don't have to learn, you know, they don't have to go in and out of tools. So, you know, maybe using Reticulate or something like that. So, you know, I'd be really keen to hear experiences from people using that, or any suggestions for how we could, you know, maybe integrate the two tools. So, you know, I'm sure you've all seen things like this. So deforestation in the Amazon, because, you know, from satellites, we can see trees as they're being removed, but we can't see biodiversity. You know, you can't see the bees and the birds as they're being removed from the sky. But more and more, we're really getting fine scale land use products where for any grid cell, you know, maybe a 1 kilometer scale, you know, we'll know the percentage of different land uses present. And so given that information, we can predict how much biodiversity is left. And so we can produce something like this. So now, you know, we're not just seeing the deforestation in the Amazon, but we're seeing the biodiversity loss as a consequence of that deforestation. And, you know, as the land use products like the one used to produce this become available, you know, year on year, we can start tracking biodiversity loss year on year. So, you know, we've produced outputs like that for scientific papers relatively regularly. But now we're really starting to use R more and more to communicate our results. So, for instance, this was a piece of work in collaboration with many biodiversity modelers and land use modelers around the world to see how we could undo some of the biodiversity damage that we've done so far. So, what happens if we protect more of the world's land, or restore more degraded habitat? What happens if we all reduce the amount of meat that we consume and waste less in our agricultural chains? So we found that Shiny and Plotly have been really great ways to engage the public a little more with our results. So they can play around and really see what happens to biodiversity as a consequence of their decisions, because often they see a lot of our results as a bit doomsday and a little bit negative, and it's hard for them to see what they can do about it and how they can engage. And so Shiny and Plotly have really been a good way to get them a little bit more involved and see the science from a different perspective. And it gives us a way of providing additional information about the science that's a little bit more easy to digest than a scientific paper. So we've also used Shiny and Plotly to make it much easier for policymakers to access biodiversity metrics. So a lot of the metrics we produce are used, for countries to track their progress towards targets, but they can also be used, potentially in terms of planning next decisions. So, this was work to assess how much damage we've done to biodiversity so far and how much biodiversity might change towards 2100, under different futures of climate change and human development. So with this Shiny tool, policymakers and NGOs and anyone who's interested can basically go on and learn a little bit more about the biodiversity index, about the different scenarios, so the different futures, and they can pick their region of interest and get the graph that they need to download and then use it in their own work, freely and easily, without them needing to contact us. So something that we haven't done yet, but I'd really like to work on, and again, any advice would be great, is to have a reproducible pipeline to produce spatial outputs of our results really easily. Because those curves that you've just seen, they're obviously based on maps for multiple time points, and often we'll get requests for people wanting a region of interest or a country of interest or even smaller than that. And at the moment, we're providing those spatial outputs as requested, but it's time consuming. So it would be really great to have a tool where a policymaker or an NGO could just upload a shapefile of their region and then download the cuts of their outputs, similar to that Shiny app. But with that amount of spatial data, it might be a little bit tricky. So our database is, it's already fully openly available, and we're very committed to making Predix as transparent as possible. But that's not really the end of the story for Predix as a database. We deliberately developed it so that it could be easily linked to other databases, and again, R has been really invaluable because it's got a number of packages that make that linkage really, really easy. So for instance, because all of our sites have geographic coordinates, you can use the MODIS tools package to then download satellite data from MODIS for each of our coordinates. So you can link our biodiversity data with vegetation indices from MODIS. Or you can add in additional biodiversity data using the RGBIF package, or you can, standardize our species names in a slightly different way using the TaxSites package, and then link it to additional taxonomic databases. So, as I say, R's been really useful to link predicts with other data, and then you can go around that whole process again, go around to wrangle, model, visualize, and communicate. So I've spoken about how we've used R in our pipeline, and if you'd like to see some more examples of our code kind of from start to finish, as an example, you can go to our GitHub tutorial for one of our biodiversity metrics that we produce for policymakers at the bottom there. And I think I just want to finish, I suppose, by just highlighting that I think in ecology, I think we used to mainly use R to gather the evidence. It was about preparing and analyzing the data. But I think more and more that's not the end point. We're using R to share that evidence so that all of us can make more informed choices about the future of our planet. So thank you very much, and I'd love to hear some questions.
Thank you so much, Adriana. Would you like me to read the questions to you, or would you like to read them out yourself?
If you could read them, that'd be great.
Yeah, sure, no worries. A question from Beth. Have you tried the I don't know if it's a pronunciation, or the INLA package to fit spatial models?
Oh, I have not yet. I've played around with it, but I haven't yet. So that's on the cards. We sometimes use NLME, but it's not as flexible as the INLA package. So yes, I would like to develop that a little bit more.
Okay, we've got another question from Tim, who said, thanks for the interesting talk. How far back does your data go, and are there plans for collecting more systematic data going forward?
So the biodiversity data that we've collected, we deliberately tried to focus from 2000 onwards because it could be linked more easily with MODIS data. So most of it's from 2000 onwards, but because the focus then is on estimating the relationships, we can then backtrack those relationships as far as we want. So the predictions go back to 900 AD, which the land use data might not be particularly accurate back that far, but that's how far back we can go in terms of predictions. In terms of gathering more data, we'd love to continue gathering more data. So, we tried to make the database as representative as possible in terms of, the species and also geography. But there's still some big gaps in, Africa and Russia and China that we'd love to get, but funding for these kinds of long-term projects is hard to come by, unfortunately. So and it's a lot of manual data inputting. So at the moment we're not adding more data until we get more funding for that, unfortunately.
Okay, a question from Amanda. Have you got any resources that can be shared for education purposes, for example, to share with schools or universities?
What sort of resources would you like? So we haven't done a lot of work in terms of creating bespoke resources. but it's something that I'd, like to look into, starting in the new year, really, to again engage a little bit more. So the Shiny apps has been, for the public, has been kind of the start of us sharing our results with those kind of audiences in mind. And we've been trying to make walkthroughs for students, analysis walkthroughs for students, but it's mainly been with ecologists in mind. So I'd love to hear from anyone outside of that sphere in terms of what sort of resources would be useful, because the biodiversity crisis is becoming much more widely appreciated and acknowledged, but and I think we're in a good position to share information, but I'm probably not knowledgeable enough right now to know what resources would be most useful. So I'd love to hear from people to let me know what you would like.
Okay, we've got a question from Andrew. By the way, if I read out a name of a package incorrectly, I apologize. I'm not a data scientist, so I'm not familiar with a lot of these. He asked, do you control latitude using the IME4 or GAM4 package or earlier in the pipeline?
No. So usually it's not necessary, because the way that the analysis is run, the data, if you kind of imagine that because we're grouping the data by study, we're looking really at, within a study, how does land use affect biodiversity? And within a study, latitude, geography doesn't vary that much and climate doesn't vary that much. So we don't need to account for spatial variation. And, we will test our models for spatial autocorrelation when they're run. And, we find that it's not an issue.
Okay, thank you. Elizabeth asks, do you find it difficult to communicate the importance of your results to others in order to make changes to benefit the environment?
So what we find is, we don't find it difficult to communicate the importance, because, I think many people acknowledge the importance now, but certainly for the public, it's difficult to get across what they could possibly do, because, when we talk about global biodiversity, it's at such a scale that, it's easy for them to think, well, it's not, what on earth could I possibly change about this? Which is why, that Shiny tool really engaged them in a way that we hadn't seen before, because, they were making choices, even choices in a tool, but it was choices that they're making and seeing changes. And then, in the tool, we're telling them about how that translates into choices they can make. So, it's been a different way of us thinking about our results, because, for us, we're not trained as communicators, and so we've come from thinking about, biodiversity and the importance of, land use change on the species, and not really thinking about the human aspect of it. So it's been a challenge, and for policymakers, I think the challenge there has been getting across the immediacy of the problem, because a lot of our results have been showing that if we make changes quickly, there's potential to undo some damage, but the longer we wait, the worse it gets. And whether we'll see any changes that come from that, I don't know yet.
Okay, great. Thank you. We're out of time with Adriana's slot. Adriana, there are a couple other questions in the chat. I don't know if you're available to answer those while the next presentation is going on, but thank you again for presenting. That was brilliant. Okay, so next up we have Jeremy Horne. Jeremy, you've presented at pretty much all the old conferences, I believe, so an old hat. Also, if you're in or near the Brighton area, you should check out Brighton R, which Jeremy runs. Jeremy will be presenting building an engaging email marketing campaign using R. So whenever you're ready, Jeremy, if you'd like to unmute yourself and take it away.
Perfect, there we go. I think I'm unmuted now and I think my screen is shared. So we'll have a thumbs up or something, but if everyone can hear me, excellent. Thanks very much, Laura. Yes, do come and check out Brighton R if ever you're in the Brighton area, or even at the moment, come and check us out online as well, because obviously with COVID, we've turned into an online community and we are planning another event shortly, hopefully. So good morning from sunny Hove. It never rains in Brighton and Hove, or so somebody told me just before we moved down here, and how wrong they are. This is a really weird one for me, because actually when we sat down almost a year ago to the day now to plan our very first Brighton R event, we thought to ourselves, maybe, just maybe, one day we'll manage to get an Earl in Brighton. We might just manage to get an Earl here. Now, I'm not sure when we said that what we quite had in mind was me sitting in the box room of my house with all my beautiful Liverpool football memorabilia around me. But you know what? I'll take that as a step in the right direction to getting an Earl in Brighton. I'm going to talk to you today about how you can use R to optimize your email marketing. But before I do that, just a little bit about me. If my screen wants to click on, there we go, it works. Technology works, so it's always a good thing. So as Laura mentioned, and as I said before, I am a co-organizer of Brighton R. You can see the beautiful orange hex next to my face there. I've recently gone freelance, so I call myself a data strategist and data scientist. I'm sure a lot of you on the call, having read all of the comments earlier on during the keynote, are familiar with the concept of data science. Data strategy may be a little bit more of an unfamiliar term, but I like to say that I help people get smarter with their information. Now, obviously, that's a load of buzzwords, but it's something that I've been doing for the past 15 years of my career. You might have guessed already, I'm a little bit of an R lover. As Laura said, I'm an Earl regular. It's not quite every Earl, but this is the 4th time I've been here. I'm here again, and obviously I've got my beautiful R Studio t-shirt on as well, one of my many in the R collection of t-shirts. I'm a mad cricket fan, really, really sad I couldn't see any live cricket this year, obviously due to COVID, but I'm a big fan of the Cricket R package as well. Could talk to you about that all day if you like cricket, but that's another talk and another story for another day. And I'm also a beer connoisseur. You can't really have Earl without talking about beer. I'm really missing all of the face-to-face beers that we could be having, putting the R community to rights as we usually do. So hopefully next year we'll be able to do Earl with a beer in our hand and talk about everything and anything in the R community. As I mentioned, I've spoken at Earl a few times previously. You might have seen me in 2016 talking about how we implemented real-time media campaigns using a regression model in R for cough and cold products with error rates that shouldn't be sniffed at. In 2018, I was talking about how we managed to unlock £5 million of revenue for a UK hotel chain, again using R. I believe that talk got a great reception. And last year in 2019, I was talking about building a data science team around R for my then employer, Rocket Mill. This year I'm back and I'm talking about email marketing. And email marketing is probably something that everybody on this Zoom right now has been exposed to. In fact, you've probably been exposed to it today already, but more on the receiving end than those of you that have been exposed to it on the sending end of the emails. And email marketing is when you promote your business or your products using email. So if you think about how you might have been exposed to it today already, you may have received messages in your inbox telling you about all the concert tickets that you could book or indeed not book due to COVID this year. You might be subscribed to various fitness and well-being mailing lists that send you an email on a weekly or a monthly or some kind of periodic basis. But you'll get a lot of those emails. They'll all come into your inbox on a day-to-day basis. And that's because it's really easy to mail people in bulk. In fact, it's so easy. And one of the reasons is because it's cheap. According to Info Management, it costs less than a penny to send an email in the UK. And if you think about it, with an email, there's none of this massive bump that you have to do for any of the other marketing channels that you could operate in. You just have to get someone to write the email, put a few links into it, and then that can be kind of repurposed. You can send it to tens of thousands of people. So it's really cheap. But on the opposite end of the scale, it's also really hard. If you think about traditional marketing techniques, let's take direct mail. Let's take one where you get all that bump and you send somebody a really nice glossy pamphlet in the post telling you everything about your brand and what they can do. And that costs you £3 to £4 to produce each one. Then there's mailing costs on top of that. And then you're probably going to give them a prepaid envelope to order whatever it is that they want. So that's really expensive, but perhaps it was a little bit better. It was more directed than, say, an email. And then if you think about really, really old school marketing, think about on the street corners, the charity people, the chuggers, as you call them, trying to engage you in conversation and make you sign up to charity donations. Probably not happening as much now. I haven't seen it over the last few months for some obscure reason. But when you market in that way, you've pretty much got the conversion from the second the conversation begins, because these people are really good at converting people. And so that kind of marketing's easy. But email marketing is a bit harder. Campaign Monitor have produced surveys and statistics on email marketing in the UK over the past few years, and 17.5%, so just 17.5% of emails that are sent are opened. Now, when we say open, that's just scanning the contents of that email. It's having a little or a quick browse of what's in there. You're not looking into the email in too much depth. You're not potentially going and clicking on links and purchasing. And when we talk about clicking on links, only 2.4% of people in the UK click on an email that they receive. So let's just put that into perspective for a second. For every 1,000 emails sent, only 24 of them are going to be clicked on. Now, when we say clicked on, that might be clicking a link within that email. That might not necessarily be going on to make a purchase. You might just click a link, go onto the company's webpage, browse a bit of information, and still not purchase. So even fewer than 24 people will make a purchase and engage in some kind of transactional behavior with the brand. So it's really hard. And I get brands come to me regularly and say, well, how can I make my emails more engaging? What can I do to make more people click on my emails and purchase and transact with my brand? Now, I'm going to talk you through a quick example. I can't talk too much about the client or the company that I was working with, but I can talk you through an example. And for those of you that have heard or seen me talk at EARL or Brighton R or anywhere before, you'll know that I never miss an opportunity to get my son into an R presentation. And of course, today is no exception. I'm going to talk to you today about a childcare brand. And I thought, as you've probably seen from my presentation so far, there's quite a few stock images in there. And so I thought, well, rather than put another stock image, let me get a real baby photo, a photo of my baby. He's now 4. He is fully coding within R. In fact, he started when he was 2 years old. And I believe he is the only child that goes on play dates and asks his friends if they've heard of the Tidyverse. If there are any others out there, do get in touch with me. We need to get some kind of R play dates going at some point post-COVID. And he's also really excited. So he'll be coming home from school at 3 o'clock this afternoon. And he's already told me he's really excited about coming to his first EARL. So for those of you that are still on later on in the afternoon, keep an eye on the camera. He'll be waving, listening to the talks, so you can find out a little bit more about the Tidyverse. But anyway, back to email marketing. And how do you make your emails more engaging? Well, you need to start by thinking about what you can control within that email. And there's really 2 main aspects that I want to focus on today. So the timing of the communication. When do you engage with your audience? Clearly engaging with people at, say, 3 a.m. may not be the best time to do it. But what time and what day should you be thinking about doing this? And the second side of it is the content of that email. So the content could be the text, it could be the links that you put in that drive people to your website. It could just be something really simple like imagery, but content's really important. That's your chance to get in front of your audience. That's your chance to tell them what you want to tell them. And of course, I'm sure there are others of you that are on the call that are pointing out There's other things you can control. So there's things like the subject and the address. I'm not going to focus on them today, but yes, there are other things within an email that you can control. And of course, the best way to optimize all of this, we're at an R conference, so of course the best way to optimize it is in R. And so let's talk a little bit about how. So starting with the timing of the communication, there's two aspects that you can look at here, two ways that you can control the timing of a communication. So there's the time of day, the hour that you send it out at. What hour is your audience going to be most responsive? And what day of the week should you contact people? Are people more responsive on a Monday at the beginning of the week, on a Friday at the end of the week, or maybe the weekend or somewhere in between? And of course, that's something that you can use R for, and it helps in many, many different ways. And the first thing that you need to be able to do within any of these challenges is connect to your database. And when I say database, I'm talking about your CRM. Now, Salesforce, which is one of the most popular CRMs out there nowadays, has a lovely R connector with the Salesforce R package that can help you do that. HubSpot, another popular CRM I know, has an API and an R connector within it as well. Obviously, not all CRMs, not everybody's on, say, the biggest or the craziest Salesforce CRM. You might have a smaller or a different CRM solution, and you, as long as it's got an API, you can use R to connect to that. HTTR and JSON-like combined are really, really helpful in bringing that data alive. So once you've connected, you need to extract email data from your database. Now, when I say email data, this is information at an individual level, at a person level. And you need to extract the sends. So what have you sent them? And crucially, what time did you send this email? And then on the flip side, you want to know, was that email opened? Potentially what time it was opened as well? And was that email clicked on, and what time it was clicked on? Now, you might think, I've got all of this data, I can start playing around and analyzing it. But one word of warning that I call out at this point is time zones. And I want to go back to an example when I worked with a brand earlier on this year, and I was working with their email data, and I got a schedule of all the email sends and a schedule of all the email opens. And one piece of advice I give you, because this is something I do whenever I'm working with a brand on email marketing, is sign up to that mailing list yourself. Experience that mailing list from the perspective of a consumer. It helps you understand what they've received and build up a few theories and hypotheses before you analyze the data. It also helps you with the time zone. So I signed up to this mailing list and I was looking at it, and it was really odd because looking at the send data, I was being sent the emails at the time they arrived in my inbox, but I was opening them and clicking on them about 4 or 5 hours before I was even sent them. And I thought, well, this isn't right. How can I open an email before I've been sent it, looking at my own data? And it turned out that the sends were in UK time zone, but the opens and the clicks were in the US or an American time zone. And so if I hadn't have standardized those time zones, I could have given some recommendations that were potentially 4 or 5 hours out in terms of the most optimal time to send emails. So just because you're dealing with a database in a single country, in a single time zone where everybody on that database is, say, UK based, doesn't necessarily mean that it's all, or the whole database is in a UK time zone. So do check very carefully. Once you've done that, you can let the tidyverse eat it for breakfast, and you can start doing some summaries. You can look at hours, you can look at weekdays, and you can understand when the best time to send it would be. Now, in this case, the best time to send it, emails relating to childcare information, was on a Monday. So perhaps you've been at home all weekend with the kids, they've driven you mad, you've gone back to work on Monday, and this salvation email arrives in your inbox, explaining to you a few things, a few tips and tricks that you can try throughout the next week. And the times that people were most responsive were 3 to 6 p.m. So when you're collecting the kids from school, when you're coming home from work, that's when you've got time to really review your personal inbox from the day, probably not in the morning. So we managed to feed back to them, get your content out on a Monday, get it out between 3 to 6 p.m. because that's when people will read it, they'll engage, they'll click on it, and they'll go through to your website and purchase. Moving on and talking about the content, and I've got choose your words here. Words are really important. Content, most of that content will be words. And so there's a lot that you can look at when it comes to words and content. And the first thing is phrases. So if you think about any brand, you've all got slogans, you've all got a certain way of speaking and a way of positioning yourself. But how should you use those phrases within your communications and within your emails? How should you position your brand and product as well? Do you want your emails to talk about you as a brand and what you stand for, or do you want it to talk about the product and what their benefits are to the consumer? Word count's really important. You want to get the optimal word count within an email. Use too few words and you risk not telling them enough about your product for them to want to engage with the email and purchase the product. Use too many words and you risk telling them too much in the email that they don't go through and click onto your website. Or worse still, you risk almost shutting them off because they'll look at the email and think, well, this is really, really long. I'm not going to read it at all. External, or in this case, product links are really important. So how should you link to your products within the email? Do you want to talk about all of your products together, or should you just talk about one or two products at a time? And then one other thing that perhaps not everybody thinks of is the tone and the emotion of that email. Now, I appreciate that that might not be relevant for all brands, but particularly when you're looking at childcare, that's quite an emotive subject. People, when they think about their kids, when they think about how they treat their kids and what they do for their kids, it's really, really emotive. And striking that right tone within the email is really important. Now, if you put a lot of these together, obviously that boils down to a lot of text analytics. And I know that quite a few of you will have done the workshops on previous days of VirtuEARL, and you might have heard about this package in the top left-hand corner, Tidy Text. Tidy Text is really useful when you're looking at text analytics and being able to understand how words might influence something. And it works on this basis of tokenization. So it looks at individual words. So it looks at breaking down individual words and trying to understand what they mean. And I'd always used Tidy Text up until a few months ago. And I'm not going to sit here and say Tidy Text isn't very good, but I've just discovered a new package that I'd like to talk to you about as well. And that is Sentiment R. Now, I apologize for all you hex lovers out there like me. There is no hex for this one, or there is no hex that I can find. If you are aware of a hex, please share it with me. And if you're aware of a sticker, please send me hundreds so that I can add to my collection a little bit like this. I have many others. There are stickers, in fact, dotted all over my house. My 4-year-old, he loves R that much. He steals my R stickers and uses them for himself. First world problems, eh? Anyway, back to Sentiment R. Sentiment R works on whole sentences. So rather than looking at this tokenization, it looks at the sentence as a whole to extract the sentiment. So let's just take an example to show you how it works. Very, very simple sentence. I am happy. Probably said it all lots and lots of times. In fact, we're probably all happy today because we're at VirtuEARL. Now, if you use Tidy Text and you use the tokenization and you break it down to I am and happy, and you remove your stop words and all of that, that obviously comes out positive, and as it does with Sentiment R as well. Now, a subtle change. Let's put the word not in front of happy. And again, you remove your stop words. So you've got I am not happy. Once you remove the stop words, you just end up with happy. And so Tidy Text would say, well, this is really positive. Sentiment R would look at it and say, actually, there is some kind of negativity within that sentence. So that's why I prefer Sentiment R for the moment. But again, both packages are really good when you're trying to analyze text data. But it's not just about sentiment. It's not just about the positives and negatives that you see here on the right-hand side as well. There's a lot more that you can tell emotively about text. And that's if you use the National Research Council emotion lexicon data. And this is where you classify data based on the 8 emotions that you see here. Naturally, when you're writing an email, you want to get this feeling of trust within your consumers. You want them to trust you as a brand. You want joy to show up on their face when your email turns up in their inbox. You don't want it to promote fear or anger or any kind of negative emotion within your brand. How does that work within email marketing? So going back to my childcare example, there were 2 specific phrases that they would use within their emails. And they had a few emails that used this phrase 1, which said, we can help you manage. We can help you manage with this problem. We can help you manage with your childcare. And phrase 2 they used a lot was, I say, it should be don't worry. You can obviously tell that this The text was written in potentially a little bit of a hurry, but it's meant to say, don't worry. And so if you have a think about these two phrases, and obviously if we were at a face-to-face conference now, I'd be asking for a show of hands, but we can't do that. And I'm not going to try and get a show of hands in the chat because God knows what will happen with that. But you kind of think, which phrase got better engagement? And you're probably all thinking to yourself, yes, correctly, it was the "we can help you manage" phrase. They received twice as many clicks as the "no worries" or "don't worry," whatever it was within that email. But if you think about it, if you think about these pieces of text, "we can help you manage," that is instilling trust within the consumer. You're saying, we can help you, we're your partner, we're by your side. You're giving them that trusting feeling, that helping hand. Whereas if you're talking about "don't worry" or "no worries" or whatever the phrase might be, you're instilling this thought, well, should I worry? What should I worry about? Why should I worry? And it gives the consumer that fear. And so by optimizing their emails towards those that were phrase one, "we can help you manage," they achieved a better click rate. Now, I mentioned before that word counts are fine art. In this case, and in fact, in other cases that I worked with over the past year, 150 words was probably the optimal, or between 150 and 200. If you look at this chart of word count on the x-axis and click rate on the y, above 200 words, your click rate starts to fall, and it starts to fall quite quickly. But it's more than that though, because if I overlay another metric that I looked at, which was the unsubscribe rate, at above 200 words or levels of above 200, the unsubscribe rate starts going up. So not only are you getting fewer clicks, but when people do click on it, they're much more likely to click on the unsubscribe button. So you're getting fewer clicks and lower quality clicks as well. And that 150 to 200 is generally a good rule of thumb from the brands I've worked with recently. How should you position your brand, or how should you even position your products within your brand? And again, what I've seen time and time again, particularly from text analytics, where you look at emails that focus on mentioning the brand name rather than the product name, they don't do as well. People are reading your emails because they want to find out more about your products. Why are the products good for them? Why should they buy them over the competitor? So the email needs to tell them about the product, not tell them about what you're focusing on as a brand. Yes, your brand values are really important, but perhaps they're more for internal communications than to talk at length to your customers about. And the other thing is products. Focus on one product at a time. If you're a brand that has 10 different products, sending out an email saying, here's product one, here's product two, here's product three, that tends to turn people off because they don't know which one to buy. What I saw is when you put multiple product links within the email, no one clicks on any of the product links because they don't know which one to look at. But if you use a single product link within the email, people click on it because it's simple, it's easy, they know what they need to buy. So we've spoken about how you can work with the content of the email and how you can optimize that. I just want to talk a little bit about personalizing that as well. Personalization is really important nowadays. And within this brand, everybody would get 10 emails. So it was an email journey and everybody would get 10 individual emails. They might be spaced a week apart, they might be spaced 2 weeks apart, a month apart, etc. But it was a journey. And on analyzing the data, what we found was that on average, people only opened one of those 10 emails. Now that one email could be the 8th email in the journey. So you've sent them 7 pieces of content and they haven't engaged with it. And clearly what you want to do and what they needed to do as a brand was, if they're only going to click on one email, bring that to the forefront of the journey, capture their attention early. And perhaps if you capture the attention early, they can then click on more than one email. They might click on the second and the third. They might click on the third and the fourth, etc., etc. And then if you've got them captured early on, you could even streamline and optimize it. You could have a 5 email journey rather than a 10 email journey. But how do you predict which email people will click on? Clearly predicting one email in 10 is going to be really difficult. And so I looked at the emails they were sending out, and broadly it's split out or boiled down to 2 categories. So category 1 was informative emails, giving people childcare information, giving people a little bit of, this can help you with a certain aspect or a certain problem, and this can help you with something else. Just informative, lots and lots of information. Whereas the second set of emails were more supportive. Perhaps there were links to mums groups, there were links to online forums where you could talk to each other. And clearly different types of people might need these emails. The parent that's with the child the most might want access to those support networks, whereas the parent that's with the child a little bit less might just want the information, but not need the support of other parents. And so rather than predicting 1 in 10, we split the emails into these 2 groups. And we built a machine learning model to try and predict, is person A, or is each person within your database likely to open an informative email or a supportive email, so that we can personalize that journey a little bit more for them. Now, naturally, I'm not going to sit at an R conference and talk to you about a model that sucked. The model did well. It predicted 90% of email clicks correctly. And so they were able to personalize and streamline their email journey alongside all the text analytics that we spoke about previously. And so, of course, you're probably all wondering, what were the results? If you think back to the beginning of my presentation where I gave you the benchmarks, their actual open rate was not too far off that 17.5% benchmark initially. It was at 16.7%. After all the optimizations were put in place, it almost doubled, just over 31%. And click rates themselves, they more than doubled. So actually their click rate was initially a little bit below that 2.4%. It was at 1.81, going up to 3.76. I'll just summarize very quickly because I'm conscious of time, but there is a lot to look at when you need to create, or in creating, an amazing email. When do you send it? What day, what time should you be sending that? How should you communicate to people? What should the emotion of your brand look like? What phrases do or don't work, and how many words should there be within that? How do you position your brand? The best practice would be to focus on your product over the brand and one product at a time. And what can you do to personalize that content with machine learning? And of course, R can help with all of that. Now, it wouldn't be an R talk and it wouldn't be a talk by me if I didn't do a little shameless plug at the end. I have just gone freelance. I can do a lot more than email marketing. I've worked with customer databases for the past 15 years. I do a lot of reporting automation, so I'm a big believer in the reproducible analysis concept. And I'm also working on R training and business coaching courses, either for teams or on a one-to-one basis, and many, many other bespoke data science projects, but these are the easiest ones to package. So I am available for hire. Do get in touch with me. I'm available on many different forms of social media. So you can find me on LinkedIn, or you can look at my website, www.datacove.co.uk. You can find me on Twitter and GitHub, and I've indeed started my own YouTube channel as well. A lot of the content will be R related, a couple of new videos going up next week too. So do check me out there. Do get in touch if you want to talk further, and hopefully there's time for 1 or 2 questions now.
Great, thank you so much, Jeremy. That was brilliant. Yeah, we've got time if someone's got a super quick question. Oh, perfect. We've got one straight out of the bat from Tyrone. What technologies and tools do you recommend for report automation, particularly when clients insist on PowerPoint output?
I mean, yes, it is really, really difficult if they're insisting on PowerPoint. You can use R to dump your charts into PowerPoint. So I've got a lot of clients that insist on PowerPoint, and I've worked with media agencies where everybody insists on, I don't care what the chart's done in, the final version's got to be in Excel so I can tinker with it. Produce your charts in R and let R spit them out directly to PowerPoint. And what's really good about that is that no one can tinker with your numbers. Your other option would be Markdown. Markdown's really good because if you think about the way that Markdown works, you can have a little bit of text explaining what you're doing. You can have or not have the code if you want, and then have the charts that sit underneath that. So those are probably the 2 things I'd look at. But again, it's really hard. You've got to almost persuade people to lose a little bit of control over having their charts in Excel before you pick the right tools.
Cool, thank you. Thank you so much. If there are any more questions, if you wouldn't mind just popping those in the chat, and Jeremy, if you're available to answer those, that would be great. Again, thank you very much, Jeremy. Cheers.
Brilliant.
Okay.
Thanks, guys.
No worries. All right, next up we have Eryk from the Bank of England. Eryk will be presenting on using R to study financial regulations. So Eryk, whenever you're ready, if you could share your screen and unmute yourself.
Sure. Can you hear me, Laura?
Pardon?
Can you hear me?
Yeah, I can hear you. Yeah.
Okay. Okay, great. Okay. Okay, so hello everyone. I'm Eryk Walczak. I'm a senior research data scientist at the Bank of England, and I'm going to talk to you today about using R to study financial regulations. So let me start with standard disclaimer. The views in this presentation are the authors and do not necessarily reflect those of the Bank of England or its policy committees. So me and my co-authors will work at the Bank of England, and for those of you who are not familiar with the organization, the Bank of England is the central bank of the United Kingdom, and among other things, it supervises and regulates banks. Our job is to make sure the UK has secure banknotes, stable prices, safe and sound banks, and a resilient financial system. So this was a joint project between data scientists, researchers, and policy specialists, and all of my co-authors are listed here. We worked in an interdisciplinary team, and the results are openly available in a working paper and will be published in a journal article soon. So what I particularly like about this project is that it required both data science skills and deep domain expertise. So let me just start with explaining the motivation for this project. So there are several costs of regulation, and as I mentioned previously, the Bank of England is a regulator and supervisor. So we communicate with the private sector who might have concerns about those costs related to regulations. So as I mentioned, there are different types of costs: opportunity costs, compliance costs, and cognitive costs. In this particular project, we focused on measuring cognitive costs related to understanding financial regulation, banking regulation. So what does it really cost to understand what is required? So reading the rules, whether they are difficult or not, how much your mental energy you really need to understand them. But there are also other costs like compliance costs, for example, how much it costs to report certain information, or opportunity costs, which might restrict behavior. But that's not something that this project focused on. So why textual analysis of rules? Where first of all, the data is available. So rules are embedded in text. So data on regulatory costs is scarce, but texts are readily available. So texts are available in the rule books, in different documents, as data scientists would know, we can use natural language processing to analyze large texts and treat text as data. And we used several different types of measures, really. Here, measures of cognitive costs of processing text are grounded in psycholinguistics. So they tell you how people process language, for example, how concepts or operations are processed. And also, we used insights from computational linguistics. So we use measures to capture language processing costs, things like length or different structure of text being used. So the earliest research on complexity of text would focus on length. And this is something that we did here as well. So this is the simplest measure of complexity. So we looked in this project at complexity of regulation, banking regulation, UK banking regulation, between and after the crisis. So we wanted to understand how the regulations changed following the great financial crisis, because the crisis led to changes in regulations of banks, among other things. So the simplest way for us to do it, to measure this complexity, was to look at the length, so how many words there were, and we found here that the length increased from 400,000 words to 720,000 words, as you can see on this bar chart. We also found, which we knew previously, that there are many more sources of the regulations. So after the crisis, EU rules came into were added, whereas previously it was mostly the UK rules which were used. So that was the really high level overview of this complexity. But we wanted to understand a bit more about regulation, just to know what is happening here. So let me just talk you through the agenda. So I'm going to start with talking about data, and then I'll move to measures, explaining the reforms, post-crisis reforms. Then I'm going to tell you about potential follow-ups or next steps, and I'll finish with conclusions. So we created a data set for this project, and that actually took quite a lot of time, because it required not only data science skill but also understanding of the subject, and quite a lot of consultation with the lawyers and people familiar with the matter. So we created this data set, which was very comprehensive, especially for post-crisis time, and we could compare pre-crisis and post-crisis documents, legislation. And we also developed data set that facilitated network analysis. So I'm going to show you how that was done, and how you can use it yourself, how you can use this data yourself if you wish to. So there were several data sources, as I previously shown on the bar chart, and the majority of data used in this project came from web scraping. So we web scraped rule books which were put online by Prudential Regulation Authority, by European Banking Authority, and also quite a lot of PDF documents which contained supervisory statements, so additional legislation. We also extracted links, and most of this analysis was automated, so using tools like RVest, like PDF tools, and a lot of regular expressions. So here you can see a screenshot of the capital requirement regulations, which is fairly well structured. So what had to be done here in this particular example was just scraping this data set and put it in the table, or scrape a lot of rules like this. So here you can see Article 20, and this is the text of this article, and here you have some additional information. So that would be textual information, just really raw textual information. But what is contained in this particular rule is also network information. So you can also treat particular rules as network information. So you can think of this Article 20 as a node in a network, and an edge, a connection to a different node in a network, would be mentions of different articles. For example, Article 143, 151, 283, and so on. So this information was extracted from the text and allowed us to develop a network data set as well, which then we tracked and used in the final analysis. And all of this was done using standard R tools, publicly available, and some function, well, quite a lot of actually custom functions as well. So we scraped the main source of the analysis, really one of several sources of the analysis was the rulebook, which is published by Prudential Regulation Authority and is available online. So here you can see example on the right-hand side of a particular rule. So here you can see Rule 1.1, and this is the text of the rule. So again, this was scraped, and links to other rules were extracted, so that the network data set could be created. And all this code to extract information, especially from the PRA rulebook, was then wrapped in a first functions and then into a package. And now it is available on Bank of England's GitHub page. So you can download it and use it for your own purposes. And feel free to leave feedback if you're interested in that. But this data set can be acquired through this code, and as I mentioned, it's freely available. So go ahead and play with it if you want to have a new text data set or network data set. So the next step I'm going to talk about here is measures. So we use several measures, and these measures can be used to describe any set of regulations, any legal documents I believe. So I think that the same approach could be used to study all sorts of regulations. So some of the measures that I'm going to talk to you about were used to study things like U.S. Constitution or tax rules, for example. But what we did here, what was novel in this project, was putting all of these measures together, both network and text measures. So without further ado, let me just talk you through the measures which we used. So the measures of complexity which were used in this project are derived from several disciplines. So the first ones were derived from linguistics. So we had three main measures: lexical diversity, conditionality, and length. So length being the simplest one, just the number of words. Lexical diversity measures was calculated as relative frequency of unique words, and that tells you about the number of different concepts which increase cognitive costs. So, for example, if you have many different ideas mentioned in a text, many different entities, then you need to have them in memory. So that makes certain rule harder to understand. Conditionality is another measure. So that is calculated as by measuring the relative frequency of conditional statements. So things like ifs or buts. And that tells you about operations. So if you have a rule, for example, that says if A then B, if B then C, if C then D, then more of these conditional statements you have, which we just assume that the harder rule is to understand. So these measures tell you a bit about what we call local complexity. So things that you need to understand while you read a particular rule. Then moving forward, we also had measures coming from network science. So measures about the structure, the network of the entire rule book. So we measured here relatively simple measures like a degree, so number of direct cross references to a rule. We also had degree which was going out of from a rule, and that both of these measures tell you about centrality or context of a rule. And we also used the PageRank, which is a famous Google algorithm, which tell you about the chain of cross reference leading to a rule, which is weighted by their importance. We also used the reverse PageRank, which tell you about this set of cross reference, but starting from a rule. So that tells us about context. So these were the measures that we used, which were based on network science, but we also developed some rules, some measures which were based on law, on legal research. So here we focused on what we called vagueness. So that was calculated as a ratio of very vague terms. So things like reasonable or adequate, things are not which are not specified, because in some cases you want to leave a rule slightly underspecified, just to let lawyers actually decide what is reasonable, what is adequate. So you don't always rules are written often in this way, but writing rules in this way might increase cognitive costs because these rules require interpretation. We also measured precision, so ratio of very precise numerical signs or words, so things like GBP or percentage, and that tells you about thresholds. So thresholds which are used in very clearly defined thresholds, which are defined in the rules. So that tells you about global complexity, which require additional information, which is not available directly in the rule, but which might refer to other to precedents or market practices. So these were the measures that we used in this paper, which are, as I mentioned, relatively simple to calculate. Some of them, so things like I think lexical diversity or PageRank, I think, and degree, you can get functions from packages like iGraph, for example, or frankly any network science packages. Vagueness, as I said, here is just the ratio of terms. So these are relatively simple functions to write yourself. So once we have these measures and we describe the data set in this way, we also wanted to validate the measures, to understand whether the measures that we are using actually tell us what we want to know, whether they are sensible measures. So in order to do that, we used Q&As, so questions and answers, which are submitted to European Banking Authority. So European Banking Authority collects information, collects questions from supervised firms or from other regulators, which about rules which would require clarification. So that was our proxy for complexity. And here I scraped all these questions and I connected the relevant topics, the relevant articles of these questions, so that we could actually then pair the question to a particular article that was scraped previously. So we fitted logistic regression model here, a rich logistic regression model, which you can see specified here. So on the left-hand side, we had the dummy variable, which told you whether there was a question about a particular rule. And on the right-hand side, we use a vector of complexity measures, so measures which I explained to you earlier on. And we also used a dummy for topic to control for non-cognitive costs. And we fitted this model to all rules, all capital requirement regulation rules. And using this model, we were able to validate our measures. So we found that mostly the centrality measures, really the network measures, were the most predictive of whether the question would be asked about the rule. But precision, total sentences, so length were also valuable measures. So things like vagueness or reverse page rank at the very bottom were not particularly useful. But the measures on top, which are on the right-hand side of the dashed lines, were measures which were particularly useful. So using this method, this measure, we were able to validate our rules, which is a measure, sorry, which is quite important when you develop any kind of system to understand legal language, really, or set of rules in whichever setting you work in, really. So that's how we validated our measures. So that's how we know that they were sensible. And once we had this information, well, then we described the reforms, or really how the rules changed after the crisis. So we started with simple descriptives. So here we were able to say that we started with a simple number of words, divided into rules and guidance, which are just different types of regulations, which showed you that the number of rules, that the length increased, which was, I guess, not surprising. That's something I showed you previously on the bar chart. We also looked at unique words, so how many different concepts, new concepts there are, and here we saw the increase as well. We looked at conditional words, so things like if or but, and here we found an increase in that. So here I have just number of words, but relative conditionality increased as well. And we also looked at characteristics of the network. So looking at the nodes or edges of the structure. When we look at the structure of the network, we also found that the structure of the network changed. And I think that when you think about network, it probably makes much more sense to really plot the network. And I think when we plotted network, that's when we really could see the picture of the entire regulation, of how it changed after the crisis. So on the left-hand side, you can see regulations before the crisis coming from one data source. And on the right-hand side, you can see regulations after the crisis, 10 years later, when most of these reforms were introduced. And you can see that not only there are several sources now, so not only Blue Rule Book, but also CRR, capital requirement regulations, technical standards, and supervisory statements. And here you can also see that there is this core, really, of the regulation, which tells you about capital requirements. So this is the yellow blob in the middle. And this is probably not so surprising that it's so central, because a lot of rules would cross-refer to this set of rules. So using this plot, we were able to show how the structure changed and how the regulations actually evolved over this 10-year period. So I think that was a very powerful way of explaining how a large, complicated legal system evolved over time. So to summarize, we have 4 facts on textual complexity of post-crisis reforms. So we found that tighter core emerges in the network of cross-references. So that's the yellow part on the previous plot. We found that legal style limits complexity of language. So the individual rules don't change that much because they tend to be split. And we found that at least 1/3 of rules contain vague terms, things like adequate, and these terms require substantial interpretation. So they need to be interpreted by lawyers or people familiar with the matter. We validated our measures using EBA Q&As, so question answer that I talked about previously, and we also developed a case study on definition of capital, and that is something I'm not going to talk about here now. We're going to describe it in our research paper, which is going to be published soon. So moving forward, where does it lead us? So first, we described the system. We wanted to understand how the system of banking regulations work at this point, but we also can potentially create some suggestions to people that develop rules or who want to change potentially the rules. So at this point, there is an increased interest among regulators, especially in automating the rules, so in implementing machine-readable rules. And traditional solution to regulatory complexity was simplification, but now I think there is more interest in automating the rules. But law requires interpretation. So as I explained previously, a lot of rules would contain words which might be seen as vague, which need to be interpreted, and these rules are not necessarily suitable for automating. And as I mentioned, supervision requires discretion. So not every rule can be automated because non-digitized contextual information is difficult for machines to understand. But nonetheless, we were able to look at this complexity of rules, at the vagueness of rules, and to actually see whether that changed before and after the crisis. So using measures that I talked about previously, so things like vagueness and precision, we demonstrated that vague terms were fairly common, but specific numerical values were not. So that gave us a starting point. So we were able to identify rules which were vague or precise, and we're able to actually plot them to create some kind of description really of rules, and to explain which rules are vague, which rules are precise, or which rules are require certain interpretation, and that could be particularly useful for people that create rules. I mean, this is still very early stage, it's very experimental work, but using measures that we developed, we can identify rules which require substantial interpretation, or rules which contain no vague terms. So here in green, for example, so rules which don't contain vague terms but require a high number of conditional operations, they are relatively easy for machines to understand. They can be automated relatively easy. Rules which require interpretation can't be automated so easily. So this is one way to identify rules, to spot rules which can be potentially automated. So for example, if someone wants to develop an API for certain regulations, then that would be a first step really in doing this, creating this this kind of mapping. So to conclude, we use textual analysis to measure post-crisis increasing complexity. We found that now the rules and entire regulation is larger and more interconnected, but language on individual rules did not become more complex. And we developed an approach to identify where machine-readable rules could succeed. So we could identify which rules are vague, which are conditional. So that allows us to identify these rules. And we also created new data set of new textual and network data set, which can be used by researchers and also other researchers or people working in legal tech space, regulatory tech, reg tech, subtech space, supervisory technology might use the same approach for working with their own regulations with different sets of legal text. So I guess with this, I will stop. So thank you very much. And if you want to, if you have further questions, please ask them now, but you can also email me or reach me on Twitter. And more information about this research, the early version is available in a working paper, which I'm linking to now. So you can read more about it, get more information about it, but we are going to publish a journal article soon, which will contain additional information. So thank you for your attention. I hope you enjoyed it.
Great, thank you very much, Eryk. We'll just see if any questions come through in the chat. Lots of thank yous coming through.
I appreciate this is not the most it's not the most obvious topic. I think it requires in our case at least it requires understanding from the legal perspective, from supervisory perspective. So it was quite challenging for data scientists to jump into that.
That was great, thank you. We've got a question from Tim. Will you be looking to use this work to help rewrite the rules so they can be more conducive to ML?
Yeah, thanks for the question. So I'm not working on rewriting the rules. So I'm a researcher, and people who work on rewriting rules might get some ideas from this particular project. So rewriting rules as understood now, so automating rules, which I mentioned previously, mostly involves using things like API, so that certain threshold or concrete numerical values could be fed into a system. For example, using API, but that's not necessarily the same as making rules more conducive to machine learning, really. If that's what you mean. What is potentially conducive to machine learning really is using the data set of rules, but that requires actually getting the data set, getting text and networks, and then running machine learning algorithms on it. But I'm not sure if that's what you asked about. Okay, so I think there's another question there.
Yeah, is your code on GitHub?
Yes, so we shared part of the code, so not all analytic code was shared. We shared code which allows others to get data from Prudential Regulation Authority rulebook. So if you want to get text or network, you can use that code. And the measures that I mentioned can be calculated using standard R packages. So a lot of functions were taken from Quantida, which is a fantastic package. We used iGraph as well. So network measures, text measures, a lot of them are available in existing packages. So you can calculate them yourself in a fairly straightforward way.
Great, I think that's everything. Again, thank you very much, Eryk. That was fantastic.
Thank you.
Okay, everyone, we've reached a lunch break. I don't know about you, but I'm a bit hungry. I'm going to leave this meeting open during the half an hour. We'll be back at 1 o'clock. So feel free to use that time to chat to someone on the chat function. You can unmute yourself, have a video chat with someone. I'll crop this out of the recording that I share at a later date. So, feel free to use the meeting platform while it's available for you. You can also leave it and you can just click the link and join back in at any time. If you're enjoying the conference so far, let us know on Twitter. We're at EARLConf and the hashtag is VirtuEARL. Picked a nice tricky one this year. So yeah, let us know. I've seen that people are particularly enjoying Kirsten's picture with her dog. So if you're sat with a pet, send us a picture on Twitter. That would be great. And yeah, I'll just pop up the agenda while we're pausing for lunch, but we will be back at 1 o'clock. Hello, everybody. We're going to get started again. Let me just grab the agenda. Hope everyone managed to grab a cup of coffee or tea or something to eat. Okay, so next up is Sergey. Sergey is from Aviva, and he will be presenting on still parsing user agent strings for your models. Use this instead. So whenever you're ready, Sergey, if you'd like to unmute yourself and share your screen. We can't hear you if you are talking. Oh, it's because you're on mute. But now you're unmuted.
Hello?
There we go.
All right, sorry about that, guys.
That's okay.
Yeah, technology fails us all the time.
All good.
Excellent. Can you see my screen now? Hello?
Yes, yep, can see
Okay,
it.
excellent. All right, so thanks very much for joining the session, everyone. My name is Sergey, as Laura said, and I'm going to talk about something called user agent strings. So just to give you a bit of a context, I work at Aviva, as Laura mentioned, and Aviva is the largest and the oldest insurance company in the United Kingdom. Here in the UK alone, we have roughly 15 million active users at the moment, but Aviva has operations in a number of other countries. So essentially, we are a global insurance company. And as you can imagine, due to the nature of our business, we have quite a few people around who deal with data on a daily basis. So a few years back, we established something we called Quantum, which is our global data science practice. And at the moment, Quantum unites over 600 data practitioners globally. And within Quantum, we have customer science, which is the team where I work. And in particular, I lead a group of brilliant data scientists who deal with all things personalization. So that's a little intro about myself. Now, as a business, we have quite a significant presence online. What that means is that our customers can go online, buy insurance products from us. They can check their existing policies, for example. They can check the size of their pension pots and so on. And as for any online business, one of the most important data sets that we as data scientists can work with is what we call clickstream. In simple terms, clickstream data tell us what our users or customers do online, what they do on our online properties. And that's a very important data source because it can tell us many different useful things about our customers, such as, for example, what the intent and needs of our customers are, how much time they spend online, what their typical journeys are, what factors drive conversion on our website, and so on and so forth. I'm sure you can come up with other use cases for such data. A typical component in clickstream data is usually what's called user agent strings. So just to explain to you what that is, for those of you who don't know that, imagine a user goes online, they open their browser, go online, and start interacting with a website. And what happens under the hood, the browser would talk to the server that serves that website through a series of so-called HTTP requests. And those HTTP requests would usually have what is called HTTP request headers. In simple terms, what that means, it's just a set of text strings that define various parameters of a given request. And user agent string is one of those request headers. And as the name suggests, all it does, it just describes the software that is acting on the user's behalf. So that's where the name comes from. The original purpose of user agent strings was the so-called content negotiation. What that means is, depending on the value of the user agent string, the server would know what version of the website, what version of the different pieces of content it is supposed to present to a given user, depending on, again, on what that browser is and many other different parameters that are described in the user agent string. So if you were to look at an example of a user agent string, that's how it looks like. So what you can see immediately here is that it actually contains many useful data points, such as, for example, whether a particular browser is compatible with the so-called Mozilla rendering engine. We can see a bunch of details related to the system in which the browser is running, such as, for example, device, operating system, the version of that operating system, the locale of that system, and so on. We can see what software platform was used to develop the browser itself, and a bunch of other details specific to that browser. Because of that, rich set of data points that one can extract from a user agent string, they got a number of use cases beyond simply content negotiation. One of the most common one is probably web analytics, that is reporting on the traffic composition that then can be used to optimize the effectiveness of a website. User agent strings are also heavily used in traffic management, in particular in situations when one wants, for example, to block nuisance bots and crawlers that try to reach their website, or to prevent click fraud, which is a huge problem in the advertising industry. And also recently, and more increasingly, user agent strings are also used in all kinds of machine learning applications, where people would use different elements from the strings as essentially features in their predictive models. Why such features might be potentially useful in machine learning applications? Well, again, that's because user agent strings, and hopefully you have seen that already by now, they contain lots and lots of potentially useful proxies that describe the respective users or customers. For example, depending on the device, depending on the operating system and its version, we can infer such things, for example, as lifestyle and tech savviness of that user. We can even probably say something about the affluence of that user, again, depending, say, on the device they use. Also, what we can do is say whether that user is actually human or not, and there are methods to do so. And that can be quite useful in many applications as well, as you can imagine. Now, how exactly would we use user agent strings in machine learning applications? Well, I'm sure many of you would come up with this approach straight away. Let's decompose a user agent string into its elements, and then let's say one hot encode those elements and use them as features in our model. Straightforward, simple approach. Unfortunately, it has a number of drawbacks. First of all, it's extremely difficult to maintain high quality parsers for user agent strings. And there are a few reasons for that. First of all, unfortunately, there is no consistent format that people would use to define user agent strings. And also, as you can imagine, over time, we see more and more new devices. We see more and more new operating systems, versions of those operating systems, versions of the browsers themselves, and so on and so forth. All of that results literally in an astronomical number of combinations that one can see if they were to combine the different elements from the user agent strings that can be seen in a typical website. And as a result, from the machine learning perspective, what that means is that we would end up, if you were to use this approach, we would end up with an extremely high dimensional and sparse data matrix. And that's simply not practical to work with, not to mention it would require significant compute resources to work with as well. So what's the solution then? Well, the idea here is very simple. Let's embed user agent strings into a low dimensional space. These days, this, as I'm sure many of you know, can be done in a variety of ways. We have a number of NLP techniques around that could be used to perform this task. But what we found particularly useful in our work is the so-called fast text algorithm that has been originally developed by researchers from Facebook. I'm not going to talk about the details of how this algorithm works. You can find a lot of information online about it. But just to highlight a few benefits of using this specific algorithm. First of all, it's not data hungry. What that means is that with just a few thousands of examples, you can actually train a very decent transformer. This algorithm works really well on short and relatively structured documents, which user agent strings are. And as the name suggests, this algorithm is very fast to train. And also it works very well on the so-called out of vocabulary words. That is, words that have not been seen by the model at training time. But due to the internals of this algorithm, it actually works with such cases very well. And that's what we are going to look at, how we can use this algorithm in R to generate embeddings for user agent strings. This can be done actually using several different wrappers, R wrappers for the official fast text library. But what I would recommend to do is to use the official fast text Python library. And just call it from R using the famous reticulate package. It's super easy to do, as you will see. So what you would have to do first, of course, is to install Python and the fast text module itself. And you can find instructions on how to do that in the official fast text documentation. What happens next, you just load reticulate. It would be probably a good idea to check first whether the fast text library has been set up properly and is available to R. And if all good, then all you do is just import that library into R. And then what happens, you can call all the methods implemented in this library using the standard dollar notation that all of us are so used to in R. So for example, if you were to create an FT object that refers to that imported library, you would do something like FT dollar train supervised and so on. So that's that. And now it's important to emphasize that fast text transformers can actually be trained in both unsupervised and supervised modes. And that's, I would say, yet another benefit of using this algorithm. When it comes to the unsupervised mode of training, you would train a transformer that could serve, for example, as a generic library of embeddings that can be then used in essentially any machine learning model application in your organization and by any of your colleagues, for example. So that's good, but you can also do that in a supervised manner. In other words, in a task-specific manner. Of course, that would require labeled data to train such a transformer, but this is exactly where the existing parsers actually can be of great help. So that is definitely all possible, and you can generate the labeled data set quite quickly. Now, what I'm going to do next is to show you a couple of examples as to how this all looks like in practical terms. I'm going to use a sample of 200K unique user agent strings that I extracted from the whatismybrowser.com database. And here on the slide, you see an example of how this data look like. Essentially, it's just a plain text file where each line contains a unique user agent string. And I normalized everything to lowercase, right? Now, here you can see an example command to train an unsupervised fast text transformer. I'm not going to go through all the parameters here, but just to highlight a few of them. That's how you provide your input data to this command. This is where you define the dimensionality of the embeddings that you want to get in the end. And then you provide a couple of other important parameters, such as, for example, the number of epochs that you want to train your algorithm for, the loss you want to minimize, and so on. So rather straightforward and simple. And then once you have your trained transformer, of course, you can then apply it to new data set, to new data that were not used at training time. Here, you can see one example as to how that can be done. I'm not going to go through all the details here. The most important bit is probably this line right here, where we take that trained model and we use this method, getSentenceVector, to calculate the average vector for each of the user agent strings in our test set that we use here. And here at the bottom of the slide, you can see an example of how those embeddings look like, essentially. So I'm showing the first 3 user agent strings and the first 10 elements of the respective vectors for those user agent strings. So very straightforward, very easy format. Now, we trained this transformer, we calculated the embeddings. What next? Well, of course, the next thing that one might want to do is to plug these embeddings into a machine learning model and see whether they actually help to boost that model's performance. But before we jump into modeling, it's always useful to visualize the obtained solution and understand whether it's actually any good in the first place. And to do that, what we can do is to use, for example, the famous t-SNE algorithm to visualize the resultant embeddings. And here you see one example of using that approach. So here I'm using a three-dimensional t-SNE representation of the embeddings that are of size 32 originally. And each dot here corresponds to a user agent string from my test set. What I've done here as well is I color-coded each of these dots with the hardware label, in particular computer, mobile, or server. So depending on the content of the user agent string, we can see whether it's actually a computer or mobile or server. And immediately from this graph, what we can see is that even though the transformer we trained is unsupervised, it actually figured out that the points in the space that correspond to those hardware types should actually be closer to each other. So in other words, it correctly uncovered the patterns that are actually of use in practice, potentially. Yeah. So hopefully it's quite obvious. So these data points are quite separated from each other in this three-dimensional space. So that's unsupervised approach. Now, as I said, we can also train supervised models. And of course, for that, we need to add labels to data. That's very straightforward to do. All one needs to do is before each document, one needs to add the label in this format that the fastText library expects. Very simple format. So it's double underscore label, double underscore, and then the value of the label itself. And that's pretty much it. And then we apply a very simple, a very similar command to what we've already seen before, except that we are using the train supervised method here. And again, we provide our input data, very straightforward. We defined things like learning rate, the dimensionality of our vector, the loss function we want to minimize, and so on. And then we can, again, visualize the resultant solution, for example, using the t-SNE method. And that's how it looks like in this case. I would argue that this solution is much, much better than what we've seen before, because here we see an even more clear separation of our test examples in this three-dimensional space, which is not surprising because that's what we optimized for. Yeah? We asked our model to actually recognize the hardware types. So that's that. And that's pretty much it. All I've got today, guys. Just to summarize, hopefully you could see from this presentation that the information contained in user agent strings can be efficiently represented using low-dimensional embeddings. And wherever possible, I would recommend to generate these embeddings in a task-specific manner. And in terms of the algorithms you can use, there are many of them, but fast text is one particularly useful and suitable algorithm for that. If you want to reproduce the examples I showed here in this presentation, do clone this project from my GitHub repository. And also, if you would like to connect on LinkedIn, please do so. Thank you very much.
Thank you, Sergey. That was brilliant. Yeah, if anyone's got any questions, please pop those in the chat. We've got a question from Horne. Why use Python implementation and not the R one?
Because under the hood, it's still either the C++ or Python implementation, even if one uses an R package. So all the existing R packages are essentially just wrappers around the official fast text libraries. I just found that using the Python library is particularly straightforward and simple compared to a couple of other implementations available.
Great, thank you. Question from Julia, who said, thank you for the talk. Have you tried doing anything in BERT or similar, maybe a different user case?
No, we haven't used BERT. That's because I guess here we are not exactly dealing with human language. Yeah, it's still pretty much a technical language. It's just a bunch of abbreviations used to, for example, label things like the name of the operating system and its version and so on. So I'm not sure BERT would work here as well as fast text, for example. Not to mention that BERT is a heavyweight thing to work with in the first place.
Okay, I think unless there's any more questions, lots of thank yous and great talks in the chat for you, Sergey.
Thank you, guys.
Oh, okay, one more question. How can we test out the fast text algorithm? Any sample data sets?
If you mean by testing how we can say whether the transformer is any good or not, hopefully you could see during the presentation as to how one could get an idea whether that solution you get is actually any good. If you want to play around with the algorithm itself, do go to my GitHub page and clone that project. You will find a sample data set to play with.
Okay, I think that might be it from everybody. So yeah, thank you again, Sergey. That was great.
Sure, thank you very much, guys.
We're a little bit ahead of schedule, so I don't know whether Harshitha, if you are on the chat and ready to start your presentation.
Yeah, Laura, I am ready.
Hello. Okay, brilliant. Good, thank you. Cool.
Yeah.
So Harshitha is from Beta Access. She'll be presenting on R-Powered dashboards using Shiny for digital health RWE studies. So whenever you're ready, if you'd like to share your screen.
Yeah, I think is my screen visible now?
Yep, I can see like all of your PowerPoint, like the slides and stuff.
Yes, yeah, I'll just start the presentation. Hope this is fine.
Yep, all good.
Yeah. Hi, good afternoon all. Myself Harshitha from White Access. So today I'll be presenting our work on R-Powered dashboards using Shiny for digital health RWE studies. So I am the data visualization lead there. Today's outline would be what we actually do and why is that we use our Shiny or the real world evidence platform. I would start with that and let us know what's the business case used in different places where we use Shiny and visualization, which would give a better insight of what we are doing currently. So as John Tuckey says, the greatest value of a picture is not just seeing it, but which forces us to notice what we never expected to see. So just to start with the quote of what's visualization importance is of all. So who we are, what is Y-Taxis does, just a simple here. It's a multi-award winning digital healthcare research and strategy scale-up company where we do analytics, consulting, localization, and data through registries. So these are some of the work we currently work on. So this is the real world evidence which I was talking about, where we collect data from real patients with a specific disease with the e-consent with there that is being recorded through any particular app with respect to that particular study which we are doing. One of an example I would say is the melanoma, where we are doing in collaboration with Melanoma UK. That's one of it. And then we pseudonymize the data and further have it our sponsors or clients to see how data looks like and what's the spread across the data. So yeah, so this is what when we say real world evidence. So this is what the real world evidence we talk about, where we actually collect the data from real patients about different what is their as a quality of life, what are their symptoms looks like, or different aspects of their treatment, different stages at which they are currently in. So these are different things we take the data from patients. So with all this, where are we with R and with Shiny? So why is that we use R? So one thing which everyone would like to use is because of it's an open source, and obviously it gives a very effective visual analytics when compared to other equivalent platforms which is being used in clinical research. It is cross-platform where we can use Python or any other programming language embedded with R, with Markdown as well, and combining any other tools along with it, like HTML, CSS, and stuff. So, and it's popular among all these statisticians because it is more of machine learning, and any other statistical work could be done more easily. And obviously it has a better documentation and community support. So this is the major advantages of using R in any of the platforms. So here with respect to clinical research. So this is an image here you can see is with respect to R Shiny being used highly. This is an image which I took it from R Pharma, where 2018, most of them, it was from 2018, where almost 45% of presenters were working on already Shiny with clinical modeling, data, drugs analysis. So there's just a word cloud which has been created then. So I think it's not right now which has been popular, but it's been in it's already in talking from probably 3-4 years or more than that instead, especially the Shiny coming to in the. So coming to Shiny, it's an open source. We can build our own dashboards. We have several widgets which could be included in here. WebSockets wherein we have server and client which could be communicated, and most of it is interactive. It's not a static dashboard which we are building up. It's an interacting programming model where you could do more interaction. So being a visualization lead there, I have been working on several D3 projects before, so which makes for me to understand how important interactivity in any given visualization where R can provide. So coming to a business case here, so this is one of the business case I would be taking through. So where how data is flowing from an API to our application. So just putting across, these are the different libraries which we are using in our project. So when a particular API is connected, we use R Markdown to pull the data from the API. We also use Reticulate to write some of the coding there to pull the data from API. Python also we use using our Reticulate. We basically pull the data from the API, live data, and then schedule it based on however we want it. So we have it could be an hour, or it could be once a day, or however data input is. So it's based on how you want to schedule it. You could schedule your R Markdown to run. So once you have, you can either create a CSV file out of it, or pin your data which is out of the R Markdown. So once you have these files or CSV or your pins, that could be further used in your dashboard or your application to do further visualization and stuff. So coming to the specific dashboard here in this business use case, we have used different places where we could. One is the patient recruitment. How is the patient recruitment been across different countries, we could see. And then demographics, how is the gender distribution, age distribution, geographical distribution, and details about the PROs, which is patient reported outcomes, which could be EQ5D, QOL based on the study, which study you're working on, or it could be any other additional PROs as well. So we are also building up additional visualizations, which talks about how these visualization not just gives a representation of what the data is, and also provides insight of what other additional things you could see, which we would be seeing further. So this is just a recruitment dashboard which we have, wherein you could see different countries of how recruitment has been happening across different countries. What's the current total registered, or how many are actually responding to all the questionnaire being asked. So this is just an example of, it's also a longitudinal study. When we're talking about clinical data, it's not just a period probably of about 6 months or so. It's a longitudinal data which we want to see, and also see how the recruitment is happening probably at the start of the study, or any people are joining in middle of the study, or how things are going ahead. So this is an example of that, which is representing in each country how the recruitment is going ahead. Here, here we have used R Shiny, wherein this is the value boxes which we have used, and the plots are mostly of Plotly's, which is a great addition to R Shiny, and it's very simple to add in things as well. So this is a demographic of players, where we have also included the reactive function, where you could add or delete or just have a look at how many male patients are there, how many female patients are there, and also in which age you want to check. You can filter with respect to this with the use of slider, and just have a look at the histogram of those details as well. And this is the country demographic of how many patients are from which particular state across countries. So this is what we have used. This is the leaflet upon which we have placed the shape files and understand of each state level counts. So these are the different packages we have used for the same. Plotly, dplyr. Dplyr has mostly been used in most of the analysis, let's say when a data frame or data table is being used. So which makes coding much simpler and easy to do any further reduction of data as well. So with respect to maps, we have more explored the leaflet part, which was much simpler. So this is a leaflet map in this for the same. So this is one of important things which we saw with respect to the PRO aspect is, let's say for EQFID, there's a particular package in R, which is EQFID, wherein given values of any particular this questionnaire, you could calculate the score for particular individual person. So that is being done by EQFID, which is in value addition to whatever with respect to clinical data, which because you need not go back to a CSV file, convert that data, and then do any formulation for the same. Instead, you just have to pass the responses or the responses given by the patients just to the function. It would give you the score corresponding to each of the responses. So based on that. And further, what we have done is we have created box plots for each of it to understand what's the minimum and maximum values, minimum representing least very less depressed, or the higher value showing that the patient is highly infected with depression or eating or any other variables which is being seen in this particular PRO. So here we also plotted to see how each of the particular PROs or EQFID. This chart talks about particular EQFID score, where each of the we have taken an average of each month to see how at a particular time the score is increased or decreased. So when a score is increased, it says the person is or the patient is feeling better. If a score is decreased, it could be the person is not feeling better. So this we did to understand, especially with the COVID situation, how the patients are actually feeling. Are they feeling better or they are not feeling better? But it could be mental health issue, or it could be not getting proper health, not getting proper medication at right time because of the situation, not being medical, not the GPs are not being medically available immediately once because of all the situation. So we wanted to have a look at that. So create an average at each month to see how it's been going ahead. There are two forms of EQFID, 5L and 3L. Again, with respect to this package, 5L has a lesser country coverage when compared to 3L. This is just for information, which you could have more look at EQFID package documentation, which is available. This is one of an interesting visualization which we came up. This is with respect to melanoma registry which we had, wherein we wanted to see, we have data with respect to different treatment, a person taking different treatments at different interval of time. So we wanted to know at what interval, what different treatments a person has been taken through from, let's say, treatment 1 to treatment 10. So what was the first treatment, what was the second treatment, what was the third treatment? So we wanted to see this as how the pattern of a particular line of treatment of an individual throughout for all the patients in the particular registry. So this is one of an very exciting one which we saw, let's say in by probably people taking radiotherapy in the third in treatment as a treatment 3 are not going far in more they're not going other treatments. It's almost ending there, or it's also here as well, so radiotherapy. So this is one of an very interesting which we saw with respect to line of treatments which we implemented for the melanoma registry. So this was again used with network D3, which is an implementation from D3. Library takes care of all the internal things again. This is a chord diagram which we came up with for, again, melanoma registry, wherein there were different adverse effects a patient would go through because of it could be because of the treatment, radiotherapies, or any of the therapies which they are currently undergoing. So how each stage at particular disease and what are the different symptoms they go through. Let's say for a particular stage 1, there is more of fatigue and diarrhea, which you couldn't see for a patient. That's the highly reported one. And this is the stage 2. With respect to stage 2, this is stage 3 and stage 4, where you can see the fatigue is the highest among all these stages, irrespective of whatever stage you are in. So this is again is one of a kind of visualization where you can see it's not here the category is just between stage and adverse events. You can add multiple categories as well here to understand how the spread is, how each of it are correlated, how the highest frequencies occurred. So we have also written a blog on this. If you are more interested in, you can just have a look at this link below. That's one. This is also one of an interesting one which we came across. So going forward, this is because each registry has its own completion rates, because there are several PROs which we are giving a particular patient has to respond to understand their how effective a particular treatment could be, or how effective the particular treatment they are taking. So with respect to that, we just want to see how patients are completing each of the responses. So this is one of a plot which we came across with respect to Plotly, which is parallel plots, wherein we saw the completion rates across each of the plots. So how well they have completed the EQ5D, ADL, QOL. This is also an interactive plot wherein you can just pick up people between 40 to 90% completion rate, how they have completed the same individual, how they have completed the other PROs. This is an example with respect to a PRO. This could be used in any other scenario as well. So this was again used with Plotly and dplyr for few of the analysis. So yeah, with said this, I want to conclude my talk by saying the use of R, which Shiny has enabled, it's not just any of the front-end developer or anyone to develop a dashboard now. Any even data scientist or R programmer are able to develop super easy dashboards, which is much simpler and stuff. And R being a cross-platform, it enables us more supportive things to use again, and a very supportive communities as well. And as being in a clinical based research or clinical based study we are in, we would require different additional clinical based library, which is mostly available in R as well. As one of an example I gave is EQ5D. There are several additional things with PROs as well, which is also been included here. So yeah, so we are currently been using our Shiny and building up dashboards for clinical registries. So which has been very productive again. Yeah, thank you. So yeah.
Great, thank you very much. If we have any questions, if you'd like to pop them in the chat.
Yeah.
We have a question from Anna. Do you use a validated version of R? If not, any struggles in using R in the highly regulated pharma world?
We do use a validated R because when you're deploying any R dashboards, you need this R Connect, right? So that's been validated with a particular R. R is actually not completely validated for any that way, but it's an R Studio being a very easy one to use. That's a better one, I feel. But R is completely not a validated version of R. If I answered your question right.
Thanks. Just see if there are any more questions. We're amazingly ahead of schedule. A question from Stuart. How much JavaScript do you need to write with D3 in R?
It depends on what visualizations you have to use. The ones which I had done for the chord diagrams or the Sankey plots, I have not used any of the CSS or JS files. It was just network D3, and for the chord diagram, it was just the chord diag thing, which library which I had used, which required no CSS or D3 JavaScript, which was required. But if you need any further modifications to the existing one, yes, you would need additional JavaScripts to include in there.
Hervé asks, some of those graphs are hard to understand. What is your target audience? Do they get training before the rollout or before rollout?
So basically, it could again depend. If it's all depends on the sponsors and clients which we have. So if they're comfortable with those plots, we would again put that across to the dashboard. So again, it again depends on the sponsors how they want it to be. But I mean, being said, I understand few people say it's kind of, let's say the parallel plots are difficult to understand. So, but once you get it, what it is supposed intended to tell you, it's more informative than you think they are.
Naomi asks, how does your audience respond to novel chart types?
Especially the chord diagram one, which we had put it across as a blog, we had got a good response in there. They were happy to see especially the chord diagrams with the adverse events and staging with melanoma. They were happy to see how each of it, which was not known at all, the fatigue and several other being highly prominent. So the response was great for especially the chord diagram, because I'm aware of it because we had put it across in a blog, and which had a good response rate for that. Thank you.
Sergey asks, do you have a dedicated team of engineers who look after the app's deployment and maintenance?
Yes,
How
we
do you,
do.
and
Yeah, we do have a development team where the app deployment, app maintenance, development, everything is being taken care. So yes, we do have one.
and he also said, how do you organize the work with them?
So basically, it depends on our workflow, how we go before standing up any project which has been starting up, where the first thing would happen is the development of application deployment and patient recruitment happens. And then we come into as being a visualization lead, or our team comes in place once everything is out. So yeah, that's how our work is being organized. And also the API, the application development team also provides the API to interact with the dashboard as well.
Okay, unless we have any more questions, I'd like to say thank you very much, and thank you for sharing your presentation. Now we're a little bit early. Emma is due to start at 2 o'clock. So I think what we'll do is we'll have a 10-minute break, just in case people have particular talks flagged. I don't want people to miss out if they're expecting a talk to start at 2 and we're already 10 minutes in. So we'll have a little 10-minute break, and we'll be back at 2 o'clock with Emma's presentation. So thank you, everybody. Emma, did you want to have a quick?
Yes, can you hear me?
Yeah, we can hear
Oh,
you.
great. It's kind of a bit hit and miss. You never know if you're actually gonna be able to. I will just what I'll do is make sure that everything works, and then I'm more than happy to start at 2 o'clock, but it's better than to realize that doesn't work.
Yeah, no, it's good. We've got a little bit of time to just make sure everything's okay.
Yeah. Can you see some very colourful pills?
I can, yeah.
Excellent. Okay, well, great. I'll just mute myself again because now we know it works.
Yeah, just leave this screen up.
Perfect.
Awesome. Okay, everyone, we'll be back at 2 o'clock with Emma's presentation. Okay, let's get going. Next, we have Emma, who's from the UCL and the Health Foundation, and Emma will be presenting on using R for personalised medicine. So whenever you're ready, Emma, if you'd like to unmute yourself and take it away.
Oh, great. Thanks, Laura. So yeah, as Laura said, I'm Emma Vestesson, and I'm here to share some of how we can use R for precision medicine. Just an awkward clicking bit. So let's start with the most important bit. So you can find me on Twitter using this handle. So it's an old weird nickname that I'm not going to attempt to pronounce. I'm a senior data analyst at the Health Foundation, and I'm also one of the R Ladies London organisers. As of September this year, I'm an R Studio certified tidyverse trainer, which I'm very excited about. But today I'm here to talk to you about some of the things I've done as part of my PhD at UCL Great Ormond Street Institute of Child Health. And because this is an about me section, I also just want to highlight that I'm not a pharmacist or a clinician. So when I'm talking about this today, this is a lot more from the kind of data science side. Okay, so for those of you who haven't heard of Great Ormond Street, it's a world-leading children's hospital based in London, and it's very specialist and actually quite digital. So it was one of the first hospitals in England to get this kind of certificate that you can see here, and they've got a digital research environment that aims to bring open source and cloud-based technology into the healthcare arena. And for me, it's been a really, really good opportunity to work with clinicians and pharmacists and researchers to make sure that the research I'm doing I'm asking the right research questions, essentially. So as any good researcher, I essentially took this direct from Wikipedia. So precision medicine is this idea that you want to target the treatment for a patient based on exactly on that patient and not some kind of general group. So instead of a one-size-fits-all, you have something way more personalized. And today we're going to focus on drug dosing. So when a patient takes a drug, if the dose is too low, you end up in this yellow area down here, where essentially it doesn't have a therapeutic effect. Whereas if the dose is too high, you end up in this red area where the patient might have really severe side effects. So where you want to end up is in this green area, that's called a therapeutic window, where the drug works, it treats the disease, but it doesn't have really severe side effects. But for many drugs, it's not really a big problem to end up in this therapeutic window green area. And for some drugs, you might have to calculate the dose based on the patient's weight or age. But there are some drugs that have a very narrow therapeutic window, and then the drug concentration in the body needs to be monitored, and the drug dose needs to be kind of determined in a slightly more advanced way. So you might wonder what this has got to do with data science and R. So actually, you can model how long it will take for the drug to leave the body, and once you know how long the drug is in the body, you know how long the patient is exposed to the drug, and therefore whether or not it's likely to be long enough for it to be in the therapeutic window, but not so long that it ends up being toxic. And these types of models, so they're called pharmacokinetic models, they'll take into account patient characteristics, so age and weight and kidney function, for example, so things that you would find in an electronic health record. And there are actually quite a few statistical models that do quite well in the literature, but only a few cases where this type of modeling or these models or results from them are used directly in clinical care. And that's because getting the predictions from the models for individual patients essentially involves solving a bunch of differential equations, and that's not something that you can just do kind of the back of an envelope kind of thing. So we decided that we wanted to help clinicians access this power of modeling without them having to write any code. So we've used Shiny to build a tool that predicts after how many hours the drug is likely to have left the body. And I think when we've talked to clinicians, one of their main things is they think it can help them understand when it's safe for a patient to either be completely discharged or move to a less intensive ward, so maybe an outpatient hospital, which would then both be better for the patient but also free up space in the hospital. And what we're looking at today is essentially a proof of concept. So we've looked at a specific drug that I'll cover in a bit and a specific model linked to that drug. But we've tried to do things in a way so that it can be done for other models and other drugs. So we've looked at a drug called methotrexate, and the tool that we built in Shiny was actually adapted from an Excel macro that was in use in the hospital, I think actually at UCLH, but that broke. And because this macro was developed, I think, in 2012, obviously Microsoft has been updated. We're hoping that Shiny will be a bit more stable and easier to deal with. So the model that's implemented is based on patients with bone cancer that were treated with this drug called methotrexate, which is a chemotherapy drug that can have quite nasty side effects. So patients got a high dose of methotrexate as an infusion, and then they had blood samples taken to measure the drug concentration over time. And you can see a link or like a reference to the paper on this slide as well, in case you want to read it. So this is the way the app looks. So we've gone for quite a basic or minimal design. So you enter some information about the patient. So I've pre-entered this. So the age and some information about the infusion, as well as how many samples. And then you enter information about each sample, so you get a tab for each one. You can then go to click estimate. And Shiny or R will do all the work for you. So it will solve a bunch of equations, not exactly these ones, but it will solve all the equations for you and return this. So again, this is quite a kind of minimal design, but you get this plot that shows you the concentration of the drug in the blood over time. And it gives you an estimate of when it's likely to be below 0.2, which is a very, very, very low concentration. So essentially it's left the body, as well as a confidence interval. You can also see the data points that you've entered to see how well this model actually fits. And it returns a bunch of parameters, which I think will only make sense to anyone who's actually got a background in pharmacology. But this will hopefully also help the pharmacists and the doctors to understand a bit more about for how long the drug was in the body. We're also returning exactly the same information that was entered for the patient, so that you can actually check that this is exactly what I wanted to enter. You then have 3 options. You can, if you're happy, you can generate a report, which essentially just downloads a PDF of this, of what you can see here. You can decide that you're happy with what you've done for this patient and click on New Patient, which takes you back to the first page with everything blank, or you can click on Edit Information, which takes you to the first page with all this information stored, and you can change what you need to change. So as I said earlier, we wanted to make it really easy to adapt for other drugs. So the way we approached that was essentially to put as much as we could in the global.r file. So this meant that we put all our functions, our model coefficients, and our input boundaries in the global R file. So here's just an extract from our model files, from our global R file. This just specifies a bunch of values that we then refer to in the main app. So there were also a few design principles that we took into account when we started. So the first thing is that there will always be a human being making the final decision on the dose or about what actually happens to the patient. So this is just a guide, but we wanted to make it as easy as possible for that person to use the tool and trust it. So we wanted it to be accessible and easy to use for the end user. We wanted it to be safe, because at the end of the day, we're talking about actual people, and actually children in this case. We wanted it to be transparent, which I think here actually, in addition to people being able to see the code, this is based on a peer-reviewed model, so people can look at whether or not they think the underlying data and the modeling was appropriate, and then decide whether or not they want to use this tool. We also identified some kind of main risks, and this is where the slightly more technical part of the presentation will start. And I will actually assume that you have some knowledge of R Shiny, so hopefully you do. It should be fine to follow along even if you don't. But the main things that we kind of worried about in initial conversations with people was data entry errors, old data being used for new patients, so essentially a mix-up of information, but also users getting frustrated with the tool because there are so many things. I don't know if anyone here works in a hospital, but you have to sign into my understanding is you have to sign into so many things. So we want to make sure that it was kind of not causing more problems than it was actually solving. So the first thing we want to do was actually check the inputs. So for example, if you've got kind of butter fingers, it's very easy for 50 kilos to become 500 kilos. And in a children's hospital, it's very unlikely that you'll have someone that weighs 500 kilos. So we want that to be flagged as wrong. I think another thing that we worried about was that someone would say, look at the dose in the wrong unit. So 12 grams should actually be entered as 12,000, not 12. So we needed the tool to pick up on that. And we've just used validate and need from the Shiny package. And the way it works is you put a need statement, and we had need statements for every input that we put in. And then within this kind of validate function, and if this condition here isn't met, you get this message. And we decided that if any of the inputs are invalid, you don't get any results back, because we didn't want people to get any information unless we thought that what they put in was good enough to return anything. So we wanted users to get feedback as well, because I don't know about you, but there's nothing more frustrating than using software, it not doing what you think it should be doing, and you have no idea why. And this was actually all developed before COVID, but I think for me it's getting even stronger with COVID in terms of the sense of like we're all using so much technology and it just needs to work. So we grouped the different values. So there are values that are outside the range of values that the model was developed on, and that should give you a warning. So if it's something like the original model was based on people aged 4 to 50, if you enter a 55-year-old, you can do so at your own risk, because it's kind of, you're extrapolating, but we still think that a 55-year-old is a plausible age. But we also wanted to stop or warn about values that are nonsensical. So like I was saying earlier, a weight of 500 kilos or an age of 500 years. And we decided to go for no feedback for values that were okay. And this might sound like a non-decision, but actually we didn't want to overload the user with messages. So I managed to record a GIF, which I was very proud of. So this is what happens when you in the first situation where you get a warning. So you can see that it gives you a warning saying that the value should be in a certain range. Here you've put in a valid number, so stays the same. And then as soon as you enter something that's completely ridiculous, it turns red and gives you this warning. And you can also see that we've got something at the moment there saying do not enter real patient data, because there are a few issues we haven't resolved that I'll talk about later. So how did I actually do this? So I built a custom feedback function based on the Shiny feedback package, and I hadn't actually looked at the Shiny feedback package for a while, but I had a look at it today, and it's just such a great package. So I'd really recommend looking into it, because I think it makes your app a lot better. But there are kind of 3 main categories, as you can see, that can happen. So this is the one that gives you the error, this gives you the warning, and this is just telling the function to hide the feedback. So I put this in my global function so that if I ever wanted to change that, I only need to change it in the global function and not everywhere in my server function, sorry. And this is what then goes in the server function. So this just means that any time that this input age is changed, it returns a feedback, it runs the feedback function. So this goes in my server function, and I don't actually have to put anything in my UI function. So this is where I mean that you need to have somewhat of an understanding of Shiny apps, but hopefully most people do. Another quite big concern, partly because it's sometimes really hard to understand the kind of reactivity of Shiny, and we wanted to kind of even though we think it probably works the way it is, just be extra safe. We want to make sure that when someone clicks new patient, all information should be deleted. And to do this, we've put this kind of code in our server function. So from the Shiny JS package, we're using the reset function. So when someone clicks the new patient button, all the inputs and all the kind of tables and plots that we created before they all just get reset to the original value, and the original value was completely empty. So another thing that actually took us a really long time to get right was this concept of, so each sample needs to be entered into the app, but the number of samples differs by patient. So you couldn't just set up 4 tabs, because sometimes people will only have 2 tabs, and it seemed a bit unnecessary to say have 12 tabs if people only entered 2. So what we did was set up this thing where you enter how many samples you have, and then you get this tab panel that creates the right number of tabs for you directly as you click. So you can see that changing. And here you can see the code. So we're taking advantage of the render UI function in our server function, which dynamically creates a number of tabs based on the number of samples. So I've highlighted the input that's being used, and then it just creates all of these tabs for you. And then in your UI function, because you're rendering it, because you're rendering things in your server function, you do need to use this UI output to take it in. You can't just set up a tab panel. So that was kind of the last of the technical bit. So this is just a thing to say that essentially this was the first 5 months of my PhD. So the start here is like this bit is how I started to go out, and I haven't actually touched anything since the 30th of March on this app, but we still have it's a bit unclear what the future for this will look like. Hopefully we'll be more like this left-hand side than the right-hand side, but I still wanted to just go through some of the things that we think will happen next. So we really would like to have some unit testing, just because that's good practice. We want to do some more user testing. We've had conversations with people who would potentially be using this, and they are interested, and my supervisor is a pharmacist, but we think it's really, really important to work with the people who will be using it. We also want to add some additional features, so drug dose recommendations, for example. The plan was always to turn into modules, ideally using the Golem package. And we also wanted to pull the data directly from the electronic health record, and maybe ideally even be able to save things into the record so that we can see that this tool has been used. I think actually the next step for me is to read the Mastering Shiny book, because as I said earlier, I haven't really worked on this for about 6 months, and I think the Mastering Shiny book will be a really, really good asset. And it was being written as I was developing the app, so it's just kind of a recommendation to anyone who wants to do Shiny that this is a really good book. So on a slightly more non-technical side or regulation side, we haven't really figured out yet. There are ways of doing it, but unlike many of the other Shiny apps I've done, where I've just kind of published them to the Shiny.io website, you need to make sure that you keep the patient data safe. So all the data I've shown you today has been completely fake. It's just kind of been like a realistic patient. And we also still need to explore some of the regulations around this. At what point does it actually count as a medical device? There are actually commercial tools doing very similar things, so it can be done, but we just want to make sure that we get all the kind of legal sides right. So thank you for listening, and I want to say a big thank you to all of my supervisors, Joe Standing, Neil Spear and Adam Steventon, and also the Health Foundation for supporting my PhD. So thank you.
Great, thank you very much, Emma. Just to give people a couple of minutes, if you'd like to send Emma a question, please pop that in the chat.
And also, yeah, wash your hands. That's that subtle reminder in the background. Just say, Laura, I actually got my little Mango the cats out to keep me company today.
Oh, nice.
I wasn't at the conference.
I have to say, I haven't massively missed ribboning 500 cats before. Lots of thank yous and nice messages coming through. A question from Eugene. Have you considered using PK/PD models in MATLAB? I know there's quite a large user community in that area.
So I didn't actually develop the model for this. I will probably go for NLMixR, which is a package for PK/PD models in R that's being actually developed. I think MATLAB is a good suggestion. I might look into it if I can't get things to work in NLMixR.
Tyrone asks, is any of the Shiny dashboard code available on GitHub?
It's not at the moment, to be honest. I think we were always going to make it public, but wanted to get some things sorted first, and then because it's been paused, I'm more than happy to share it with people on an individual basis.
Another question. We had an issue with Shiny server physically located in America with patient level information held in America. Has it come up with as a potential issue with hosting Shiny app?
So I think that's the thing. We're not going to go for anything that's not based in the UK, I don't think. So we haven't even kind of considered going down the route of something that's kind of like an official RStudio thing, because I think we're a lot more likely to put it on an internal hospital thing, but we never quite got to the point where we could do that, or like probably host it locally somewhere. So I think it would be an issue to have the data in the US. That's
Naomi asks, after your PhD, who would support the tool?
I think that's a good question. There's actually at GOSH a dedicated team to research and kind of implementing these types of tools. I think it's a really, really good question, because it is a problem when people build things and then disappear. I think actually at GOSH they're quite well set up to keep these things going, and I think especially if it gets built into they've got an electronic health record. But I think it's really important to think about, and that's something that we'll definitely take into account before we kind of launch it, because the thing it was built on before just crashed and no one could fix it.
Great, thank you. I think unless we have any more questions, that is it. Just more thank yous. So yeah, thanks a lot, Emma. That was great.
Okay, thank you very much.
Oh, we have one more question. Do you, Horne asks, RStudio Connect is a licensed product. Doesn't that run against your open source remit?
So I'm not using RStudio Connect. So I'm not sure if I understand the question correctly.
Feel free to unmute yourself, Horne, if you'd like to ask it in person instead. That makes it a little bit easier.
Hi, can you hear me?
Yeah.
Yeah, it's just that we use RStudio to connect to host our Shiny applications. So that seemed to be the way we were suggested to users. So we run it on a Linux server, but it's running RStudio Connect, and we definitely have to pay for it. I'm pretty sure. So we didn't get it for free. So I'm not sure. I guess it's how you're going to host your very shiny app without.
I think one of the options we were looking into before was AWS, which I know we would also have to pay for. Might just be a good point to mention as well that I think RStudio are now giving NHS trusts a discount through the NHSR community. This is not actually linked to my Gosh work, but this is worth knowing if anyone else works for a hospital, that there are actually discounts available for the NHS. But yeah, I don't think we'll go down for we wouldn't go for an RStudio Connect solution, I don't think, at the moment. But yeah, I think sometimes building the app is the easy bit, and then figuring out how to get people to use it and share it is a whole other question.
Great, thank you very much, Emma.
Thank you.
Cheers. Okay, we've got a couple of minutes just before Dave's talk begins. So we'll have just a few minutes break until we get to 2:30. I can't believe that we're running ahead of time. It's normally completely the opposite. Cool, we'll start in just under, 4 minutes, okay? Okay, let's get going again. So next up we have David Goody from the Department for Education, and David will be presenting how our Shiny apps drive operational decision making. So whenever you're ready, David, if you'd like to unmute yourself and get going.
Okay, I'm unmuted, hopefully, and about ready to get going here. So thanks very much, everyone. My name is David Goody. I work for the Education and Skills Funding Agency. So the first question is, who actually are the Education and Skills Funding Agency? We're part of the Department for Education, and we're accountable for £57 billion worth of funding that covers the education and training sector. So primary schools, secondary schools, FE colleges, a wide range of adult education provision and different areas like that. And just to contextualize this, so I said we're accountable for £57 billion worth of funding. The entirety of the defence budget is 45 billion. If you're thinking about unemployment benefits, something that comes up quite frequently in terms of people complaining about where tax money gets spent, that's £2.7 billion in comparison to that. So £57 billion is 8% of government spending overall. It's a very large amount of money. And what I want to talk about in this presentation is within the role of the Education and Skills Funding Agency, a big element of what we need to do is provide assurance that these funds are being spent properly, that we know how they're being used, and that also they're being paid accurately, and the policies that we develop, that we work out how we're going to disseminate that funding, is done as accurately as possible. There's a lot of operational decision making that cuts across all of this, and what I want to focus on is how we use our Shiny apps in particular to really drive some key elements of what's happening in that space. So next up, just kind of a quick bit of information about the setup we have. As mentioned this a little earlier, we do have an RS Connect setup. It's set up with both production and staging servers. We've got 1,250 user licenses, as quite a number of the apps we use sensitive data, which is only available to certain staff members and teams within the Department for Education and parts of the Education and Skills Funding Agency itself. And that's actually really quite powerful, and I'll allude to that a little bit towards the end as well. Our deployment pipelines are set up through Azure DevOps, and that's also what we use for our code management, for sort of our GitHubs around code management and things like that. And from a general sort of management point of view, in terms of what we're doing with RS Connect apps and the R Shiny apps, all of this is really important to us, having that really strong version control in place, and also being able to share and learn from each other's code and each other's bits of work, being able to look across the organization, across sort of the 100 or so developers we've got, and be able to look at how they've used different elements of functionality and be able to work that back through into what we do is really, really important. Having an environment where we can set up test apps and really thoroughly work them through, make sure they're reliable, make sure they're robust, and really run through a lot of detailed user cases before we deploy through is again very important as well. And one of the key elements is making sure that you get apps that do really work and are stable and robust when people are using them. So all of that as a setup for us works very well, particularly the sort of the deployment pipelines that we've got through to both our sort of staging pre-production servers and our production server itself. We've got a huge range of apps that we do across the organisation itself. In fact, so many so we've developed our own internal app store to go and actually kind of summarise all those different elements. There are various ones we use for a lot of the governance and assurance work that are going on. There are ones that we use in terms of forecasting work. There are things that we use in terms of policy development work and different elements like that. A massive range of different elements and applications that we use. I'm, for this presentation, going to focus on some of the mapping work that we've done using our Shiny apps. And in particular, what I want to talk about through this is why really good design makes a really good operational decision. And there was a question in the chat just before the presentation started about saying, do you ever need to justify using our Shiny as opposed to, say, something like Power BI? And within the Department for Education and the Education and Skills Funding Agency, we've got Power BI set up, that's paid for in the licenses. So there is the question of, hey, we've got Power BI, it's a good product, works very well. why do we actually need R Shiny? And the thing that I come down to with that is that Power BI is a really great and a really strong product, but there is always a certain element where it's guiding you through options that have been developed for you. It's, I wouldn't call it a drag and drop style application, but it's something where you are using certain levels of templates and certain levels of design, which are implicit within the way Power BI works. Whereas R Shiny kind of gives us an almost infinite amount of customization and functionality around what we can do with different elements. And what that allows us to do is get the details of what we're trying to do within the apps exactly right for what we have to do. A tiny idea of this is one of the ways in particular by default Power BI will make you want to do click-throughs and drill-throughs. Click on something, go down to another level of data within there, is you right-click, you go to drill-through, and then you work out the option you've got. Whereas within R Shiny, we can do a lot of things about specifying exactly what we want to click to do within a certain app or within a certain part of an app and get it to do that tailored to exactly what people want. And I'm going to take a little bit of a tangent here and make an analogy about why good design and why really good functional design makes all the difference. This here is the Rio PMP 200 MP3 player. It was released in around 1989, had 32 megabytes of internal memory, had a replaceable AA battery, ran on one single AA battery and ran for 12 hours, and has a range of different functionality and buttons all over it and around it here. One of the things you might be able to see just on the top is I've got various buttons there, including a menu button, an EQ button, and an intro button. And I must say, I have no idea what an intro button must do, but at some point, someone thought that was quite important. And we've got lots of different buttons for lots of different functionalities, but actually all those buttons kind of look a bit the same, and actually working your way around exactly what each of those do is possibly a little bit on the klutzy side. Following on from this, we have the Arcos Jukebox 5000, which was one of the first hard drive players that came out, which had 5 gig hard drive within it. Again, you can see something here in terms of a slightly kind of, I would say, random approach to button elements around this. And one of the things the Arcos player is most famous for is the fact that its companion software was so bad that a third-party software was developed by users who were so frustrated about using the one out of the box called Rockbox, and that software has survived the MP3 player itself for many, many years later. And then what we have, as you can probably guess with where I'm going with this, is this beast that you may well recognize. I would argue in many ways this is lousy. It was very expensive. It didn't work on Windows computers, didn't have an FM radio in it, didn't have a replaceable battery, didn't have expandable memory on it, didn't have lots of custom buttons for various things like that. If I was sitting down and drawing out a functional spec for an MP3 player, some of the previous ones I showed you would have ticked lots more boxes than this did. But this is the one that succeeded. This is the one that actually transformed how digital music and music in many ways worked going forward. And the reason it did that is because it understood the user experience. It understood how to make things flow through, how to deliver what people actually needed and that core functionality, as opposed to trying to deliver a bit of everything and cram it in with weird, similar looking buttons everywhere around. And actually, if we go back to that question of why do I like R Shiny, why do I like working with R Shiny apps and developing in that space, is because it allows me to develop that kind of user functionality that in my mind is more the kind of the iPod that transformed the world as to the perfectly functional MP3 player that everyone has now forgotten. I'm going to move through some of the mapping apps and talk about exactly what I mean in that space. So, as I said before, Education Skills Funding Agency, what we actually do is fund a wide range of education providers across England, over 20,000 of those. And actually, there's a lot of questions that often come up in terms of what we need to know about that. And what I'm showing here in the background is a start point of something we've got. This is an application built within R Shiny, leveraging a lot of the Leaflet JavaScript package. There was the first point on this, again, about why I like R Shiny. There is a lot of stuff I'd done with Leaflet prior to working with it in R. To do that, you need to know HTML, you need to know CSS, you need to know JavaScript, and then you need to know some web development stuff in order to get all that set up. And there were a lot of times we developed this, you'd make some tweaks to what you were doing with that leaflet map, you'd deploy it, and then you get a blank screen because something wasn't quite working. The joys of working within R, you've got a leaflet package. That actually gives you a nice shortcut to all the functionality you need to do and interacting with various data sources without having to learn 4 different program languages, HTML, CSS, etc. And we've got it in one place. And then we can host it very neatly and very easily within an R Shiny app, having that talk through to our SQL servers and pull data through from there very neatly. With this one itself, what we wanted to do was do something nice and flexible and allow people to do things easily. Prior to this, we'd had a number of people who were actually coming through and actually kind of having to do things by going and putting some data onto Google Maps or to Bing Maps or things like that. And particularly if you were doing potentially sensitive work, that's not a great space. What we could do with this app was allow people to visualize groups of schools, to allow groups of different education providers on a mapping element, have that classic Google Maps style functionality. You can zoom in, you can put different tile layers in the background or things like this, but actually have it working in a way that made it simple, neat, and intuitive for people to work with. What do I mean by that? Well, firstly, the way this works is you can go in and say, I want to add a group of schools onto this. And I've got a whole bunch of different options here. I can say I'm only interested in schools within a particular local authority. I'm only interested in particular types of schools, maybe primary schools, faith schools. I can filter this down by where there are good, outstanding, or other types of schools. If someone wants to ask me the question about, are there areas of the country where there are no good or outstanding schools, I can fire this map up and literally within about 15 seconds have an interactive visual of all the information we need around there. With all the dots that appear on that screen, I've got options down on the bottom about how I can color code those, whether that's by Ofsted grade, by phase, by local authority, or a range of different things. I've got a number of neat little options here that I can do. I've got drop-down boxes and tick boxes around this. We could have configured this menu box any which way we want. You can see it comes up nicely as a pop-up box triggered from the app, grays out the background. It's a neat, nice bit of functionality. It's intuitive. It works in the way of what you need to go through those different elements of getting to the answer you need and getting to it quickly. Secondly, again, in terms of what you can do, you might have something where you're interested in a very specific range of things. It might be that you've done a bit of analysis and you know that this relates to a specific group of 35 schools, or you've got a monitoring report that you're tracking and something like that. And you don't want to go through the app and say, upload this first school for me, or put this second school on the map or something like that. So again, we built in another little bit of an option here. It's in a button that just says upload data. You click on that and gives you the opportunity to upload a CSV file. And if that CSV file has a column in it with a header that says URN, which is our unique reference number that we use for schools, it will go through and say, I can recognize all of those. I can go and cross-reference those against the SQL database that we've got, which tells me the exact location of that school. And the exact location of a wide range of other different characteristics that we need to know about those, and drops those straight on the map. So we can go straight from a unique identifier to all this other information, which we're keeping refreshed in the background. So it takes the work off the people doing the analysis in different areas of not having to match in all the information in terms of location and all these different things. The app is doing that leveraging and making it really quick and easy for you to get to what you want to, which is some geographical visualizations of what's going on in that space. And you can upload multiple layers in this way. You can set them with different colors. You can set them with different types of labels. You can have a legend with different features on and things like that. You've got all these different elements that you can go and add in, and you can add things in by postcodes or elements like that if you want. Again, there's a range of different functionality that we've been able to kind of build in. And the way you go and access through that is through menu options and different elements that we can customize to exactly how we want them to look in that space. So what do you start getting once you've uploaded some information into this? Well, I could have something where, for example, I wanted to understand about all the different schools in Coventry, which is where I'm based, and I can see how they're spread by different Ofsted grades across here. This case, again, we've got options within this where we can vary the map in the background. So it can be ones that are completely grayed out, so you don't have the map being something that distracts you, or it might be something where you actually want to have a clear idea of the different makeup of the city and areas itself. In this case, you can clearly see by roads and different elements of where we are. So that's a nice, neat kind of ordnance survey-ish type of map that's giving me an idea of a spread of different schools there. Neat, useful in a range of different areas, and something that people can update and access and vary nice and quickly. There's a lot of other stuff we can do within these apps as well. One of the things that we're also interested in sometimes is where pupils come from when they're attending a particular school. This can be useful for a range of different things. Sometimes we're having conversations with schools and other areas where their pupil numbers have been falling over a period of time, and there's a view about actually whether what needs to happen with the school to best support them going forward. You may have times when they kind of say, well, actually there's a new housing development coming in here, and we expect a lot of children from that housing development to attend our school going forward. And actually we can look at all the schools in the local area and see where their pupils typically come from. On this map, the red areas are where the highest proportions of their pupils come from, then the yellows, then the greens, and a smattering of people from the grey areas there. And as you can see, this isn't an unbalanced one. It's not all the red areas around there are the highest ones. It disproportionately pulls people from north of where they are rather than south of where they are. So say if the new housing area they were looking to kind of open up that's being referenced here was a little way south of that school, we can look at that and say, well, actually, that's not something where pupils are typically coming into that school. Therefore, what do we need to think about in terms of the implications that might happen there? This kind of functionality was also very important when there was a process that was done a few years back known as the area review process for FE providers, where there was a view taken about whether there were too many individual providers across the FE sector and whether a better experience for students would be achieved by a certain degree of mergers and rationalization across there. And understanding what was happening about the communities they served in a detailed fashion was really important. On a technical level, in terms of what we've done with the app around here, we've loaded in all the boundary areas. Those could be local authorities, they could be what are known as super output areas, they could be things to do with parliamentary wards and different elements around here. So people can flick between all those different areas, and the app's doing the hard work of managing all the geography around there. You're just choosing the schools. We've also used the apps to query APIs elsewhere. One of the things that works very well in that space is something we've got that gives a detailed information around travel times. So the spot on the center of this map is actually where Coventry University is based, which, as well as running university courses, also runs FE courses. This is linking the leaflet map with an API that then gives us information on the distance people or the time taken for people to travel in different areas. So the purple areas in the center are where you can get to within 15 minutes using public transport. And then by the time you get to the yellow areas, these are the ones that you can get to within 60 minutes using public transport. And the map layer in the background is from the Thunder Forest level set of map tiles. The red lines there are bus routes, and if you zoom in, it even gives bus numbers. The black lines are train lines. Now, one of the things that's really interesting with this, again, is it's not neat concentric circles, particularly as you get further out. If you are based on where those black train lines go, you can actually get in there, sort of Leamington Spa down to the bottom. You can get from Leamington Spa to Coventry University within about kind of 30 to 45 minutes if you're relatively close to the train station there. Similarly, if you go out to Brighton to the west, and even to sort of some parts of Birmingham to the west there. Now, again, with this, it's giving an idea of where we're looking at particular providers, and if there's ever an issue, say with an FE provider and running into financial difficulties, and we want to assess what is the impact this is likely to have and what overlap there might be with other providers in the local areas and things like this. This very quickly gives us a sense of who is going to be affected by that and where it is reasonable for people to be able to travel from. Again, this is interactive. I can zoom in and zoom out for this. I can do this for lots of different providers. And there's a wide range of different elements that we can kind of pull in across different areas. And all these means where we are having to make a lot of these kind of difficult and interesting operational decisions, we can pull informative information in a way where people are self-serving rather than commissioning a mapping team to go and do this, or different elements around that to be able to answer those questions and really make sure people are being informed in that space. A few final things just to tie up around this. There's also the element within all of these where what we've been able to do is bookmark this. So you've set up your parameters for what you want to do with the map and things like that. Actually, there's then a very simple option which just goes and writes the configuration and the options you set up on that map back as a small file to the SQL server that we've got, and then gives you a customized link. And if you then put that link into an email and send it to anyone else within the organization, they click on that link and they see your exact map. No big, basically attachments that you need to add on to this, nothing else that you need to kind of faff around, just a nice short web link in an email and they get what you see. And also they can continue to edit it and do their variant of it going forward with that. And again, that's really powerful for people not having to rework what they're doing with the different elements that are going on. There is also an element where we developed a house style around things. So the element with sort of the sidebar across the top and the information on the top, we've reused that for a lot of apps. And actually there's so much of the time when we get a specific commission where we need to set things up, and we've had a few of these recently where literally we've had sort of 1 to 2 weeks to set up an app to really drive a lot of what we need to do with managing elements, where we can use the format that we've already got set up, use the skeleton that we've already got set up, and actually build the rest on there. Again, in terms of thinking about neat functionality and things like that, I like the way that we can customize different elements. So down the left-hand side here, you can see that we've got those nice big breakout buttons for guidance, for the webinar that tells you about the tool, for being able to leave feedback and things like that. They all feel distinct and look distinct from the other elements of the tool, that they draw your eye across that. And even with the stuff in the top left, the welcome, the school tab, the trust tab, the exception report, got different little icons about those. They're all little things that draw your eye in. And the ability to do kind of the nested menu options that we've got here. So on this one up here, we've got sort of the local authority element ticked, and that gives you a few more options. Avoids you just having this long scroll of different options in that space there. And that helps with people moving through intuitively. And by having this relatively common design that we use within here, it makes it far easier for people to be able to move from one element to another app without having to relearn things from scratch. So final bit, and then I will start going through some of the questions that we've got up here. Other stuff we like about this. We find the apps load really fast because within the RS Connect server, you can run multiple instances. So the first time the app boots up, you can then get another 10, 15 people onto that same thing. So it just loads up like that rather than doing a big data load. The apps themselves can also have customizable URLs. So it's rsconnect/migrate app or something like that around that, rather than going back to Power BI before, and I do like it, that thing where the Power BI link is like 3 lines of text long. And again, that's a nice, neat thing for people understanding what they were doing. We can control secure access using AD groups. We can monitor the overall level of usage that we've got. And we also do use our markdown reports a huge amount in terms of the reporting we're doing. And we find them very, very powerful in terms of doing that. So that's my kind of whiz through about why I'm basically an R-Shiny fanboy. I know there have been some questions in this, so I will dive in and start getting with a few of those and steal your thunder, Laura.
What have we got? Tom asks, what is the name of the API that gives you the travel times?
I will quickly, it's gone off the top of my head, but what I will do is I will answer that in the message box while the next presentation is on. Sure. And it was originally a German company and then it got bought out, so that's why it's gone from my head.
Okay, Jeremy asks, have you or do you plan to share any of this with local councils? It could be really helpful for planning class numbers, school capacity, and even planning COVID-safe routes, bus services to get children to school.
So there is more that we're starting to share in this space through the View Your Education data portal that we've got set up, where we share things back through to local authorities. So we are trying to set more of that up in that space at the moment. At the moment, one of the things with our RS Connect setup is it's an internal only setup that we've got here. So these apps can't immediately be shared externally. But as I say, through the VIAD portal that we've got, we are starting to share more through those.
Okay, a question from Owen. What resources would you recommend for further learning in Shiny, such as mentioned before, HTML, JS, CSS?
Yeah. So in terms of different elements around this, I have to say there's a lot of really good tutorials on the RStudio website, and I think they are a very, very good place to start in terms of working through there. And that's certainly what we've done with what we've done with getting a range of different people up to speed around there. So that's been our principal start point on that.
Matt asks, for access management with AD groups, do you use Shiny Proxy?
No, we don't use Shiny Proxy around there. I'm trying to remember exactly what we do use for that. Chris Dice, who I can see is on the call and answering questions, may be able to answer that one for me on that. But I'll try and get the detail on that and drop it in the message.
Sure. Stuart asks, with 100 developers, what technologies are you leveraging a lot with Shiny?
So within that, what we're finding within there is that it is a lot around sort of Shiny components that we're using there. So we haven't actually done a huge amount specifically using Shiny Dashboard or Flex Dashboard within there. There are a number of packages that we kind of come and lever quite a lot. I mean, inevitably, there's a lot that we use from kind of the Tidyverse packages in terms of data management and data running through there. There were a few points earlier on talking about the fact that actually knowledge of kind of CSS and JavaScript and things like that can be quite transformational when you want to go to sort of the nth degree of basically customization of apps. And I would agree with that, and we have done that. But what I quite like in terms of what we can develop through this is the element of basically being able to have almost sort of a core set of functions and a core approach that we've got to be able to set up a lot of these apps, so that when you're standing something up, it's almost kind of like 70 to 80% of what you actually want to do in terms of the layout, in terms of the various ways that we would probably use click-through functionality, in terms of how you're linking through to the SQL server and different elements like that. It's stuff you can just reuse from an app that already exists, and then very much focus on how we change things and move things around. And then that helps with the familiarity of staff moving from one app to another.
Great, thank you. I think that's all the questions. Faisal just said that was the best R Shiny pitch I've ever seen. Great presentation, Dave. So that was brilliant. Thank you very much.
Thanks all very much.
Okay, so next up we have Steve and Samir from NHBC. So Steve and Samir, if you're there, if you could unmute yourselves and share your screen. Steve and Samir are presenting practical experience with insurance pricing in R. And I know you guys wanted me to launch a poll at some point, so just let me know when you want me to do that. And I think I'll need to read the results to you, but yeah, just give me a nudge and I'll do that for you.
Good afternoon. Good afternoon. Yes, it's Steve Marriott speaking here. I'm here with my colleague Samir Khimani, and absolutely right. We're going to talk through our experiences of, well, from my side at least, complete novices knowing very little about R through to us implementing our actuarial pricing modeling into R. So it's been an interesting journey. So a lot of what we're going to talk about is a bit of a scene set, and then give you some of the things we think are going to go, you know, be potentially problematic, and then talk you through what actually ended up being a bit more problematic, and finally finishing off with a bit of a demo. So all sorts going on in the presentation, less technical apart from the demo at the end, and obviously got a bit of an act to follow. So obviously a good talk for the previous one. So moving on then. One second, I'm just not clicking forward. So a bit about NHBC as an organisation. It's been around since the 1930s, and it's got approximately 1,000 employees. And principally, the main goal, as the slide suggesting, is to make sure that homeowners, when they buy a home, get a good product, a good quality product. We're not builders ourselves, but we help the building industry deliver that. And we do that in two different ways. Firstly, we're sort of helping the builder in the sense that we set out standards to which they should be building. And then we have many inspectors across the country that will then actually go out to sites and visit while they're building to see if it seems they are indeed sticking to those standards. Hopefully all being well, everything goes fine and we've got a happy customer, but on occasion that doesn't quite work out. And we have a situation like this where someone's got a substandard home. Hopefully the builder will be able to help out directly themselves, but where not, we step in, because as well as doing the front-facing piece, we're also an insurance company and we offer a 10-year warranty for homeowners. So when you move into a new house, you'll get this warranty, which you can then call upon for repairs. So that's a bit about us. So I thought it'd be a bit of fun, and also because I've never been to Earl before, get a bit of a sense about you. Obviously, if I was there in person, I'd do a bit of this, or even a bit of that, but neither of those. So instead, we'll have to do it virtually. So quick poll. Let's see if this works. I haven't done this before either, so it's another first. So see if you see if the poll can pop up now, and just get an idea of which sector you're in, because I'm hoping you give me the right answer.
Okay, I've just started the poll. Can you see the results of the poll?
Oh, sorry.
If not, I can read them out to you.
So I'm not sure they'll be able to, but if everyone can click, so if everyone clicks by now, and then we'll.
Yep, there's all the votes.
See what happens. See what happens. First for us all.
We've got a majority of government and insurance, 21% each of those, 4% pharma, 6% retail, 5% utilities, 6% marketing, 21% insurance, like I said, 5% finance, and 33% other.
Ah, there you go then. There you go. So that's good news, because we were very concerned that it's all going to be insurance folk, in which case the next few slides will be less interesting because they've probably seen it before. So moving on to what is an actuary. That's a bit of a funny one. So we've got this slide to get the typical response to that. Oops, no sound. That'll teach us for being flash. But effectively what they're saying there, haven't got the foggiest. So there's the subtext, and so that effectively is what we're getting when we introduce ourselves as actuaries. The other one is, are you an actor? Is the obvious one. And for those who've got a bit of an idea about vaguely what we do, you sort of get this vision of a sort of grey old person sitting away in some little room somewhere. But in reality, things are very different from that. In terms of our sort of profile, it's probably not that dissimilar to data scientists now. In terms of the male female mix, it's very close to 50% in terms of the students that are coming through. And in terms of, we've got about 50% of our membership that are overseas members, and surprisingly enough, most of the members are, way under 40. So in terms of, the typical profile of one of those people, very sort of high caliber student, either doing maths or actuarial at a degree level, and then to become a qualified actuary, you've got to do a series of exams beyond that, and that can run to sort of 6-7 years of examination. The outcome is a highly skilled individual, obviously very suited to the insurance environment in which we live. So very much a sort of insurance focus in terms of what we do. There are other strands, but that's the principal one. It's a very rewarding career, both in terms of obviously the monetary side, but also just in content. Again, it's a similar flavour to around data science. And if you looked at our sort of strap lines, it very much you could label that as data science as well with an insurance specialism. So that's a bit about us. So how do we live and how do we work within an insurance context? We're very much at the top table. So I'm talking about NHBC here, but it could be equally of many insurance companies. NHBC itself has been around from, again, 1930s, turned to an insurance company in 1970s. And so all through that time, we hold, the actuarial department hold the keys to the the finances of the company. And what I mean by that is, if you think about insurance companies, what we're doing is sort of effectively selling promises. And so, because we don't know what claims we're going to get, we just got to get a best view. And if something happens, we'll have to then pay the money. And the actuarial department, the team that actually does the calculations, looks at the past data to actually come up with that assessment of how much we should charge for one of our homes on risk in our case, but for other insurance policies if it's in a different context. In addition, we also hold the keys to how much money there needs to be in the bank for NHBC, because clearly once we've got all these homes out there that we've got a warranty on, 10-year warranty, they add up to be quite a few homes covered, and we've got to make sure we've got enough money there to pay the bills. So in terms of day-to-day, what does it look like? A bit like you guys, a lot of number crunching, lots of data preparation, and getting the house in order in terms of the calculations themselves. Then, but it doesn't stop there, because it's so high profile, it's influencing the pricing of homes we're going to be insuring tomorrow or the day after or the next week, that sort of thing. We've got to make sure that we don't just turn the handle on the data and assume what happened back then is going to be carrying on going forward. So we need to have a lot of dialogue with other teams in the department, in the organisation, in order to come up with a collective view of what things are going to look like going forward, and then we enrich our data to actually have to reflect the future as well as what's actually baked into it as a starting point. Given our high profile in the organisation, and clearly from the diagram there, we're feeding into the board and the CFO directly. We've got to make sure that what we put out there is indeed we're happy to stand by. So a lot of our time is also spending just reassessing and making sure we have made the right call. Again, similar to your side, there could potentially be different ways of doing things, and it's making sure that we're happy with the way we currently are doing. So a lot of self-checking, and then we have the difficult part sometimes of having to share the results. Ditto again in terms of some similarities. We have to sort of explain quite complicated modelling to an audience that isn't necessarily, right in the deep of that sort of thing. And sometimes we have to be the bearer of bad news in terms of, ouch, the premiums need to go up because, if things have changed, or similarly, we need to have more money in the bank. So sometimes we're having to be giving, the bad news across to those that don't want to hear it. Also, we've got to be aware that people really pour over the work we do, both within those meetings and beyond. It's not unusual for peer reviewing actuaries to come across and look and lift every stone on our work to make sure that the steps we've taken is logical and that they're comfortable that it's a reasonable approach to take.
So yeah, what are we modelling? As Steve mentioned earlier, we've been around for a while. We started writing insurance in the 70s. So we have a bunch of data we can use for modelling. We're taking the past insurance sales and the corresponding claims, and after some manipulation, some cleaning and the rest of it, we're putting it through a predictive model. Off the back of that, we're getting out the anticipated insurance sales, and then finally the projected claims. In terms of the data, we have some exposure information, so our explanatory variables here, things like the building type, the number of bedrooms, and the builder experience. Things we're trying to look at is if there's going to be a claim or not, and if there is a claim, how much that claim is going to cost us. So there's a couple of things with our modelling that we're, in terms of our approach, we're looking to go for a regression approach when it comes to whether a claim is made or not, as opposed to classification, because we understand that each policy has a baseline propensity to claim. So that makes the GLM quite suitable for our task. For those less familiar with the GLM or generalized linear model, essentially we're taking standard linear regression and we're applying it to different distributions. It's a standard modeling approach in insurance for a little while now, and only now we're starting to move towards additional data science techniques. In our GLM, we're using one to predict the likelihood of each peril, and then another for the severity of it. So our NHBC product, it's got quite a few sections of cover. The first section is insolvency cover. So if a builder were to go bust in the process of building a home, we refund the policyholder their deposit. Another section is where the builder is liable for a small period of the warranty. And finally, the larger period of the warranty is where we're liable. and we split that out into multiple heads of damage. So we end up with a multitude of GLNs here, and kind of summing the expected losses from each of these together gives us our risk premium. In terms of modeling software, because GLNs have been around for so long, there's a multitude of modeling platforms out there as well. So they've been developed specifically for the fitting of GLNs within insurance and then deploying the resulting price changes, although they can be used outside of insurance too. So many of these have hard-coded methods within them. So R gives us the added benefit of flexibility over some of these platforms. And in addition to that, these have high initial setup fees and yearly licensing fees sometimes. So using R kind of allows us to escape that. In addition to that, when you're using these modeling packages, quite often they can appear as a bit of a black box. Whereas when you're using R, you can go through the algorithm itself in more detail and appreciate what these softwares are doing. So yeah, over to you, Steve.
Cheers. Yes. So that's sort of the end of the scene set. A bit of a tricky link at the top there for those who are old enough or interested, that sort of thing. I was going to say something else there. So in terms of the you know, when we're setting out on this journey to go R, this in terms of what on a page what things look like is this. So the delivery, we're clear on exactly what we wanted to get in terms of the modelling itself. There's no ambiguity there. We're also actually subject to a very tight timeline because we're sort of dropping it into an established sort of process within the organisation. Ourselves, obviously, advanced domain knowledge both through our studies previously, but also on the job. So clearly we know the nuts and bolts we're handling. And in terms of sort of the base modelling skills, absolutely, that's, you know, that's our bag too. But there is a caveat to that. In terms of the R side, that's sort of new to the department, new to the organisation, apart from Samir himself. So really, it was fresh ground in terms of just going down the R route. But we're sort of doing other coding and things like that, so we're familiar with coding in principle. And as I've outlined earlier, really, you know, what's possibly a bit unusual is that the spotlight's all over us on this, in terms of making sure, A, the results are coming out is decent and sort of aligned with previous results and subject to sort of scrutiny at that level. But equally, under the bonnet, we're going to have people prodding and poking to make sure that, you know, it does stand up. And if it doesn't, you know, it's going to be brought out for everyone to see. So really, you need to do a good job all the way through. We're also, from an actuarial point of view, you know, sort of held up against high professional standards that we need ourselves to apply doing this sort of work. So that's the sort of scene set. And so having had that, and obviously it's a bit of an arse there, what kept us up at night right at the beginning of the project then? Non-delivery. You probably could have guessed that one. If we didn't deliver, we'd be in big trouble. My head particularly was on the block. Resourcing. Yeah, with only Samir and the team with our experience, again, big issue. We need to tackle that. Wider buy-in, as Samir outlined in his earlier slide, the normal route in insurance context would be to be buying one of these off-the-shelf packages and probably get consultancy support alongside from those who are providing it. Whereas we're sort of going a bit off-piste here. It's increasingly norm to do that, but it is still a bit off-piste. So we'll sort of unsettle a little bit those above us to make sure that it's the right thing to do. So we need to keep the stakeholders with us all through this journey. And as I've outlined, we've got to do it in a way that really does stack up all the way through. So given that, how do we approach it? From the start, we wanted the shiny interface. Two reasons for that. One is to sort of make up for the sort of the lack of in-house R knowledge directly. And so we wanted the ability for the modelers to sort of actually do the modeling, even if they didn't know they are. The second one is, you know, given the iterative nature of these sort of model fitting exercises, which I'm sure you guys are familiar in your roles, it's actually more efficient to have a UI interface to actually enable you to sort of do that iterative approach to the model fitting. So we wanted it from both those perspectives. We also were keen to have the back-end code working in isolation whenever we needed to. So we weren't reliant on the combo. We could just run it in the code if we had to. And that actually proved to be very useful, as we'll potentially sort of hear later on in the slide pack. Also, having the back end actually makes up for one of the drawbacks of the proprietary software, in the sense that you can actually, it's very transparent. So if on the shiny front face and you're playing with that bit, if it's not clear exactly what it's doing, you can go and look at the code to actually make sure that you really do understand what it's doing. Interleaving the model logging within code. So what I mean by that is, from the very start, we're very keen from the sort of audit point of view and actually from efficiency point of view to be able to as we were modeling and doing a model, we could park it with a logging number and then come back to it if we needed to. This helps with the audit trail, but also if you want to sort of resurrect a model you did in the past and bring it back to the fore, you can do so without having to sort of go through all the same steps again. And as you probably can imagine, partly because that's why we're here presenting, but also given the lack of internal resource and the time scale, very important to have external support. So we engaged Mango to help us with this project.
Yeah, so learning the hard way. I'm sure I've had a couple of messages saying I'm quite quiet, so I'm going to try to speak up. Maybe lift my laptop a little bit for the mic. Hopefully that'll help. I'm not sure what else I can do there. For our journey, learning the hard way, some of our lessons along the way include the need for specialist support when it comes to IT. So a lot of our laptops around the company are for very different use to what we want to use them for. So as soon as we started to use R and play around with R, things like RAM upgrades followed shortly after. The other thing is the criticality of package selection. So kind of using the standard GLM packages available, they didn't really help us with our task. A lot of them would fall over. So we ended up using Microsoft Client R and the Rebase Scale R packages there, and they gave us the quickest runtimes. And IT supported our effort here as well, with making those softwares available for all of us. We found also with multiple people trying to access the same packages, it was necessary to set up controls around that. So people can not only access the same version of the package, but are using the same packages to carry out similar tasks. As mentioned earlier a little bit as well, the way we structure our data set, in some of these models we're using around 50 million rows. This led to us exploring the best ways to model these data sets and eventually establishing a machine learning server, which is great for us. And then when it comes to Shiny, we severely underestimated the time taken to develop a Shiny app. The back-end code was up and running so fast, it was great. But with wiring up the front end and the debugging that comes with it, it was a large job, so I think we'd assign more time to that in the future. Also interfacing with SQL. With our local laptops at the time, we couldn't quite use the standard ADBC and DBI packages to get into our SQL server and bring that data in. For memory issues, we had to have a bit of a workaround for that. And the other thing with SQL is knowing when to draw the line for data manipulation. So ideally, we'd have all of our data manipulation in SQL. Some of it just made more sense for us when we were coding it to do it in R. But kind of drawing that line is something that we need to work on in the future. Then finally, interfacing with external support. So with consultancies like Mango, we appreciate along the way we could have explained NHPC and our product a little bit better to help us arrive at that final goal. Appreciate we have the domain knowledge and they have the skill set, so kind of working together is something we needed to work on.
Sorry to interrupt, it's Laura. You are really quiet and we're struggling to hear you a bit. Well, a lot.
Yeah. I can try to look into Zoom and the settings there. One moment.
You start off quite clearly and then it just tends to go quite quiet.
Okay.
Sorry to interrupt.
It's okay. Is that any better? Am I staying at a constant level now at all?
A little bit better. I would just say talk a bit louder. That I think that might help. Just a bit closer to the microphone.
Okay. I'll give it a go. So some of the things we're looking to incorporate into our process include Git versioning control. So at the moment we've had one person working on code at any one time. So we've been versioning through more traditional means. However, as we head to a place where we're going to have multiple users accessing multiple areas of the code, we're looking to incorporate GitHub or GitLab into our process. I know plenty of you guys will be laughing at us as to how can we be kind of going about this project without this already. I think it only emphasizes how much we need to move in that direction. And then establishing our coding protocols. us as actuaries, we really love protocol. There's something like protocols allow us to have some control around the setup of the PC and the R environment. So we're looking to establish an NHBC guide to R within our team to help with this. The other thing is the enhancement of the Shiny app. So our Shiny app is finally up and running. However, there are lots of areas where we can decrease runtime and rid of loading redundancies. So it's definitely one from a more immediate time horizon for us. So back to you, Steve.
Well, thank you for battling through that, Samir. I say your sound is in and out, so if you can tweak any settings, that'd be brilliant. But yes, so the question was, so after that journey and the bumps we hit along the way, you know, would we do it again? Is it something that we sort of took too much on or not? And the answer is absolutely. It was spot on in terms of delivery. We got there. We did what we needed. The results flowed, and we had, well, happy customers. 1 second, it's just taking a bit of a lag. So yeah, so in terms of the ultimate delivery, it did do the job. We were able to get to the finishing line. Then in terms of what we've ended up with is obviously, you know, I'm preaching to converted here, but it's a platform now that we're in our gift to adapt. Because we sort of made the decision to split the Shiny from the back end, we can choose to adapt both, or the back end or the front end. So we've got a lot of flexibility about how we want to take things, and we can enhance it over time to do sort of further analyses. As a bit of a side product, we weren't really, obviously, probably could have thought about it, we didn't really think about it, is that the fact we've gone down this journey and people in the team have got much more familiar with R. I'm not saying we're experts yet, but definitely more familiar. It's opened our eyes to what we can quite do with it and with SQL to a certain degree. And so really it's being the catalyst to actually change other analyses and processes within the department to the same platform. State the obvious, and I think Samir mentioned it earlier, if you caught it, which was, you know, clearly we're not saddled with a license fee with R, whereas if we'd gone down on the proprietary routes, we would have done. Yes, we've had some upfront costs to get where we are, but there's no ongoing cost. Having said that, we have chosen to stay linked up with Mango for while we're sort of doing some further development work. The other beauty of this, which again, preaching to converted here, is the fact that we're now in this community. We can sort of share the fruits of it in the sense of the packages that are out there and new developments. So really, we can sort of turn our hand to new analyses quite quickly and stay up to date. So now over to Samir for the demo, and obviously, hopefully most of you what he's showing, but obviously if he can got his issues sorted out, that'd be brilliant.
Yeah, cheers, Steve. I've unticked that the little automatically adjust thing, and turned up my mic volume. So hopefully you guys be able to hear me better.
No, it's still not massively clear.
No. Right.
Do you have any headphones that you could potentially pop in and try?
No, not that will go into this computer. Yeah, I'm not sure what else I can do on this one. This is the last slide though. So maybe do you think I should give it a go, or
give it a go? See if we can. Yeah, everyone turns up their volumes.
Yeah. Yeah, sorry guys. Yeah, this is our demo. So hopefully, luckily most of this is video, but I'll just try to talk through bits of it. So initially you can specify your user on the model name here, or start from an existing model. If you kind of have a baseline setup, then you're able to select your data set over here. On the left-hand side, you have the data dictionary as well as the transformation dictionary. The data dictionary we can use if we have preset data types within our data to help convert those to factors or to numeric. Whereas the transformation side, if you want to fit things like polynomials or log transformations to our data for use in the model, we can specify that there. Then after that, we have a couple of feature selection methods here, one of them being lasso. So this helps us kind of determine some of the most predictive variables in the data set quite quickly. And then we can take that output for use in the area at the bottom where we build the actual GLM. On the left-hand side of this, you can see a GLM family and a link function. You can specify the algorithm too, kind of get that set up for the GLM. Then at the bottom, you've got the schedule area. You can set the GLMs to run straight away or schedule them for later on in the day, for example, after work. So that's really useful for setting up a bunch of models to run at the end of the day. Then we can view our models here. They go from scheduled to fitting to then completed. And the blue indicates that there's no errors there at all, otherwise it'll be red. And then clicking on the arrow, we can view a model summary, all of the kind of key information to do with the models there, p-values, the coefficients, the variables used, as well as where the data set is. And then at the bottom, we have something to analyze the fit. So here we can specify the factor or the numerical variable and look at the actual values versus the expected, as well as some degree of error for the error bars, which you'll see in just a moment. Because we're using the training data set for this example, and it's quite a good fit here. Then we have the option to kind of change the variable to be numeric, and for this we've got quantile scaling and kind of nominal buckets as well. So I try to divide the exposure into equal buckets so we can see the fit of the model over the entirety of the variable. The additional functionality of this graph is we can zoom into certain areas, which is kind of really useful for us to kind of just take a deeper look. And we're able to hover over certain points too, so you know exactly what's being plotted there. So that's it for me. Hopefully that was a bit better. And yeah, back to you, Steve.
Thanks, Samir. Thanks for battling through there. Apologies if you haven't heard that well. Some of you guys out there really do apologise. Not quite sure. It was working fine. We've had a couple of rehearsals earlier and it was absolutely fine. So not quite sure what's happening. But that's it for our presentation there. So hopefully you've got a bit of insight of where we're coming from. Actuaries, it's a different application in the sense we know what we want to do, but we're just converting to R. And obviously you've got a good sense of what we're ending up with in terms of that tool. But there's more to be done on it, but we're obviously liking what we're seeing. All the sort of good presentation gurus say that we should leave you with one thought rather than many, given, you know, throwing lots of stuff at you and it's a conveyor belt of presentations this afternoon. So I'm hoping amongst all the noise distortion, if you remember one thing, you'll remember what to say if you're asked what an actuary is, because at least we can get a few people saying the right answer. That'd be lovely. Anyway, thank you. Any questions?
Thank you so much, Steve and Samir. And oh, sorry, Samir, it has to be one person to have audio problems. It's the thing with these kind of things, you can practice and practice and test, and then you go for a live event and you're like, ugh.
Yeah, I don't know what happened there, sorry.
That's okay, don't worry. We had a couple of questions. I'm not sure if you already answered this one. Someone said, how will you handle the new price walking regulation that will kick in 2021?
So it doesn't actually fortunately apply to us as we understand it. So it's still being looked into, but I don't think that's actually going to cause a problem. But obviously, it's a big issue for the wider industry.
Sorry, I don't know what this person's name is because you've just got it's like your surname, so I don't know what your first name is. So apologies to not refer to you properly. But they also asked, any plans to go beyond GLMs, not just to help the GLM pricing process?
Sorry, you just crackled the last bit again, so my turn now. So just say that again, sorry.
That's all right. Any plans to go beyond GLMs, not just to help the GLM pricing process?
Yeah, no, absolutely. This is our first toe in the water, it really is. And I say, personally, it's sort of really opened my eyes to the power of R. And I'm not just saying that because the audience here really impressed by it. And so I would see us using it in many applications, many analyses, and we're sort of keen to do some of the fancy whizzy stuff that the data sciences are doing more generally. So and within our organisation, there's plenty of opportunity beyond just the direct insurance stuff. So no, it's a first toe in the water. So great times.
They also said, really cool app. Any chance this is open source?
Well, I'll have to speak to the big bosses about that one. So well, I'll have to take that one offline and have a question mark. But obviously, we've invested quite a lot of cash into this one to get us to where we are.
Okay. Vin asks, does pricing model address potential churn? There we go. Got there in the end.
In our case, I say we don't the warranty we offer. There's we don't go out and try and renew it. So after 10 years, that's it for someone who's bought a new house. And so the sort of the thought of trying to sort of keep hold of that particular customer doesn't really apply. So it doesn't directly know. Obviously, in other contexts, it would do.
Okay, we've just got one more question really quickly from Purvi. How do you get everyone learning R at NHBC quickly?
So some of it is, it's one of those things, because like I say, we are coming from not a complete blank page, in the sense that, the people around the table, as I sort of outlined earlier in the slide pack, are clearly people that sort of in this sort of area anyway, in terms of thought process, and, will have done coding of some degree in their either university or studies, and actually in the R syllabus, in the actuarial syllabus now, they are actually teaching R. But my team itself had very little experience apart from Samir. And so how we sort of effectively learnt it, and I'm not claiming we're experts by any means, but how we learnt it is partly by just seeing, what's in front of us in terms of, we know what we wanted. This is how Mango have helped us produce some code to get there. And so one of it was that, but the other side is, once you've got a taste for it, doing your own research, like I'm sure you guys do, you just sort of, it's sort of a lot of it's the same old of just oh yeah, that's how you do it in R. That's it's just a lot of it's about syntax rather than we've got the logic already. So it's that sort of thing. So we haven't had a specific training course or anything like that. And I say we're still relatively early, but we're into it enough to realise how powerful it is.
Brilliant. Thank you very much. There is one more question in the chat. We need to move on to the next presentation. So if Stephen Smith, if you wouldn't mind answering that in the chat while we continue on. Thank you so much for your presentation. That was great. Thank you. Thanks both.
Cheers. Thanks everybody.
Cheers. Okay, so up next we have Joe and Gavin from HMRC, and they'll be presenting on supporting the self-employed during COVID-19. So Gavin and Joe, if you'd like to unmute yourselves and share your screen, and we can get going.
Hello, can you all hear me?
Yep, we can hear you.
I did have my video on, and then my internet connection kind of did a bit of a wobble. So I've just turned it off for the time being, just to make sure that I might give it another go later, but just to ensure that you are able to hear me and see the slides. So thank you, Laura. As you said, my name is Joe Fallon, and I'm joined by my colleague, Gav. We are both data scientists within HMRC, so that's the UK Tax Authority, and we're kind of based in their central IT function. So today, we're going to be presenting on work we've done fairly recently around supporting the self-employed during COVID-19. Oh, I'm not doing very well here. Okay. So, COVID-19 has had a huge impact on everyone's lives. And part of the UK's response has been to launch a number of different financial support packages. So probably, most famous is around furlough. So that's the coronavirus job retention scheme. So that's all around salaried staff. But there is also what we talk about today, the self-employment income support scheme, and that's there to provide support to the self-employed. So it's there. There's kind of two aspects. There are eligibility criteria that people have to meet, and then when they're met, the amount of grant that you get depends on your kind of historic trading profits. So it's all using data that we get in normally through the tax system to look at what people's previous profits were, to then determine what level of grant that they can then receive. So it's having to use the data that we already get in a very different way. Our role was to kind of bring together lots of different data, various different places, bring it together and work out who is eligible, what the grant will be. And we had to do this in a very short amount of time. So, this is a very big project. And I think we've been paying out somewhere in the region so far of £7 billion to over 2 million people. But we had to develop the process in around about 6 weeks. So very short time frames, very high profile project. We really had to make sure that the calculations were robust. Along the way, we kind of use a lot of the principles behind reproducible analytical pipelines. And that's a phrase and a term that you hear a lot about in government, but I'm not really sure anywhere else really uses it. But the ideas when it's using, I'm sure will be familiar to everyone. But it's just about, in everything you do, trying to reduce the number of manual steps. Trying to create a pipeline. Trying to have everything in code where it can just run. And when you run it, you kind of know that when you run it again, you're going to get the same result out. So, this slide is very much just the same things that I've talked through on the previous one. So, Gav, do you want to take this one?
Yeah, so this is the directive for CEs. So the Chancellor announced the scheme on the 26th of March and then said that he wanted people to sort of get the payments before the end of May, which is where that 6 weeks came in to the the sort of the pipeline we needed to get it done from a statement on a press conference to development of policy to development of analysis to delivering and paying things into people's bank accounts in 6 weeks. So the directive is basically the thing that the Chancellor signs to say this has now become law. This is with the Coronavirus Act. The Treasury can direct HMRC, and when the Chancellor signs it, that becomes law. And that's how these schemes have very quickly been able to deliver the things that were required. The problem with this, and this has written in what the eligibility criteria are and how we define it. And the criteria is basically that you were earning £50,000 or less, and your self-employment income is greater than all your other relevant income, either in the latest year, which at that time was 2018-19, or averaged over the 3 years from 16-17 to 18-19. So if you passed one of those criteria, you were eligible. And then we calculated the grant awards. You probably can't see it here, but it sort of shows you that section B is how we then calculate the grant award. For Cs 1, it was 80% of your average trading profit over the 3 years delivered for 3 months, basically. And then for the second one, that became 70%. And we've recently had the extensions have been announced, so that will now be going on at least until April. But when we actually designed this thing, this directive didn't exist. So no one actually knew what it was we needed to do. Also, the Chancellor mentioned a couple of things at that conference, at that press conference, which made things a little bit more difficult. He said that any amendment to a tax return after the 26th of March would not be accepted. And also he said that HMRC would contact people and tell them that they were eligible. So that meant that the usual systems that we use to look at sort of self-assessment, the analytical data warehouses that we use, look at historical tax returns, and they only keep the most recent version of it, so the most up to date for each year, because people amend it throughout the year for various reasons. People get it wrong and they send amendments. So our analytical systems don't necessarily have the entire history; they only have a latest view. And our main analytical warehouse only updates on a monthly basis, because this is an annual return. It's not like these are monthly returns. So that we normally analyze in that sort of way, but this scheme requires something very, very different, which it requires an accurate picture of the self-employed population at a particular moment in time. So that's very different from what we normally do. So what we had to do is we needed to work with our IT partners to work out, to define and extract the data needed to calculate the individual's eligibility at that particular moment of time on the 26th of March. And we worked very well with our sort of partners and defined it and got the data. But the problem was that because the policy wasn't even defined and completely in flux, you couldn't really define anything. So just to give one example, in the original policy sort of discussions, it was decided that losses, so people's losses would be zeroed. So instead of being a loss, it just go down as a zero. And so that's fine. But then someone changed their mind and said that, well, that disadvantaged people who may have had a loss one year, and that would have then brought their things down. So it was then required that actually we're going to take into account losses, but then we've already had a data delivery with all this thing zeroed. So we need to go back, get a redelivery. But also, when something like that happens, the whole definition of the criteria changes, because the way they were defining whether you were eligible was a ratio of your self-employment income to your total income. And if that was greater than 0.5, then you were going to be eligible. But as soon as you allow negative numbers in there, that doesn't quite work. So you can have negative numbers divided by negative numbers. And we had to point this out to the people who were writing the policy, that now people who you may not want to be getting this could get it because of the way it's now been defined. So the way that the directive is written in the end reflects the fact that we sort of had to point out that it wasn't necessarily going to work. So if we just go on to the next slide. So what was our role in this process? What did we do and what did we do in R? So our role was to maintain and manage this database of eligibility of these 5 million sort of customers, who was eligible and how much they would be awarded. And so what we had to do is, well, our first thing was we had to take all this raw data, all this raw input that was coming from a number of different HMRC systems, depending on, was that from the 26th of March, or do we have to roll that database back so that we can get the position at that? So we're getting a huge range of inputs from a number of different sources. So then we needed to standardize that input and then pass it through this eligibility pipeline that would then take these people and calculate their eligibility and their trading profit. Then also we realized as we were going through it, the system needed to be able to make amends to these returns, because it turns out that our data is not 100% accurate. So as people begin to query their claims, it turns out that some of them our data is just slightly incorrect. So we needed a mechanism that we could replace the incorrect data and replace it with new stuff. And then we then needed to deliver those outputs in standardized forms, because we then needed to feed the actual digital services that were doing the eligibility check-in and we're doing the pay-in. And then some other teams in HMRC's IT functions were designing and building those services at the same time as we were building this checker. And we needed, so what we were basically doing is taking data in a really raw sort of formatting it, producing this pipeline and then sending it on. How did we do this? So if we look at this, we split the thing into a number of different components, and I took the bit of dealing with the inputs. So it was my view to, get the data however it came, make sure that it was standardized, make sure it went in. Also took control of taking in what's called the designatory data. That's everyone's sort of contact details, because remember, the chancellors also said that we're going to contact these people. So we need to get, data that can be used to contact them via various media. And then I developed the pipeline that then created the model. And what we did is we knew that we were getting so many redeliveries that we needed to do it in such a way that we could link the raw data feeds that we were getting to particular, updates into the database. And that turned out to be very useful, as we'll come on to later. And that's where my bit ended, and then Joe took over from there. So I'll just hand over to Joe.
Yeah, so, results of Gavin's pipeline was a database containing the kind of whether people were eligible and what the level of the grant would be. And on my side, it was then a case of taking that and preparing the files in the very specific format needed for the digital service. So that's the actual website where people who are applying log in, and also going through various different sources of designatory data to find the best way to proactively contact people to encourage them to come and apply. Also, Matt in the team, amongst other things, he made a Shiny app, and that was really great because it was a way of taking the data set, but displaying the data in a way which is very easy to see. So when we did have queries coming in, when we needed to see what had been going on, it was very helpful to be able to look up what the data was actually saying in a way which was very easily visually digested. And that was something which initially was only designed for our own team's benefit, but increasingly other teams found it an incredibly useful way of looking at the data. And just kind of saying that everything in kind of our team's side of things, so the things which are on the slide here, this is all done and powered through R. So then on the next slide, so as you see, it was quite a complicated project. We were getting lots of deliveries of data, different cuts of data, when we find out that we needed something else because things changed in the policy, or we identified areas where we needed improved data. We were getting lots and lots of different data sets sent to us. And we were really making this model whilst the policy was being developed. And we did have this very short time scale needed. So we thought for the next few slides, what we would talk about is, what different approaches that we found useful. These are probably things that you've all heard of, probably all doing, but which aspects of data science, which little features in R, and which kind of bits of project management, particularly from Agile, did we actually find really helpful in this 6-week period. So I think I hand back over to Gavin for this slide.
Yes, so some of the approaches that we did find extremely useful. So data lineage, this was the idea that we kept a complete records of every raw data feed that we got. So we ended up basically with an object which had the paths to every feed that we had. And then we then had a sort of set of data sets. We had an interim data set, which is the one where we'd absorbed the raw data into our sort of database. And then the output data was then the processed version that then is what everyone else used to run their things. And that was really useful for a number of reasons. One, in theory, the way it's written, if you did lose everything, you could rerun the whole thing from scratch and wait a little while and you'd be back to exactly where you were, because that's how it was built. It was a function that added everything in as it came. But what really became very useful about it is when the thing went live, and people were querying, well, why is this? I think it's this. There's a number of places where things can go wrong. It could be that, we hold the wrong data and that's just incorrect. It could be that there's a mistake in our thing and that sort of was the reason that it had gone wrong. So it could break in a number of places, but being able to go back and find exactly what raw data it came from allowed us to really find out what was going wrong for people, and then find out where it had gone wrong. We very much worked with defined roles. We carved off sort of logical chunks. So I dealt with input and processing, Joe outputs. Our colleague Chris, who's a data scientist but a former tax professional, looked after the policy, and it was him who was translating that policy for me to write the pipeline. Our boss Adrian was taking that role of sort of going to these meetings with all the different stakeholders and sort of distilling down the important stuff to us, but then allowing us to get on with the work. And then, as Joe said, we and another member of the team, Matt, got sort of drafted in when the work got a bit bigger. But you define the role, you communicate a lot of those interfaces. I'm going to provide data like this. Is that useful? Is that the good format for you? And it allows you to sort of focus and not get overwhelmed by the whole thing. And we found that was very useful. Version control, it's a bit of a no-brainer, but extremely useful. We had to roll code back because of policy changes or incorrect data. Also, originally, remember, I'm working from home when we started this. Well, still working from home, and it was all being done on my Surface Pro. So it was my Surface Pro on my desk in my office, and it was fine to start with. But as we were changing things and rerunning it, it just got too slow. 5 million sort of people. So we worked with our data engineering colleagues to provision it on a cloud, our studio server. And then because it's all backed up by GitLab, redeployed the code. I think we got permission approval at 5 o'clock on the Tuesday night, and by Wednesday morning we were back up and running and rebuilt the database in the cloud. And what was taking me 3 hours to run the update code is now down to half an hour. So you can very quickly respond to changes when you can go at that speed. And also QA, very important, working with tax professionals. They'd work, certain cases and then compare their answers with what was coming out of our model. And, that was our QA. And then I'll hand back to Joe.
Great. And then, I think what we've been saying before, that having pipelines was very important. So, having a series of steps would take us from the raw data as far as possible, keeping everything in code, everything split into logical stages what follow on from each other. And that's kind of highly linked to splitting your code into functions, into small logical steps, which are very, easy to understand, and splitting your, separating out, defining your function from using it in various different scripts. So just a very, that's probably not particularly readable on here. That's not come out very well. But the idea here was just to show you a particular function, which is about adding addresses to data. And that's quite small. It calls other functions, but then you can have a script where you then call it. So you're separating out the definition from using it. And then Matt and the team kind of took this to the logical conclusion by using kind of notebooks in R Markdown. So, these documents are combining your kind of code and your outputs, and on building the document, it runs lots of code. And on here, when running to produce outputs, you've got in the document what the inputs were, the results of various checks, various MI results, and then it tells you, the path and the name of the outputs. So that then you've got this document what nicely describes, how you went from the inputs to the outputs, and that producing that document is the exact same thing as producing the outputs itself. So can through that quite quickly. I think Gav, you're taking this one.
Yeah. So these are just a couple of our tips and tricks that were extremely helpful in doing this work. So when this started up, we didn't have a database, so we used SQLite, which is a sort of file-based database engine for people who don't know it, but it stores it on disk, and then you can query it as if it was a database. So you don't have the problems with reading everything necessarily into memory, because, you know, we were working with 5 million individuals with 3 years tax returns data. So the biggest table we're talking about is, you know, 15 million rows with quite a lot of variables. Then when we redeployed to the cloud, we stuck with this solution because we didn't have time to do anything else. But hopefully with the pause between the C's and then the C's extension, we're going to hopefully replace the SQLite database with an actual database in the cloud. And hopefully, because of the way we've written our codes using dbplyr and dplyr, it should just be a back-end change and the code will run on a database instead of from SQLite. And then this other thing is just really sort of quite important, is because we were, again, working from home, we wanted to keep network traffic to an absolute minimum as we were doing this. R's ability to deal with zip files and zip archives and only pull out the bits it needs allows you to keep your network traffic as small as possible. So that was just, you know, we couldn't have done it without it, because the amount of time for you to expanded things that it would have taken. And similarly, because we're dealing with all this raw data, we did do quite a bit with command line tools, sort of like grep, which will search for, you know, records in raw files, or zip grep, which will do the same, but on a zip sort of archive. And that was, again, when we got these queries, it was like, well, where was the original data? And then we could follow the journey through. So that, yeah.
Yeah. And then, you know, these things are probably familiar to most of you in the audience, but we used a lot of the tidyverse in the project through particularly the dplyr package. You know, and one thing what was particularly useful was the scoped versions of mutate. So for those of you not familiar, mutate is a function in dplyr which is all about, you know, transforming a column. Now imagine you have lots of different transformations you want to apply to a whole series of columns. Well, imagine you have a transformation you want to apply to a whole series of columns. These scoped versions of mutate mean that you don't have to just write lots and lots of very similar lines. You can write things very efficiently. In older versions of dplyr, these were known as mutate at, mutate if, mutate all, but now you use the across function. So I'll just quickly skip through these, but the example at the top is just converting all columns in your data frame to character. The second example is just taking, you can specify a list of columns, but in this case it's saying take all columns which start with, where the column name starts with the word petal and times them by 10. And the bottom one is running a test. So it's saying, look at all the columns, identify the ones which are numeric, and just for those columns, times them all by 100. So that might be converting things from pounds to pence. And then in this slide, you know, also we made heavy use of anti-joins and semi-joins. So the idea of so these are all about joins. So you have two data frames, and an anti-join is saying that from data frame 1, you know, we only want to keep the rows which don't appear in data frame 2, and the semi-join is about saying, you know, in data frame 1 we only want to keep the rows that also appear in data frame 2. And the nice thing about the semi-join is, you know, you could do something similar using an inner join, but with a semi-join you guarantee that you're not going to get any duplications of the rows in data frame 1. And they're also, you know, there's something which after you've used them for a while, they become very intuitive, and they become quite a very nice way to work. So I think we filled up a lot of our time, so we should probably leave it there. We might have time just for 1 or 2 questions.
Great, thank you very much, Joe and Gavin. If someone types really quickly, we'll have time for 1 question. Stuart asks, does anyone know what software Off-Call used?
I've got no idea.
Tim asks, do you think that using R allowed you to hit a deadline, and it couldn't have been done otherwise?
I'd probably say yes. I don't know what you think, Gavin, but you know, part of that, we do, you know, we also know R very well. It's something that we kind of use daily anyway, but you know, I think a lot of the things like the mutates and the being able to you know, access things from within zip archives really cut down the amount of time it took to do things.
Yeah, definitely. Without that sort of being able to use the archive stuff, it would have been very, very difficult.
Okay, great. Thank you so much for your presentation, guys. That was fantastic.
Okay, thank you.
Cheers. Thanks a lot. Okay, wow, we are bang on time today. I'm very impressed. So we started off the day with a keynote from Annarita from Zurich, and then we're going to wrap up the day with another fantastic keynote from Max Kuhn, who is a software engineer at R Studio. And we're really delighted that Max can join us this afternoon. I'm not sure what time it is for you, Max, probably a lot earlier.
It's about 11.
11, there we are, this morning. So yeah, I'm going to stop talking and hand over to Max. So Max, whenever you're ready.
Great, thanks. I'm going to leave my video on, but please, if it's lagging, post something in the chat. I want you to know it's my dog snoring in the background and not me. Let me share my screen. All right, so I'm going to talk about a set of packages called the Tidy Models packages. So I'm a software engineer at R Studio in the Tidyverse group. Somebody asked Hadley one time, like, what is Max doing? And he said, modeling. And they said, oh, what kind of modeling? And they said, all of it. So my group, myself and the group that I have are involved with you know, making it easier to do modeling inside of R. So that's what this talk is going to be about. Some of the tools that we have that you could use to analyze data. And if you choose to develop your own modeling packages, we also have some tools for that. Okay. So, you know, I maybe don't have to convince you, you're at an R conference, but, you know, maybe why to use R for modeling. You know, there's just a lot there. It's probably the largest modeling library or capability out there. You know, Crane is up to about 16 or over 16,000 packages this month. We have a lot of really old models, a lot of cutting edge models. It's a wealth of resources inside R for modeling of various types. One of the problems in R is one of consistency. So for example, mostly consistency of interfaces. So if you think about when we build models, a lot of times when we specify the model, we could think of using the formula method to choose what our outcomes are, what our predictors are, and so on. But not all packages have that. Some packages only have the formula method. Some packages only have like the XY interface, and you really sometimes never know what you're going to get when you start looking at a new package. There's things like, you know, which packages use sparse matrices or which use dummy variables and which don't. And something I'll talk about towards the end, hopefully I think we'll have time, is I think there's a lot of people building R packages maybe based on postdocs or dissertations and things like that. And they're built by people who weren't like native R users to begin with. So they may not be aware of things like, you know, object-oriented programming, like making a predict method and so on. And they may have never heard of the formula method. So, you know, we want to maybe address the problems of consistency and maybe, as you'll see at the end, give people tools to make R packages that sort of are consistent with the conventions that we would use. So here's a good example. If you've seen my talks before, you've probably seen this slide. Here are various ways to get class probability predictions from different models. You know, most of them use the predict method, but, you know, one of them doesn't. They have their own custom predict function name. And then as an example, you know, what is the value of type? Sometimes it's response, sometimes it's prob or posterior or probability. And so, a lot of times it's very frustrating that if you would like to use more than one modeling method, and I think most of us would, we have a lot of time with what I call syntactical minutia, that, different package developers have different thoughts on, what these argument names should be called or what the interface should be. And so, if you're doing a lot of modeling, this could be very frustrating for you. So that's sort of like between package inconsistency. And then I'm going to pick on unfortunately, pick on one particular package in terms of inconsistency within a package. And so if you've ever heard of the GlimNet model, it's a way to fit generalized linear models, which includes logistic regression, linear regression, using regularization. So it can do two types of penalties, regularization methods. One's like the lasso or L1 penalty. And then the other method is ridge regression or wake decay, otherwise known as the L2 penalty. And so when you fit a GlimNet model, what's cool about it is this penalty is a tuning parameter where you probably want to look at different values of a tuning parameter to figure out what the best values are for your particular data set. But one really cool thing about it is when you fit that particular model, you don't have to tell them up front what the value is of the tuning parameter. So in the package, they refer to the parameters lambda. That's mostly because of the papers that have been written. We'll come back to that name in a minute. But the really nice thing about GlimNet is you can take one model fit and get prediction off of almost any or probably any values of lambda that you're interested in. So what I'm going to do is I'm going to fit a couple different GlimNet models here and only show you the results for 3 different values of lambda and see how the format of the output changes depending on the data and the type of predictions you're getting. So the cool thing is, again, to reiterate, when you run the predict method, you get predictions across many different versions of lambda. So start off with a basic linear regression. We have 2 samples that we're predicting. We build our model, and when we use the predict method, we get a numerical prediction back. And you can see the results here are matrix. The sample names are encoded in the row names. The column names are sort of obfuscating what's really going on here. Basically, S0, S1, and S2 correspond to the 3 lambda values that I gave it, but it doesn't tell you what those are. And you sort of go in faith and probably double check that these are in the order, numerical sorted order. And so if you're working with this, you might want to make plots of these data. So you might want to merge in the actual lambda values and maybe stack them so that you have, one column of predictions and so on. So, you can work with this. It's maybe not the optimal format, but, it's doable. So let's switch to a binary classification model. So if we have some other model with 2 classes and we go to make predictions, we want to get the hard class predictions. We still get a matrix back. It's a character matrix this time. And that's a little frustrating because typically with R, we would store these data as a factor. And in fact, the input instructions for GlimNet is that the outcome has to be a factor, but it gives you the predictions back as a character matrix. And you can do the same thing. You can unstack this, you can convert these to factor, you can substitute in the lambda values. And again, it's another thing to do, but it's not exactly difficult to do technically. So what happens if we take this model and want to get class probability predictions? So we'll change this, instead of type equal class, we'll change it to type equal response. And then what we get back there is we get the probability from the second factor level outcome. So again, we'd have to unstack this. If we want to get both probabilities, you do the 1 minus, we add in the lambda values. Again, no biggie, but it's different code for different models. But then what happens if we have 3 classes or 4 classes? Does this change at all? So I fit a 3-class model, same thing, type equal response. And now what I get is a 3-dimensional array. And it gives me all the probabilities back. So, at this point, you might reach your level of frustration that now, for the same model, you have to have 4 different sets of prediction code, depending on what you're doing and what the dimension of the data are. And, at this point, not to pick on the package too much, but at this point, you might be wondering, am I working for GlimNet or is it working for me? And so, in the tidyverse, we've thought quite a bit about maybe good ways of storing and working with data. And, just maybe like a tidier structure would work, where in this particular case, we have, we might have a column for sample number, but, we have columns for all the probabilities, and then a column from lambda and so on. So it's a little more explicit. And if we could make this standardized, it would be a lot easier to work with a package like this. And it's a marvelous model. We use this model all the time, but we can be a little bit stymied by the actual implementation of this particular model. So anyway, that's an example of sort of within package inconsistencies that we sometimes have to work with within R. This is not a new problem. In like 2005 is when I worked on Carrot. There's multiple infrastructures in R, like MLR or Carrot, that try to tackle this problem of inconsistency. So it's a workable problem using third-party packages. So, if we're doing like just one-off data analysis, or, I used to work with a lot of chemists, and their answer to every question was random forest, no matter what the question was. But assuming you're trying different models, you might want to work across different models and have to deal with this this inconsistency of interface and return values and things like that. So really, we have like two challenges, for me at least, for a software developer working in R, is how do we sort of harmonize the interfaces of all the packages that are existing? So this is like a retrospective problem, is how do we make the existing packages work together and work for you relatively seamlessly? And then the perspective problem is, how can we help new R users or new R package developers from maybe avoiding some of these problems, to have a more unified interface and help them, without making them software engineers, help them develop good packages. So we'll talk about both of these problems in turn. So I'm assuming maybe you've heard of the tidyverse. It's an opinionated collection of packages that sort of obey the same very opinionated design principles. We have these sort of principles when we design packages. The one I'd probably emphasize the most is designing for humans, which means, let's give people interfaces that they can understand and are intuitive to use, and so on. And so, for example, like typically when we come up with packages that have a series of functions that have a similar scope or focus, we typically name them with the package name. So like in the glue package, almost all the functions that users use start with glue. So it makes it a little easier to tab, complete, and find them, and so on. So I'll be basically talking about how we apply the tidyverse to modeling. So we have the Tidy Models collection of packages. It's a little over 20 of them now. And again, they live in the tidyverse and they use the same ideas and syntax as the tidyverse. We have a few additional sort of goals that we are looking at, is we really want to encourage good methodology and empirical validation, and basically like level up everybody's statistical tools compared to what they're used to. And the example I usually use in this particular instance is like stepwise regression. I mean, we know stepwise isn't really what we should be doing. We've read all the papers probably and heard about it, the talks, and seen the blog posts, but then there's the question of like, what do I do? And so, what we want to do is we want to enable people to have better tools so that they're not maybe going with the software that they have, but maybe the software that they should be using. So we want to, for example, enable wider range of methodologies and so on. So again, I'll start with the retrospective aspects of tidy models, about how we sort of harmonize the usage of existing packages, and then talk to you about the prospective issues. So, there's I think 23 packages. Of course, we're in hex stickers. So, this is currently the stable of packages that are on CRAN that are in the repository. If you're interested in learning more, tidymodels.org, and we just started a book, Julie, Silvia, and I, Tidy Modeling with R. Let me see if I can go to those tabs. So for example, the website, we've spent a lot of time on the website. It's excellent. I would encourage you, if you're new to this, to look at the Getting Started page. There's a series of tutorials. There's a variety of different articles about different things you can do in case studies and so on. So that's really nice. The book is coming along. We have like the first 11 chapters sort of in the can, and it's about, I'd say maybe about halfway done, and that's with Julie, Sergey, and I. So those are good resources if you're interested in. If you've read we wrote a book in 2013 called Applied Predictive Modeling, and I just started working on sort of a tidy models companion to that, but it maybe be a month or two before that's online. So I'm not going to stay on this slide too much. These are the main packages that you would typically interact with tidy models. You maybe have heard of Broom. We're not going to look at that too much today, but Broom's really nice. It'll take objects like data analysis objects you have and convert them into formats that you would probably want to use. So for example, if you want to get the GLIMnet coefficients back, it gives you like a big sparse matrix. And so Broom, for example, will turn that into a tidy data frame and format in a way that you might want to get back. So you'll see these packages in just a few minutes if you've never seen them before. There's a sort of meta package. So if you load the tidy models package, there's some developed versions here because I was doing some work this morning and rebuilt the slides. All the notes here work with the current CRAN versions. But what tidy models package does is it loads up what we consider the core tidy models packages like RSample or Tune and things like that. It also loads a few tidyverse packages that we use quite a bit, ggplot2, dplyr, and so on. And so this is typically what I load. There's also a package called model data that we load that has some example data sets. And what I'll do is for 5 or 10 slides, look at a particular regression data set. It's the daily ridership of the Chicago elevated trains. And so what it does is a data set from 2001 to 2016. There's about 5,600 data points, and they're daily measurements of how many people entered the Clark and Lake Station in Chicago. And so what we want to do is we want to try to predict that. The predictors, like the columns in the data set, would be the date, the day of that measurement. There's some data on the weather. There's a couple of sports teams that play in Chicago, so we have indicator variables for their home game schedules. And then, there's a lot of other stations. So since this is more of a time series problem, what we did is we did like 14-day lags of the other stations and the station that we're trying to predict. That would be a typical way you would model these data. So if you were trying to predict 14 days in the future, the data we'd have available when we built the model would be like a lag 14. And so these station data columns, I think there's 20 of them, are basically the ridership at the other stations 14 days prior. So they're numeric data. They're also highly correlated. So you can think of like if many people are riding the train on station A, there's also in a correlated way more people riding at station B and so on. So there tends to be like most of these stations are at least like 90% correlated with one another, and that'll feature in or factor into some of the analyses that we'll walk through. So those are our predictors, like, or those were our columns in the data set. So, when question is like, what are our features? And so the difference between those two would be like how we have the raw data and then how do we encode them for a model. And so a good example of that is the date variable. So we can just add in, the date column and give that to a modeling method like LM or something, and that would convert that to like an integer, which is like the reference point to some, or it's like the number of days in some reference date. But there's different ways to encode that. So the fancy term for this would be feature engineering. Is how can we take, let's say, date and encode that or add it to our data matrix in ways that make it easy for models to consume that column. And so we do know from this data set that there's a big difference in ridership during the week versus on the weekends. And so we might want to think about different taking date in changing it into different columns that we can put in our data matrix to maximize performance. And so the recipes package is sort of a mashup of like model.matrix and the tidyverse like dplyr. And it's a way to sequentially define a series of pre-processing or feature engineering steps that you can use on your data before putting it into a model. And so there's a bunch of different ways you can specify the recipe. We'll just start off by using the formula method, which says, in this data set, the column for ridership is the outcome and everything else is a predictor. And then, as you'll see, we'll define a series of data pre-processing steps that go into the recipe. So, as I said, date's important. So the first thing we can do is use an operation called step date. What that does is you tell it which column to use, and from that date variable, it can derive features like what year was it, what month was it. And it can also create a factor column for day of the week. So there's, Monday, Tuesday, Wednesday, it's a factor with 7 levels. So that would be like an expansion of columns by adding more features based on date. Another important aspect of these data are that people generally don't ride the train as much on holidays. So for example, step holiday for, and you can give it which date or which holidays you're interested in. There's, different countries' holidays. What it will do is we'll take the holidays that you give it, make indicator variables for, Christmas, or in the US, Thanksgiving, or the 4th of July, and so on. So this will basically expand date to include holiday binary variables. And so now that we've created these 2 features for date, we probably don't want to include date as a predictor. So we can remove the date from the data set. We can eliminate it from the data matrix that's given to the model. Another thing we could do is we could convert it to an ID variable that's not used as a predictor, and that would also keep it in the data set, but just it wouldn't be given to a model. But I've just chosen to remove it here. Another thing we might do is, since the day of the week is a factor variable, we might want to convert that to dummy variables. We know that many modeling packages require numeric predictors. Model.matrix and most R packages, not all of them, would automatically make a factor predictor into dummy variables. Recipes do not, because there's sometimes you don't want to do it, so we don't default to that. So one thing you could do is you could say step dummy, and then use a selector here. So I didn't mention that, when we add these variables, they could be like any dplyr select. You could have date, comma, starts with, or matches, and things like that. So in all these steps, when you specify the variables, you can use the common dplyr selectors, but recipes has some extra ones. All nominal would capture any columns in the data that are either character or factor. There's all numeric and so on. So in this particular case, I believe the only factor column is the day of the week. And so what this would do is it would do the standard indicator variable encoding to produce 6 indicator variables for the day of the week factor. And so we might want to give this this data set to a model that requires, let's say, that the predictors are on the same scale. So if you're fitting a neural network or support vector machine, these steps I've shown you are mostly feature engineering steps. We could also do some pre-processing that is required by the model. And so what we can do is something like step normalize, which will center and scale the variables that you've selected. So we also have another selector called all predictors, and that will, as you might imagine, select all the predictors of any type that are in the data. Now I could have put like all predictors, comma, minus all nominal, in case I still had a predictor in the data set that was factor. So again, you can use the standard dplyr selectors here. So, this demonstrates with recipes how you can do both feature engineering, pre-processing. Between recipes and sort of the add-on packages for recipes, there's probably like 100 different steps. So some other examples of the steps you could do, I'll show you in a second. I mentioned there's some station data that have the 14-day lags. I mentioned they're highly correlated. You might want to do a PCA feature extraction. So you can select, this is a character string or a character vector of the station names. So from this, you could say, for these particular columns, convert them to principal components and give me 10 components. So those would be used in place of the station data. You can do something more fancy. There's a package called embed that has sort of a nonlinear version of PCA called UMAP. So you could use UMAP here. You can use it as a supervised feature selection or feature extraction routine, where if you give it the outcome, the UMAP scores that it will give you would have a correlation to the outcome and so on. There are steps like if you want to include a spline function. So for example, if you know that there's a nonlinear relationship with the outcome in one of your predictors, you could do like a natural spline and tell it how many degrees of freedom. Another example of something you might want to do is, let's say, temperature here is in Fahrenheit. There's also a general step mutate. So if you want to convert that to Celsius, you can just put in this, this mutate, and that will be used across any time the data are processed with the recipe. So I'm not going to go into a whole lot of detail about operationally how we use recipes. You'll see it in a second. But basically, this recipe would be processed on the training set. And then any data that you use, whether you put it in a model or make predictions, these same steps will be applied to that particular data to give you a data matrix that's consistent across different data sets. So what we might do is we might think about putting these data in a model. So, let's do something simple. Let's use like linear regression. The parsing package is one that sort of enables a unified interface with tidy models. And the way it works is you specify the type of model and then the software engine that you would use to fit it. And that might be like a package name. So for example, we could start off by saying we want to fit a linear regression model. Basically, all that does is declare that we're fitting a model where the outcome is numeric. The model equations are basically slopes and intercepts for the predictors. Other examples of sort of structural types of models would be like a nearest neighbor model, or a random forest, or decision tree. And so once we specify sort of like the format of the model or the structure of the model, then we can use this function called setEngine that says, well, how should we fit the model? Like what package or whatever should we use? And so for linear regression, we have like a variety of options. We could do, LM, which would be fine, I guess, except for in this particular case, we know that the stations are highly correlated. So, multicollinearity is kind of a problem with this data set. So maybe that's not our first choice. We could also fit it using TensorFlow. So there's a Keras engine that would use, the Keras deep learning library to fit linear regression. If there's a really big data set, we could use Spark. We have, our Spark support in tidy models is not 100%. You can definitely use it with parsnip and other things, but it is an engine here. You might decide to do a Bayesian model. So instead of doing like ordinary least squares, you could use Stan instead. So this would basically set up a Bayesian linear regression, do that type of estimation. You can set priors and all sorts of aspects of the Bayesian fit. But the one we'll go with, because we've already mentioned it, would be GlimNet. And the nice thing about GlimNet is it has, I mentioned it has these regularization methods like L1 and L2 regularization. And both of those are pretty good at dealing with predictors that have a high degree of correlation between them. So this would help mediate the problem of these stations being so related to one another. So we'll start off with a linear model. We'll fit it with GlimNet and use the recipe that we had previously to define the data matrix. GlimNet has two different training parameters. So I already mentioned the amount of regularization. So in the R package, it's called lambda. We tend to not want to use really jargony names for arguments. So, if you haven't read those books or papers and somebody said, oh, what was your version of lambda? It might not be obvious to you what that means. And so what we've decided to do is represent these arguments with more or less jargony names, and also names that can be used across different models. So if you're doing like weight decay in a neural network, we don't call that argument weight decay. We also call it penalty, because it's the same thing, just with a different, different packages use different argument names. So we try to harmonize the names and so on. So we'll use, a fair amount of regularization here. The mixture here is the percentage or the proportion of the L1 lasso penalty. So this is like a 50-50 mixture of ridge regression and lasso regression. And so at this point, we fully specified our model. So let's fit this thing. So one thing that makes it a little bit easier to work with is we have this thing that is not technically a pipeline. It wouldn't be a pipeline if you're using scikit-learn or Spark maybe. We call it a workflow because we tend to think of a pipeline in R as being like a dplyr pipeline. So what you would do is you would start a new workflow object, and then you can add a parsnip model to it. And then you can add, how the data should come in. We're going to add our recipe to this workflow. You could add it using a formula, or if you just wanted to give it the raw variables, you could do that. You have a bunch of different choices. But the nice thing about a workflow is it bundles these things together. So if you've tried out multiple recipes on multiple models and you find one combination you like, but they're sitting in different parts of your environment, you may have trouble remembering which one worked best with which. So one good thing about a workflow is it bundles them together, and you can just keep track of them better. Another thing is it makes the steps to fitting and predicting the model very easy. So the fit function here will process the recipe, save all the recipe information, hand that data off to, in this case, GlimNet, and do the model fit. And then prediction is just as easy as you would expect. It applies the recipe to the new data and gives it to the appropriate prediction function. We give you the data back in a tidy format. Even though we're giving you a one numeric column, we always return a tibble in our results. So, one guarantee with Parsnip is the column names are always reproducible and predictable. The results will always be a tibble where the data are ordered in the same way that you gave it to it. So you can just do a bind calls to the predictions here if you want to merge it in with the original data. And another, maybe you've never encountered this, but another thing that I've had to deal with over the years is there's some modeling packages that default how they handle missing values. So for example, if in the first 7 rows of the Chicago data here, let's say there's a missing value in one of the predictors, there are some, let's say one row had a missing value. There are some modeling packages that would just give you the complete records back. So they give you 6 values back instead of 7. And then it's kind of your problem to figure out, well, wait, how do I match that up with my original data? I know there's, you have to figure out where the missing values were and then pad them into the results. And if you've ever had to deal with that, it's not a fun time. So regardless of what the underlying model does, we always return to you the same number of data points that were given to the prediction function. So if row number 2 had a missing value, this would just be NA instead of just being missing. And that's again, maybe not the most prevalent issue, but when you've encountered it, it's very memorable. So we definitely want to code against that. So in this case, what we've done is we've defined how we want to pre-process our data, encapsulate that into a recipe. We've specified a model that we like, particularly the GlimNet model, and fit that and did some predictions and so on. With the GlimNet model, I specified the tuning parameter values, and it could be that maybe very little regularization is better here, or it could be that it likes, lasso more than ridge regression. So we might want to optimize these parameters. So, that's model tuning. And so one question is well, how would I do that with tidy models? So the answer to that is you can go back to your model definition. And then in place of giving the actual values for these parameters, you can put in a placeholder called tune. And this function tune just returns an expression that says tune, but it's sort of a placeholder that marks these particular arguments for tuning. And in tidy models, we've set everything up to where if you say, I want to tune the penalty function for GlimNet, the system knows that, oh, we're dealing with a tuning parameter that is non-negative. Its values typically go from 0 to, let's say, 0.1 or 1. We typically would interact with that tuning parameter on the log 10 scale and so on. So we have a lot of information embedded into these packages that know how to handle these tuning parameters. And so by tagging these things or marking them for tuning, it gives the whole system a lot of information as to what should be done with this particular model in terms of tuning. You could also tune the recipe. So for example, if you want to tune the number of principal components, there was an argument that said ncomp equal 10, where you could say ncomp equal tune, and also have it tune the pre-processing steps also. So once you've marked whatever you're interested in for tuning, you could update your workflow and replace what the fully specified model was with one that's not fully specified, and then we can find better values for those variables. So, one thing we would typically avoid doing is we don't want to like try a penalty value and then to repredict the training set. We know that just repredicting the training set often gives you very optimistic performance estimates. That if we just repredict the same data, it's like giving somebody the same test twice. They already know what the answers are and the questions are, so they tend to do like better at the exam, even though that doesn't mean their knowledge of the particular subject is very good. So, the common way of dealing with that is to use, let's say, a validation set or to use resampling. And so when we go to tune models, we're going to use resampling to do that. You can use a validation set. We just consider that one form of resampling. So examples of resampling would be like tenfold cross-validation or the bootstrap. This is a time series problem. And so we have this thing called rolling origin forecasting, which is a way to sequentially make time series splits of your data. And the R sample package has a really nice function for doing that called sliding period. What you would do is you would give it the data set that you want to resample, a variable for which variable is the date that you want to look at. And then you define like the units of resampling. And we'll do things in months here. We have like 16 years worth of data. So what we'll do is we'll use the first 14 years as our training sets. So in the first resample, we take the first 14 years of data, and that's what we'll fit a model on. And then what we'll do is this argument says we'll make predictions on the next month of data. So the first resample here, the data that's used to fit the model has about, a little over 5,000 data points. And then the data we use to evaluate the model is the next 28 days. So this was February. And then the next resample does the same thing, but it shifts over a month. And so, we have the same amount of data or almost the same amount of data in the next modeling data set. And then the subsequent month is used for prediction and so on. And that gives us, this particular configuration gives us 19 resamples. So if we try, let's say like 10 different GlimNet models, we would fit or evaluate this model across all 19 of these data sets, get 19 sets of, let's say, root mean squared errors. And so that's what basically grid search would do. So if we combine this resampling object with grid search, we have a function in the tune package called tune grid. It's very simple. You just give it the workflow you want to optimize, the resampling scheme that you want to use. And then you could give it the particular penalty and mixture values that you're interested in, or you could just let it pick it for you. By default, it does something called a space filling design, which is a type of experimental design that's really good for these types of situations. And what this code would do, it was take all 10 tuning parameter combinations for GlimNet, run them across all 19 data sets. So it gets 190 models that it evaluates and then computes, all the root mean squared errors and things it needs to tell you what performance should be. So one thing that we do, similar to Carrot, is we use the for each package for parallel processing. So if you wanted to run all these in parallel, you could do that. I'm using a Mac, and so on Mac and Unix, you can use the doMC package to tell it how to, run these on all the cores that you have. If you're on Windows, there's do parallel, do future. There's a variety of different technologies you could use for parallel processing. As long as you register one before you do the tuning bit here, they'll run in parallel. And that can give you very substantial speed ups for these particular models. So the result of this is all the information about how our performance of these models related to the tuning parameters. And so we probably want to pick like a penalty value and a mixture value that, let's say, reduce the root mean squared error. And so just to give you an example, there's a function called show best that says, give me the models that are best when sorted by root mean squared error, which should be small. And the results show you that there's a variety of different configurations of this model that will give you about the same performance. Some of them have a really low amount regularization. Some have, moderate amounts, different mixture values. So you can pick and choose what you want. There's an autoplot method that will show you a nice graph of how these things change over the parameters and so on. So, so I'm going to kind of gloss over what the syntax of how you would maybe complete this model. I'm just trying to give you a sense here of like how tidy models works. We have a lot of like high level accessor functions then when you want to get the actual metrics, you can get them using collect metrics, and autoplot will plot them and so on. So, for this model, maybe the next steps, if you really like this model, you could, choose the best parameters, update your workflow so those tune values aren't there. You could pick the best values and sort of substitute them inside the workflow. And then you could, we have high-level functions for fitting the final model and measuring the test set and so on. And so, that gives you a sense of like how we've tried to standardize the modeling process for existing packages. So we try to give you very consistent APIs with consistent return values and very consistent and understandable argument names. And that's what we do for existing packages. So what I'd like to do is take the next few minutes and talk about what we'd like to do for prospective packages. So if you're thinking about designing a modeling package, whether it's an inferential model or a predictive model, we have some tools that might be able to help you. So about 2 years ago, we wrote a tentative set of guidelines we had for making good modeling packages, and then showed that to the community and got some feedback. You can see the website here. Mostly there's some tidyverse type stuff in there, but the biggest improvements I think we get from these guidelines are just the idea of separating the two interfaces. So if you're writing your dissertation, maybe you spent like 3 years coming up the most like elegant and efficient code for doing some sort of fancy neural network or whatever, and you have like the interface to your computational code. And I think what's been lost on people is that maybe that's not the interface that you give to users. So, a lot of times that will put constraints on what the data should be like. So for example, like that computational code might expect a matrix, but typically we don't keep our data in a matrix format. Like when we get it out of a database, we don't encode the outcome as 0 and 1. It's typically, some description of what the outcome is, maybe in a factor variable. So instead of constraining the users from having the format that we want on our computational code, we want to have better user interfaces that are easier to use, and interfaces that make you not hate the package, right? So you want to use this package, man, it's a pain in the butt to use because everything's geared for the computational aspects of things. And so, based on a lot of experience that we have over, R and in my case, S, I've been around for a while, to separate out the user-facing interface from the computational interface. I think once we do that, we can still get all the great efficiency of computing that we want that make the packages much easier to use. And so we have this package called Hardhat, which is designed to help you make new modeling packages. There's a demo here I gave at a conference that shows how to make a package in 9 steps, which sounds like I'm trying to sell cars or something like that. But it's a nice demonstration of walking through how you would use Hardhat. I'm going to show you what it does in a second with a little code demo. What I'll do is I'll load the package. And the idea behind Hardhat is you have this function that you've spent a lot of time writing that does some sort of model fit. And so when you create a new modeling package using this code, you tell it the name of that function, and then it basically does all the scaffolding around that function. It sets up all the S3 methods for formulas and data frames and matrices. It already pre-builds the man files for you, and basically does all like the R software engineering parts that maybe you don't know how to do. And maybe if you're a modeling expert, you don't need to also be an R expert to create a good R package. And so I started doing some work the other day with a package. I'm currently calling it Lantern. It's based on the Torch machine learning library that we ported over to R recently. And so I just wanted to create a multi-layer perceptron neural network function that I'm going to call Torch MLP. It'll be in the Lantern package. And so let's just use that as an example. I'll run this, and what it's going to do is it's going to create a new directory in my temp directory called Lantern, and that has all the R package files in it. So here's the same code. I'll run this, and a bunch of stuff's going to happen, and then I'll come back and show you exactly what it did. So let me just run that. And then you'll see a bunch of stuff spool by and another window pop open, which I'll come back to. So what it initially does is it sets up, a description file. It creates an R directory. It gives you placeholders. It tells you the functions you could use to choose a license and so on. This is very much influenced by the uses package, which is very nice. It sets up your namespace file, creates an RStudio project, and all the things you would want to use, like, R build ignore and git ignore and so on. It updates the description file with some required packages like hard hat and recipes and stats. And then basically it sets up the skeleton that you would need to create a modeling fitting function as well as a prediction function. And then it builds all the documentation for you. So that's what it does on startup. Let me shift over to the package that it creates. And so this is the Lantern R project that it starts. You can see the files it's already built for you. The R files, basically you would come into what we call the fit function here. You can see that there's already R oxygen stuff set up for you. So if you've never used that, it's all kind of pre-built and you can come in here and edit all the documentation. The thing that you would come and do is, here's the implementation function. That is basically where you would enter in all the code you have to fit the model. So instead of this simple placeholder, you would put in all your computational code here that does the model fitting. You can add more arguments. So the predictors are going to come in as predictors and outcome as outcome. And then you can be like, penalty, whatever the extra arguments are, you can add them here. So the focus is, you worry about the computational code that you've worked so hard on, and we've done all the other stuff to make this work for you. Another thing you can do, which I won't go into because I'm about at time, is there's a bunch of validation functions. So you can use hard hat. If you want to make sure that like the data is binary, we have a bunch of convenience functions in here to help you validate data and so on. So it's very, very easy to use. I guess I will stop there in terms of presentation and just at this point say thank you for the invitation. And also that we have a fantastic group at RStudio. Davis and Julie are in the Tiny Models group. They've worked really, really hard on all these packages. Allison and Desiree, who just joined, have done a crazy amount of work, both in training materials, giving us feedback, and working with us to make all this very easy for users to interact with. So that's it.
Cheers. Thanks a lot, Max. That was brilliant. Okay, we'll just leave it a couple of minutes for people to type some questions if they've got questions. I think a couple of people said they were confused by you having your console on the top right.
Well, that's the being the token Yank here, that's how over the pond we do things. No, that's how I have it set up. Sorry.
Lots of messages saying thank you, great talk, brilliant talk, thanks, applause, superb talk, Max, thanks. Just lots of praise, Max.
Tell us something about your dog. You probably hear her gently waffling back there. If you want to know more about my dog, I tweeted about her this morning, and you can see what she was like this morning. She's very into sleep. What's your dog's favorite art package? Anything that involves food. Lantern, I'll make it probably public in like a couple weeks. And it works really well. I should say, like, it's not public, but it's worked great. Daniel in our is one of the main RStudio Torch developers. So, I've basically written my version. He's going to come in after me and fix all the stuff that I should have understood how to use. It's nice. Like, we like reticulating TensorFlow one nice thing about Torch is that it's all C++ code in the back end. So there's no connecting the Python, which is fine. I mean, we use Keras and it works really well. But, you know, for example, if you want to, parallel process with an R, in TensorFlow, that's all GPU oriented. You could also do that with Torch, but the nice thing about how Torch is built into this R package is it works like any other C++ package. So if you have 20 cores on your CPU, not your GPU, and you're going to resample like a neural network, you can do that all in parallel with Lantern, and you couldn't necessarily do it that way with Keras. With Keras, you'd have to parallelize over the GPU, which works really well, but in some cases where like resampling is the big computational bottleneck, you'd rather parallelize the resampling and not the individual models. So there's some really nice things about using it that should streamline things. There's a question on Carrot. Carrot was great. Could it be hard to know when you're asking to do too much? Will tuning models help people judge tuning workload? I guess when you say do too much, you mean computationally do too much. So assuming I have that right, yeah, I mean, with grid search kind of works very similar to how Carrot works. We have better logging. So, you know, if you want to, you know, start grid search and the first model that you start to evaluate takes like, you know, half an hour, that would tell you that, oh, you know, I should cancel out of here. Another thing that I didn't really get into, but I could show, well, maybe I won't show it because it would take a few minutes, is we have a lot of sequential optimization tools that we're adding, like Bayesian optimization and simulated annealing. And so what those would do is, you know, grid search, you have to say up front what models you want to evaluate. What iterative search methods would do is they would try to infer or predict what a better tuning parameter value would be. So it's, in some cases, what they're doing is they're making predictions like in a meta model that predicts, oh, you should try penalty equal to 0.001 and a mixture of, you know, 0. And so those will sequentially operate. And the nice thing about those is if you cancel them, if you hit like escape and get out, you don't lose it all. So you could either set them to run for like an hour, or you could run them and just hit escape when you're happy and still retain all the progress that you've gotten to date. So we're a little bit more easier to work with in terms of you know, things that are going to take way longer than you expected. Yeah. Roadmap for tiny models. You know, it's geez, what would be next? So right now we've spent a lot of time on fixing or improving user feedback that we've gotten. So for example, like, let's say there's some obscure random forest argument that you want to tune that really isn't like a main argument to our functions. You know, we knew we were always going to want to do that, but it wasn't really set up. So for example, we have things set up now where I think we've made that really easy to do. So you don't have to write a lot of custom code at this point. We're expanding some of the modeling parts beyond predictive modeling. So I have a package that hopefully will be released before the end of the year that does like multi-level models, like mixed models and hierarchical Bayesian models. We are doing things like, this is a little more invasive and take a little bit longer, but incorporating survival analysis methods. So, so one thing we did was we put out a survey on Twitter to see like what things people are most interested in. And for example, like model stacking, you know, it's not my favorite thing in the world, but model stacking was something that people are like, yeah, we want that. And so we have a new package called Stacks that that will do that one of our interns worked on this summer. So you know, we're not doing really revolutionary things right now with tiny models. We're just like filling in the blanks of things that people are like, oh yeah, you know, this is kind of a pain to use, or, you know, how would I do this type of model? And that's going to keep us occupied for quite a bit. I have some things cooking, like in the skunk works. I don't really want to talk about them because then that's expectations, but you know, there's a lot of stuff that we're working on. And I think in tiny models, there's like a project page where if you want to see what we're currently thinking about, non sort of skunk works projects, you could go there and look at it. Book, yeah, we're juggling a lot of stuff. So I'm hoping the book will be finished in like 3 or 4 months. So the tuning chapters maybe will be done before the end of the year, most likely. And then the rest of the chapters, we need to sort of define what there's going to be. I think there'll be case studies, there'll be chapters on like explainable models and, like models on, or chapters on, let's say, time series specific, or, again, like multi-level model specific. So it's a little bit open-ended as to what's going to be in the book right now, but the foundational stuff is maybe a couple months away from getting finished. And you have to stop me from talking. I'll just keep going.
I think we've got one more question from Dean. Can you do stepwise regression with tidy models?
You cannot. So, I mean, yeah, that's great. I mean, it's a great question. Let me give you my answer in a little more explanation. So, I mean, you can expand parsnip models to work with whatever you want. It's not really hard to do that. Tidymodels.org has a whole page on, using your own modeling function or something that we haven't included. We do have to make a lot of choices. And there's a lot of things that I'm conflicted about this, because there's a lot of things that we would not suggest doing. Like, it's not that they're always bad. They might be the solution, but I feel like they might be the solution like 5% of the time. And for me, stepwise sort of falls into that. So if somebody wants to add that to like a parsnip adjacent function, I don't have any, I'm not gonna, don't do that. But it's not, of all the things we're going to spend time on, that's probably not going to rise up to the top of the list. We have a lot of people adding things. Like, there have been a lot of occasions where I've said, we're not going to spend time implementing that, but here's how you would do it. And then people have turned around and done it. And again, we support them and all that. We'll help them any way we can. It's just not like a priority. For example, like binning is something that's near the bottom of my list. And so we wrote sort of like minimal binning code for recipes. And then people have added some supervised binning tools and so on. So, we're always open to other people doing things, but we're not going to prioritize things that we don't like wholeheartedly think is, the best of ideas. So sorry to down talk stepwise. I would much rather people use ClinNet or something else that does regularization. But anyway, yeah.
Okay, great. Thank you very much. Can't speak. Thank you very much for your questions, and thanks again, Max, for keynoting and doing workshops for us earlier in the week. It was really great to have you here today. I'm sure everyone will join me in saying that as well. So that's it. We are finished with VirtuEARL. I just want to say a couple of thank yous. I want to say thank you to all of our workshop hosts, so the Mango team and Colin Fay and Max Kuhn. I want to say thank you to our keynote speakers, again, Max and Annarita earlier this morning, and the rest of our speakers. I think everyone agree with me. The quality has been absolutely fantastic, and I hope everyone has enjoyed the sessions today. The recording of today, I'm hoping, will be available to send out on Monday. I think it's going to be a bit of a monster file to upload to YouTube, so bear with me, but definitely early next week, and I'll try and get the slides out next week as well. What else do I want to say? We're going to see where we are with money-wise, and we'll let everyone know how much we're going to donate to Data for Black Lives. So we'll announce that next week as well. So yeah, I just want to say thank you, everybody. If you've enjoyed today, please share on Twitter. We're at EarlConf for the hashtag VirtuEARL. And then one last thing, if you wouldn't mind turning on your cameras, it'd be great. I could take a picture and share it on social, and it'd be nice to see everyone's face. So if you don't mind. There we go. Oh, nice to see everybody. Okay, take some pictures. Cool. All right. Thanks a lot, everybody. It was really great to see you all, and hopefully we'll see you all again soon. Cheers.